The second chapter in 10th standard is triangles. So in triangles actually we'll be studying about similar triangles in details. So before understanding about similar triangles, we'll understand what are similar figures. Okay. So similar figures. Now consider one square of side 1 centimeter, 1 centimeter, 1 centimeter. Let this be A, B, C, D. So square means all internal angles will be equal to 90 degree. So consider another square PQRS and let the internal angle be square means it is internal angle will be 90 degree. So and let the sides be 1 centimeter, 1 centimeter, 1 centimeter. Now we'll say that first square is congruent to the second square because the corresponding internal angles are equal and also the corresponding sides are equal. Now what about this square here LMNO? Let this side be 2 centimeter, 2 centimeter, 2 centimeter, 2 centimeter. So square means angle will be equal to 90 degree. So what's the relation between the second square and the third square? Here see, if you take the ratio corresponding ratio of the sides. Now I'll take the ratio of this side with this side. Now the ratio of PQ by LM is equal to 1 by 2. Now I'll take the ratio of this side QR with side LM. Now here ratio will be QR by MN. Here ratio is 1 by 2. So here also ratio is 1 by 2, here also ratio is 1 by 2. We should always check the corresponding sides. Okay. Now similarly you can check this side with this side, ratio of this side with this side, and similarly you can check the ratio of this side with this side. Everywhere the ratio will be equal to 1 by 2, 1 by 2, 1 by 2. Okay. Now we will say that the second square is similar to the third square. Square PQRS is similar to LMNO. So if the corresponding angle and the corresponding sides are, if the corresponding angles are equal and the corresponding sides are proportional, only then we'll say they are similar. Now the second square and the third square are similar. Now you consider another example of a circle. This circle has radius 1 centimeter centered at O, and there is another circle centered at A and whose radius is 1 centimeter. Now the first two circles they are congruent because they have equal radius. Even if radius is equal, even circumference also will be equal. And what about the circle shown here? Suppose this circle has a radius 2 centimeter. Now here if you check the radius R1 by R2 is equal to 1 by 2. Also C1 by C2 will be equal to 1 by 2. Here R is radius of this second circle and R2 is radius of third circle, and similarly C1 is radius of second circle, C2 is radius of third circle. So here radius ratio of radius and ratio of circumference will be equal. So we can conclude that the second circle centered at O and third circle centered at B, they are similar. Now I'll give another example of rectangle. Now let the breadth of the triangle be 1 centimeter, and let the length be 2 centimeter. Let this be A, B, C, D. Consider another rectangle P, Q, R, S. Let the breadth be 1 centimeter, 1 centimeter, and length be 2 centimeter, 2 centimeter of the second triangle. Sorry, rectangle means internal angle is equal to 90 degree. So now what is the relation between the first rectangle and the second rectangle? They are congruent because all the angles are equal, corresponding angles are equal. Angle A is equal to angle P, angle B is equal to angle Q, and so on, and the corresponding sides also are equal. So the first rectangle and the second rectangle are congruent. Now what about the third rectangle which I am drawing now? So let this be breadth be let 2 centimeter, and let the length be 4 centimeter. Let this be LMNO. Internal angles will be equal to 90 degree in case of rectangle. So now what's the relation between second rectangle and the third rectangle? So before coming to conclusion, we should check the ratio of the sides. Okay, angles are already equal, we know, but what's the ratio? Now ratio between PQ and LM. What's the ratio between PQ and M? PQ by LM. PQ by LM is equal to 2 by 4, which is equal to 1 by 2. Now what is the ratio of QR? Ratio of QR and ratio of MN. Always we should check the ratio of the corresponding sides only. Now QR by Mn. QR by Mn is equal to 1 by 2. Now you can see here this side ratio we got 1 by 2, and ratio of these two sides also we got 1 by 2. Similarly, if you check the ratio of this side and this side will be 1 by 2, and similarly ratio of this side and this side will be equal to 1 by 2. So what's our conclusion now? The second rectangle is similar to third rectangle. So we can write rectangle PQRS is similar to rectangle LMNO. Now what about another rectangle which I am drawing here now? Let the length be 1 centimeter, 1 centimeter. Sorry, let the breadth be 1 centimeter, 1 centimeter, and let the length be 3 centimeter, 3 centimeter. Now if you compare with the compare with the second rectangle, we can say that they are not similar. Why? Because see now ratio of no, okay, I'll write this one PQRS ABCD. Now I'll write this as EFGH. Now you can see that PS by EH is equal to 1 by 1 is equal to 1. Okay, let me write 1 by 1 itself. Now ratio of PQ by EF. What is ratio of PQ by EF? PQ by EF is equal to 2 by 3. So now you can see this ratio and this ratio is not equal. So my conclusion is that second rectangle and this fourth rectangle, they are not similar. So the criteria for two figures to be similar is their corresponding angles should be equal. So I am writing here criteria. Corresponding angles should be equal. And second is corresponding sides should be proportional. So if these two criteria is matched or satisfying, then we'll say those two figures are similar to one another. Now I'll give some examples in triangles. Now consider one triangle of side, equilateral triangle of side 1 centimeter, 1 centimeter, 1 centimeter. Let this be ABC. Equilateral triangle means all sides will be equal. Also angles will be equal to 60 degree. Now consider another equilateral triangle of side 1 centimeter, 1 centimeter, 1 centimeter. Let this be PQR. So here also equilateral triangle means each angle will be equal to 90 degree. See now triangle ABC and PQR are congruent. Okay, because angles are all internal angles, corresponding angles are equal. Also the corresponding sides are also equal. They are triangle ABC is congruent to triangle PQR. Now consider another triangle, another equilateral triangle. Let this be XYZ. Let this be side be, let this side be 2 centimeter, 2 centimeter, 2 centimeter. Here equilateral triangle means angle will be equal to 60 degree. So now what is the relation between the second triangle and the third triangle, that is triangle PQR and XYZ, triangle XYZ? Now angles are equal, but what about the ratio of this side? Now let me see the ratio of PR by XZ. So now ratio of this side with this is this side with this side is 1 by 2. Now what is the ratio of PQ by XY? So here it is 1 by 2. What is the ratio of QR by YZ? Here also it is 1 by 2. So everywhere we are getting ratio 1 by 2, 1 by 2, 1 by 2. So now we can conclude that triangle PQR is similar to triangle XYZ. So if the corresponding angles are equal and the corresponding sides are proportional, only then we'll say they are similar. Okay, now I'll make a chart. Congruent figures, similar figures. So here corresponding angles, corresponding sides. See in if two figures are congruent, then corresponding angles will be equal. Also the corresponding sides will be equal. I already gave some examples of square, circle, rectangle and triangle. So if corresponding sides and corresponding angles are equal, then those two figures are congruent figures. But if corresponding angles are equal and corresponding sides are proportional, then those two figures will be similar figures. So this applies to any polygon, applies to any polygon. Now there is another interesting factor between congruent figures and similar figures. Now consider one square of side 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter, and consider another square of side 1 centimeter, 1 centimeter, 1 centimeter. Let this be A, B, C, D, P, Q, R, S. Now if I place this square above this square, what will happen? It will exactly coincide. It looks as though only one square is there. Like that it will coincide. The edges will coincide and also the vertex will coincide. Now consider another square of side 2 centimeter, 2 centimeter, 2 centimeter, 2 centimeter. If I place this square here, what happens? It comes like this. Edges will not coincide, also the vertex also will not coincide. Similarly, it applies to other figures also, like circle. Now consider two circle of radius 1 centimeter, 1 centimeter. Now if I place this circle above this, then the edge will coincide exactly. It will coincide. It looks as though only one circle is there. But if I place this circle onto another circle of say let's say let this be radius be 2 centimeter. So if I place this circle here, now it will come like this. So edges will not coincide. So same thing applies to triangle. Now there's take one triangle 1 centimeter, 1 centimeter, 1 centimeter. Take another triangle of 1 centimeter, 1 centimeter, 1 centimeter. Now if you place this triangle here, the edges and vertex will exactly coincide, and it appears as though it is only one rectangle. But if I place this rectangle onto another rectangle of it's 2 centimeter, 2 centimeter, 2 centimeter equilateral triangle, okay. If I place this equilateral triangle onto this above this equilateral triangle, it looks like this. Edges will not coincide, also the vertex will not coincide. Oh, okay, this textbook has come down. So what all? See, you should read textbook by yourself and understand whatever I have taught till now. They are in textbook only. Same thing I have explained to you. You also should try to read maths textbook. You should make a habit of reading maths textbook. In future, it will be very helpful when you are in your higher studies. And if you miss a class, that time you will be able to study by yourself. You should make a practice by now itself. Now similar figures I already explained you. Now see here the picture of Taj Mahal, okay. There are three pictures of Taj Mahal, and these three pictures are similar to one another. They are not congruent. So they are similar means their sides will be proportional. Not only sides, if you take the length of any consider length of this pillar here and length of this pillar, even those things, those measurements also will be proportional. Not only length and breadth of the picture, the measurement within the picture, like this length of the pillar and so on, even those will be proportional. So all these three figures they are similar to one another. Now there's some important lines here. See, two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in the same ratio or proportional. I already explained this to you. Whether it is square, rectangle, quadrilateral or any polygon, they are said to be similar if their corresponding angles are equal and their corresponding sides are proportional, or corresponding sides are in the same ratio. Now there is some activity given here. You can do it by yourself. Now consider this example. There are two quadrilaterals ABCD and PQRS, whether they are similar or not. Now you can see angle D is equal to angle S, both are equal to 85 degree. Now angle C is equal to angle R, both are equal to 70 degree. See the mouse pointer. Angle Q is equal to angle B, both are equal to 100 degree, and angle A is equal to angle P, both are equal to 105 degree. So the corresponding angles are equal. Corresponding angles of quadrilateral ABCD is equal to the corresponding angles of quadrilateral PQRS. Now what about the sides? So let us check. Now AD. What is AD by PS? AD by PS is equal to 2.1 by 4.2. So this turns out to be, if I take the decimal out here, it is 21 by 42. So this is equal to 1 by 2. Similarly, ratio of DC by SR is equal to 2.4 divided by 4.8. This also comes to be 1 by 2. And ratio of CB by RQ, this is equal to 2.5 by 5. So this also comes to be 1 by 2. Now the ratio of AB by PQ, this is 1.5 centimeter by 3 centimeter. This also comes to be 1.2. So the ratio is same. So we can conclude that quadrilateral ABCD is similar to quadrilateral PQRS. So quadrilateral ABCD is similar to quadrilateral PQRS. Now what about the figure given here? Now one is square and one is rectangle. Here in a square all the internal angles is equal to 90 degree, and in a rectangle also all the internal angle is equal to 90 degree. But what about the sides? Sides are not proportional. We can check it out. So in the first side AD by PS, side AD by PS is equal to 3 by 3, right? 3 by 3 means it is 1 by 1. So what about DC by SR? DC by SR is equal to 3 by 3.5. So this is not equal to 1 by 1 or 3 by 3. This is different. So now the ratio is turning out to be different. So it's obvious because this is a rectangle. I mean, one is a square and one is a rectangle. So our conclusion is that they are not proportional. A square and a rectangle can never be similar. Now there is another example here. This is an example of a square and a rhombus. So let me write the diagram. There is a square ABCD. Each side is 2.1 centimeter, 2.1 centimeter, 2.1 centimeter, 2.1 centimeter. So square means internal angles will be equal to equal to 90 degree. So it's understood. So and there is a rhombus and each side is 4.2. This is P, Q, R and S, and this is 4.2, 4.2, 4.2 and 4.2. Now whether these two are similar or not, that's the question. See, in what is the property of rhombus? In rhombus, all these sides are equal and opposite angles are equal. That means this angle is equal to this angle and this angle is equal to this angle. So one pair may be acute angle and another pair of opposite angles may be obtuse angle. Also it can be equal to 90 degree also. All the angles of a rhombus can also be 90 degree also. If not, the one pair of opposite angles will be equal to or acute angles and another pair will be obtuse angles. So this is the property of rhombus. So first check the ratio of the sides. Now AB, what is AB by PQ? AB by PQ is equal to 2.1 by 4.2. This is equal to 1 by 2. Now BC by QR. QR is equal to 2.1 by 4.2 is equal to 1 by 2. So similarly, other ratio also will be equal to 1 by 2 only, because here each side is 2.1, here each side is 4.2. So now my CD by RS will be also equal to 1 by 2, and AD by PS also will be equal to 1 by 2. Now see, the ratio of the sides are constant, but what is the other criteria for these two figures to be similar? Other criteria is corresponding angles should be equal. So here corresponding angles are equal or not, we don't know. Still it is not known. So only if the angles of the rhombus are equal to 90 degree, then we can say these two figures are similar. Otherwise these two figures are not similar. Okay, now we'll solve some problems. Exercise 2.1. Question number 1. Sub-question 1. All circles will be similar. Okay. Now why all circles are similar only? See, circles can be congruent only if radius is same. For example, 1 centimeter, 1 centimeter. Okay. Only such circles are said to be congruent. But if radius are different, then they are similar. Second question, second sub question. All squares are here. All squares are also similar. So what's the reason? See, if two squares are said to be congruent only if sides are equal. But if squares have different sides, then they will be similar to one another. They won't be congruent. So only sides of equal length will be congruent, and all other squares will be similar. Okay, all squares will be similar. Now what is the third question? All dash triangles are similar. So equilateral triangle, this is equilateral triangle. So in an equilateral triangle means a triangle whose sides are equal. Now take this triangle and take another triangle of side 2 centimeter, 2 centimeter, 2 centimeter. Take another triangle of 3 centimeter, 3 centimeter, 3 centimeter. So all these triangles are similar to one another, but which all triangles can be congruent? Congruent triangles are triangles whose sides are equal. Now these two triangles are equal. Similarly, these two triangles of side 2 centimeter, 2 centimeter, 2 centimeter, these two are congruent. These two triangles are congruent, these two triangles are congruent, but the all other triangles where I have written here in the first example, all these triangles are similar. So all equilateral triangles are similar. Next question is fourth question. Two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are proportional. So I already have given some examples in the previous pages. I have given examples of square, triangle, and also rectangle example also I have given. Okay, so when is two square equal, sorry, when is two square are similar? When the sides are equal, like this, sorry, when the sides are proportional. Internal angles are equal but sides are proportional, then we say two squares are similar. Similarly, if internal angles of one triangle is equal to the corresponding internal angles of the another triangle, and if sides are proportional, then they are similar. So I have given already some examples in the previous pages. You can read, check it out. Now question number 2. Give two different examples of pair of similar figures. So similar figures. So two examples. So let me give some real life examples. See, now if you take your photograph and develop that into passport size and stamp size photograph, then those two photographs will be similar to one another. Okay, current photograph of a person developed in stamp size and passport size photos. Passport size photos. So you yourself may have some photos, okay, which are in stamp size and passport size. So those two will be similar. But your childhood photo and your photo taken recently, those two will be non-similar. Okay, you should understand this point. If you take your photograph or photograph of any person at today at the present, and if you develop it into passport size and stamp size photograph, those two photographs will be similar. And let me give another real life example. See, now maps, India map in different size. See, you may have a India map which is which is in such a big size that you can hang it on the wall. Also you can have a India map which is so small that its the size will be almost uh, the size of your textbook page. So uh, those two maps will be similar. India map will be similar. Okay, and let me give some real example of non-similar figures. See, now childhood childhood photo and youth photo of a person, or my photo or your photo. The photo of childhood and photo taken currently right now, the face, hands, legs and all will be different, right? Especially face will not be the same. Our childhood photo and our photo now, our face now and our face in the childhood, definitely it won't be similar. And second example, photograph of two different person, photograph of two different person. So photograph of two different person, each person face will be different from another person. So even though it's a photograph, even though the photo is of stamp size or passport size, uh, the photos are not similar if the photos are of different person. So like this you can give some more examples which you think is right. Question number 3. Question is state whether the following quadrilaterals are similar or not. So quadrilateral 1 is like this: PQRS, PQR and S. All sides are 1.5 centimeter, 1.5 centimeter, 1.5 centimeter. Okay. And there is another quadrilateral. So that is A, B, C, D. So we need to write the dimension and also write the unit also. It's a good habit to write the unit also. If we write just 3, it's not sufficient. Whether it's 3 centimeter, 3 meter, it should be specified. You may lose some marks if you won't specify correctly. 3 centimeter. Now these two are quadrilaterals, and second quadrilateral, the internal angle they are given, it is 90 degree. So this sign itself says that it is 90 degree, but in the first quadrilateral the angle is not known. See, angle S appears to be obtuse, angle R appears to be acute angle, angle P also appears to be acute angle, angle Q appears to be obtuse angle. Or we can put a protractor and check the measurement of the angle, but in the second quadrilateral it's not needed, because already in the figure itself they have mentioned it's 90 degree. Angle A, B, C, D all are 90 degree, but in the first quadrilateral angle is unknown. What about the sides? So when we are sure that angle itself is not, corresponding angles itself is not matching, or corresponding angles itself are not equal, then we can directly conclude that they are not similar. So my conclusion is that it's not similar. the given quadrilateral are not similar. So when angle is not equal, corresponding angles are not equal, there's no point in checking the ratio of the sides. So here even if you check the ratio, it is coming constant. Like for example, PQ by AB, PQ by AB is 1.5 by 3, which is also equal to QR by BC, which is also equal by RS by CD, which is also equal to SP by DA. So everywhere the ratio is 1.5 by 3. Though the ratio is equal, corresponding angles are not equal. So at the first place itself, just by checking the angle itself, we can conclude that these two figures are not similar. Now we'll see what's the next topic in this chapter: similarity of triangles. So this chapter is full of actually similar triangles. See here, there are some sentence. Two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. This applies to a polygon also. Two polygons are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. Now you can read this text. Now I'll go for the next topic. Next topic is basic proportionality theorem. Here it is given as theorem 2.1. They have mentioned as theorem 2.1. Theorem 2.1 is nothing but basic proportionality theorem. What it says: if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Now let me draw the diagram. There's a triangle ADE, so, and according to the theorem, what it says: if a line is drawn parallel to one side of the triangle to intersect the other two sides in distinct points. So a line is drawn parallel. So now considering DE as the reference side, we are drawing one parallel line. So we are drawing a parallel line to DE such that it is going to cut AD, which is extended like this. Okay, AD is extended and AE also is extended, and we are drawing a parallel line such that we are drawing a line parallel to DE such that it intersects the other two sides at distinct points. So let that point be B and C. The other two sides are divided in the same ratio. That means AD by BD is equal to AE by CE. So according to this theorem, if a line is drawn parallel to one side of a triangle such that it intersects the other two sides at distinct points, the points are B and C, then AD by BD is equal to AE by CE. So we need to prove this. So first let me write the given data. So whenever you are proving theorem or some problems, you need to write data properly, otherwise you won't get full marks. Now ADE is a triangle. Now line BC is parallel to D. Okay, line BC is drawn parallel to D, right? So BC intersects AD at B, and BC intersects AE at point C. So this is the given data according to the theorem. So theorem also says that AD by BD is equal to AE by CE, and we need to prove this one. To prove, PROVE. So to prove that AD by BD is equal to AE by CE. So let us first join BE and DC. So that also we need to mention. Whatever changes we do on the diagram, we need to mention it. We'll write, let us join BE and DC. Now we'll draw DM perpendicular to AE. So here I am drawing DM perpendicular to AE or AC, and also draw EN perpendicular to AB. So I'll mention that one. Draw DM perpendicular to AC and EN perpendicular to AB. Now area of triangle ADE. See, in triangle ADE, if we take base as AD, height will be EN. So area of triangle is equal to, see, in general formula of triangle is area of triangle is given by half base into height. Okay, area of triangle is equal to half base into height, right? So in triangle ADE, if I take base as AD, height will be EN. So half base is AD into EN. Similarly, what is the area of triangle? What is the area of triangle BDE? So here also half base into height. Half base is dB into height will be EN. Okay. Now again in triangle ADE, area of triangle ADE is also given by half. See, here in ADE I can also take AE as base. So if I take AE as base, DM will be the height. So area of ADE is given by half base. My base now is AE. AE into height is dm. So also now area of now DEC, area of triangle DEC. Area of triangle is DEC is given by half base into height. So half in triangle DEC, base is, if I take base as EC, if I take base as EC, height will be dm. Now I will mark this as equation 1, this as equation 2, this as equation 3, and this as equation 4. Now if I do 1 by 2, what is equation 1 by equation 2? This is equal to area of ADC. Area of ADC can also be written as area of ADE. Area of ADE divided by area of BDE is equal to, what is area of ADE given in equation 1? That is half AD into EN. So in the denominator, so area of BDE, that is half into dB into EN. So here EN will get cancelled, half also will get cancelled, AD by dB I will get. So AD by dB is the answer. So I will write here AD by dB. Now here I will divide equation 3 by 4. Equation 3 by 4 is equal to, so left hand side area of ADE. So area of AD by area of DEC is equal to half into AE into DM divided by half into EC into DM. So here also DM will get cancelled, half will get cancelled. So area of ADE by area of DEC I will get as AE by EC. AE by EC. I will write this once again. Area of ADE by area of BDE is equal to AD by dB. Here I am getting area of ADE by area of DEC is equal to AE by EC. So this I will mark equation 5, and this I will mark equation 6. Now you check the left hand side of equation 5 and 6. In the left hand side of equation 5, the numerator is area of ADE. See, I am putting a tick there. And in the left hand side of equation 6, in the numerator, it is area of ADE. So here also in the numerator ADE, in equation 5 numerator is ADE, and in equation 6 also in the numerator it is area ADE. So numerator in both equation and 5 in equation 5 and 6 are equal. Now what about the denominator? So in denominator, here in equation 5 area BDE is there. In equation 6 area DEC is there. Now actually area of BDE, area of BDE is equal to area of DEC. Why is? Because see, in triangle see, this is our triangle BDE. I'm writing once again in the main figure whatever it is there, part of that figure I'm redrawing here. Now this is our triangle BDE, and this is our triangle DEC. Okay, these two triangles are between common between two parallel lines. Okay, they are between two parallel lines. So now if we take DE as the base, their height will be common. See, the height of triangle DEB is this one. The height of triangle DEC is this one. Taking DE as the base, so both have equal area. So area of BDE is equal to area of DEC. So we need to write the reason also. Since they are between parallel lines, so therefore in the left hand side of the denominator of the left hand side of the equation 5 and the denominator of the left hand side of equation 6, they are same only. See, area of BDE and area of DEC are same only. So now what the conclusion? The left hand side of equation 5 and the left hand side of equation 6 are same only. So that means therefore equation 5 is equal to equation 6. So this implies AD by DB. AD by DB is equal to AE by EC, and this completes our proof. Here it is DB, and here area of triangle is given by area is equal to half base into height. Area of triangle is half base into height. Since these two are parallel lines, the distance between them is same, therefore the height will be same. Height will be same for triangle BDE and triangle DEC. The height will be same. You can read the explanation given in textbook. If you find it easier, you can go for it, or you can go for my explanation. After this theorem there is some activity. You can read it and try to do it by yourself. Now the next theorem is theorem 2.2. So before going to theorem 2.2, so let us recall what we learnt in basic proportionality theorem. So according to basic proportionality theorem, if a line is drawn parallel to one side of a triangle like this, let this be ADE. So I will draw BC such that it divides AD and AE at B and C. So I am drawing line BC parallel to DE such that it divides AD at B and AE at C. So if we draw like this, then it divides the other two sides proportionally. That means AD by DB is equal to AE by EC. This is what the basic proportionality theorem says. We also proved it. Now, can the converse of this theorem be true? What can be the converse of this theorem? See, here first we drew one parallel line and the other two sides got divided in a definite ratio, which are which are equal to one another. Now what I'll do is I will take this triangle. Now I will draw a line DE. So DE such that AD by DB is equal to AE by EC. So if I draw DE such that AD by DB is equal to AE by EC, then will D be parallel to BC? Will DE parallel to BC? Yes, it can be parallel. So this is what theorem 2.2 says. Theorem 2.2 is converse of basic proportionality theorem. Okay, now we'll prove this theorem. Let me read out the sentence. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So here D is dividing AB and AC such that AD by DB is equal to AE by EC. So if it divides this way, then this line is parallel to third side. That means D is parallel to BC. So diagram I have written here. So I'll write the given data. Given data is ABC is a triangle, then AD by DB is equal to AE by EC. So this is the data according to the theorem itself. Okay, theorem itself says a line divides two sides of a triangle. So D is dividing AB and AC proportionally. So AD by DB is equal to AE by EC. This is the this is the given data. So I'll mark this equation 1. Now what should I prove? To prove that DE is parallel to BC. So I'll write the given data once again. AD by DB is equal to AE by EC. Sorry, I'll mark here 1, not here. Okay. Now still we don't know that DE is parallel to BC and we need to prove it. So first let us assume that D is not parallel to BC. Okay. Let us assume D is not parallel to BC and draw DE dash such that DE dash is parallel to BC. Now I have assumed that D is not parallel to BC and I'll draw DE dash such that DE dash is parallel to BC. Now if DE dash is parallel to BC, then according to basic proportionality theorem, AD by DB should be equal to AE by AE dash by E dash C according to basic proportionality theorem. According to basic proportionality theorem. Now I'll mark this as equation 2. Now you check equation 1 and 2. In equation 1 and 2, the left hand side is same. The left hand side of equation 1 is AD by dB, and the left hand side of equation 2 is AD by dB. So if left hand side is equal, right hand side should also be equal. So that also I'll write left hand side LHS of 1 and 2 are equal. Therefore right hand side should also be equal. So what is the right hand side of 1? AE by EC. What is the right hand side of equation 2? That is AE dash by E dash C. Now I'll mark this as equation 3. Now I'll add 1 to both sides of equation 3. Add 1 to both sides of equation 3. So if I add, what will come? AE by EC plus 1 is equal to AE dash by E dash C plus 1. Now AE plus EC plus, here LCM will be EC. So EC, so here EC by EC will come. So in the right hand side, AE dash by E dash C plus E dash C by E dash C. Here LCM is E dash C. So now in the left hand side, EC will be common. EC is common. So in the numerator, AE plus EC. So in the right hand side, E dash C, and in the numerator, AE dash plus E dash C. Now AE plus EC is equal to, now check the diagram. So AE plus EC will be equal to AC. Numerator is AC, denominator is EC. Now in the right hand side, again check the diagram. You can see that AE dash plus E dash C is equal to AC. So AC by E dash C. Now I'll mark this as equation 4. Now in equation you can observe one thing, that numerator is same. Okay, in equation 4 numerator is AC. So if numerator is same, even denominator should be equal. Okay, so I'll write that also in equation 4, the numerator of LHS and RHS are same. Therefore denominator also should be equal. Therefore denominator are also equal. So you can skip this sentence to make it understandable. I am writing from equation 4. You can directly write this one. EC is equal to E dash C. Therefore EC is equal to E dash C, because numerator is equal. So when is EC is equal to E dash C? When both E and E dash coincides, only then EC will be equal to E dash C. Okay, this is possible only when E and E dash coincides with one another, or you can write this is possible when E dash coincides with E. So when E dash coincides with E, so when E dash coincides with E, our AD by DB will be equal to AE by EC, and D will be parallel to BC. This proves our theorem. This is E dash, this is BD. There are some worked examples here. You can read it and understand. First time it may be difficult to understand, but when you read the textbook again and again, you can understand. They're all simple. The main thing is, if you understand basic proportionality theorem, then everything becomes easy in this chapter. Please read and understand all these worked examples. I'll be going to exercise problems, exercise 2.2. So exercise 2.2. Exercise 2.2, problem number 1. In figure 2.17, find 2.17, 1 and 2, figure 1 and 2, D is parallel to BC. Find EC in 1 and AD in 2. So here figure 1 is like this. A, B, C, and this is D. So they have given AD is 1.5 centimeter, DB is 3 centimeter, and AE is 1 centimeter. Now in the problem they have given that D is parallel to BC. So if D is parallel to BC, then according to basic proportionality theorem, so AD by DB will be equal to AE by EC. So because of basic proportionality theorem. So now substitute AD, DB and AE in this equation. AD is 1.5 centimeter, DB is 3 centimeter, AE is 1 centimeter, and EC we don't know. So now we cross multiply. So 1.5 into EC is equal to 1 into 3. So EC is equal to 3 ones are 3 divided by 1.5. So this becomes 2. So EC is 2. Now next problem, next sub question. The figure is like this. This is A, this is B, this is C, and D, this is D. So A is 1.8 centimeter, EC is 5.4 centimeter, 7.2 centimeter. So here also given that So here also given DE is parallel to BC, therefore AD by DB is equal to AE by EC. Why? Because of basic proportionality theorem. So according to basic proportionality theorem, if D is parallel to BC, AD by DB will be equal to AE by EC. Now substitute all the values here. So AD is unknown. So AD by DB is 7.2 is equal to AE is 1.8 and EC is 5.4. Now what is AD? Cross multiply. AD will be equal to 1.8 into 7.2 divided by 5.4. So here you can divide from 6 3s are 18, so 0.3, 6 3s are 18, then 6 1s are 6, sorry, 6 9s are 54, so 0.969s are 54. Then again 3 1s are 3, 3 3s are 9, 3 1s are 3, 3 3s are 9. Again you can divide 3 1s are 3, 3 2s are 6, 3 4s are 12. So this becomes 2.4. Our AD is 2.4 centimeter. Now we'll check the answer. So in the answer exercise 2.2, first answer is 2 centimeter. Second question, the answer is 2.4 centimeter. Our answers are correct. We'll proceed to next problem. See, this was actually a very simple problem, and the whole exercise, the whole problems in this chapter is based upon basic proportionality theorem only. So if you understand basic proportionality theorem properly, you can solve all the problems. So read it again and again till you understand basic proportionality theorem. I'll go to next problem. Exercise 2.2, problem number 2. So E and F are points on the sides PQ and PR respectively of a triangle PQR. So there is a triangle PQR, and there are 2 points, one point on PQ and one point on PR, like this. These are E and F. For each of the following case, state whether EF is parallel or parallel to state whether EF parallel to QR. So they have given data for PE in the first sub question. PE is equal to 3.9 centimeter, EQ is equal to 3 centimeter, PF is equal to 3.6 centimeter, and FR is equal to 2.4 centimeter. So using this data, we should tell whether EF is parallel to QR or not. This is the question. So if EF is parallel to QR, PE by EQ will be equal to PF by FR. Okay. Now we'll check P by Q. What is P by Q? P by EQ. Now given P is equal to 3.9 centimeter. What is EQ? EQ is 3 centimeter. So now this is 3 1s are 3, 3 1s are 3, 3 3s are 9. 3 3s are 9. So 1.3 by 1. What is PF by FR? PF by FR is equal to, PF given as 3.6 centimeter. FR is equal to 2.4 centimeter. Now check 3 8s are 24. Okay, 3 1s are 3, 3 2s are 6. Now again it is divisible. This is 0.4, 2 4s are 8, 2 6 are 12. Now if now again it's divisible. It is 2 3s are 6, 2 4s are 2 2s are 4. So it is, now if I take the decimal outside, it is 3 by 2. Can take decimal, I can shift decimal 1 place right. Okay, it's 3 by 2. Now 1 is not equal to 2. So 1 not equal to 2. Therefore, what's our conclusion? EF is not, sorry, EF is not parallel to QR. Second sub question. In second sub question, we'll check P. What is P by QE? P by EQ. P by EQ is, P is 4 centimeter. QE or EQ is equal to 4.5 centimeter. So this is equal to, let this be as it is, 4 by 4.5. What is, I'll mark this as 1. Now what is PF by FR? So PF is 8 centimeter. What is FR? FR is 9 centimeter. Now this is 8 by 9. Now I'll mark this as 2. Is 1 and 2 same? Yes, 1 and 2 is same only. Now here I can divide by 2. 2 4s are 8. 2 4s are 8. 2 5s are 10. So this is 4.5. So 1 is equal to 2. 1 is equal to 2. Therefore EF will be parallel to QR, according to basic proportionality theorem. Now what is 3? Sub-problem 3, PQ. PQ is equal to, we'll directly find out what is P by EQ. Given P is equal to 1.28 and sorry, P is 0.18. P is 0.18. Then PQ, so here data given is a bit confusing. So they have given PQ is equal to, instead of P they have given PQ. This is PQR and this is E and this is F. So they have given PQ is equal to, what is PQ? PQ they have given 1.28 centimeter and they have given P is equal to 0.18. They have given this as 0.18 centimeter and they have given PR as 2.56 centimeter and they have given PF is equal to 0.36 centimeter. So if P is 0.18, what is this one? This will be 1.28 minus 0.18. So what is 1.28 minus 0.18? 0. 2 minus 1 is 1. So 1. So my EQ is 1.1 centimeter. correct. Similarly, my FR will be 2.56 centimeter minus 0.36. So 6605 minus 3 is 2. So 2.2. My FR is 2.20 centimeter. Now let me check PQ by P by EQ. So I'll check P by EQ. P by EQ is equal to 0.18 divided by 1.1. So I'll shift decimal points here. So it is 1.8 by 1.1. Let this be as it is. Now what is PF by FR? PF by FR is 0.36 divided by 2.20. Here also I'll shift decimal place by one place to the right. So it is 3.6 divided by 22.0. Now I'll divide by 2. So I'll get here 2 ones are 2, 2 8s are 16 in the numerator, in the denominator 2 ones are 2, 2 ones are 2. So 1.8 by 1. So this is 1, this is 2. Now is 1 is equal to 2? 1 is not equal to 2. Is 1 is equal to 2? So in 1 actually I have made a mistake. If I shift decimal place here in the denominator of 1, so it is 11. It's 11.0. 1.8 by 11.0. So in 2 also it is 1.8 divided by 11.0. So 1 is equal to 2. Therefore, what's our conclusion? Therefore, EF is parallel to QR. So in second main question actually we have used converse of theorem number 1. So that is we have used this one, converse of basic proportionality theorem. If a line divides two sides of a triangle proportionally, then that line is parallel to the third side. That's what we proved in theorem 2.2. So using that theorem we have proved, using that theorem we have solved all this problem, I mean our second main problem. Now we'll go to third question. Problem number 3. First let me write the figure here. The figure is figure 2.18. Figure is like this. This is AC, this is AB, this is AD, there is ML and NL. So what's the problem? What's the question? LM is parallel to CB. So given LM is parallel to CB and also NL parallel to CD. To prove, so to prove AM by AB is equal to AN by AD. So this we need to prove. Now in triangle ABC, first I'll take triangle ABC. So in triangle ABC it is already given that ML is parallel to BC. So this is given data. So since ML is parallel to BC, AL by LC will be equal to AM by MB. So according to basic proportionality theorem, see, if you know this theorem, you can solve all the problems of this chapter. So since ML is parallel to BC, AL by LC will be equal to AM by MB. Now taking reciprocals of this, taking reciprocal of the above equation, so it becomes LC by AL is equal to MB by AM. So nothing but I've interchanged numerator and the denominator of the above equation. So here it was AL by LC, it became LC by AL here. Now add numerical 1, add 1 to above equation. Above equation, what we will get? LC by AL plus 1 is equal to MB by AM plus 1. Now here LC by AL, so AL will be the LCM, so AL in the denominator and in the numerator also AL is equal to MB by AM plus here LCM is AM, so it comes in the numerator and denominator. So I'll take denominator as common factor AL, so LC plus AL in the numerator, here AM is the common factor. Now MB plus AM, Now what is LC? LC by AL. LC by AL is AC, length AC. Length LC plus length AL becomes length AL. So in the left hand side of numerator, it becomes AC. AC by AL is equal to, and what about in the right hand side? So MB plus AM is AB. AB by AM. Now again taking reciprocal of the above equation. Taking reciprocal of above equation, what will I get? I'll get AL by AC is equal to AM by AB. So I'll mark this as equation 1. Now instead of going to next page, I am writing here only. Now in triangle ADC, so in triangle ADC, given that LN is parallel to CD, NL is parallel to CD, therefore AL by LC will be equal to AN by ND, again because of basic proportionality theorem. Proportionality, if you don't know this basic proportionality theorem and the converse of that theorem, you won't be able to solve any of the questions in this exercise. So now taking reciprocal of the above equation, what will I get? Interchange numerator and the denominator, that's it. So AL by LC becomes LC by AL. So is equal to here AN by ND becomes ND by AN. AN. Now add 1 to above equation, numerical 1. Okay. Now in the left hand side LC by AL plus 1 is equal to ND by AN plus 1. So in the left hand side, so AL LC, so AL is the LCM, so AL by AL I'll get here, so AN here in the right hand side, ND, so here also LCM is AN, so AN by AN I will get. So AL I'll take common in the left hand side of the denominator, so numerator becomes LC plus AL. So denominator here is common is AN, so numerator will be ND plus AN. Now LC by LC by AL is equal to AC. See the picture, the length LC plus length AL is length AC, so numerator becomes AC here, AC by AL is equal to, now what is ND by AN, so ND plus AN, length ND plus length AN is length AD, so AD by AN. Now I'll take reciprocal of the above equation, taking reciprocal of equation, what will I get? So to interchange the numerator and the denominator, so AC by AL becomes AL by AC. So even right hand side also you should take, you can't take one side and leave the other side as it is. If you are taking reciprocal of the left hand side, you should take the reciprocal of the right hand side also. So now here what is this AD, right? So AD by AN becomes AN by AD. Now this I'll mark as 2. Now from 1 and 2 what we get? See, from 1 and 2, see the left hand side of 1 and the left hand side of 2 are same only, they are equal. Left hand side of 1 is AL by AC, left hand side of 2 is also AL by AC, therefore right hand side also will be equal. From 1 and 2 we will get a right hand side which are equal. So AM by AB becomes AN by AD. Since the left hand side of 1 and 2 are equal, right hand side also will be equal. So I'll equate the right hand side of equation 1 with the right hand side of equation 2. So and this is what we needed to prove. So and we proved the problem. This solution is very lengthy. I think this is a 4 marks or a 5 marks question. Okay, we'll go to next problem. Next question is problem 4. So in the figure, D parallel to AC and DF parallel to AE, prove that BF by FE is equal to BE by EC. So the figure is like this. A, B, C. This is AE and this is D and this is DF. So given that D is parallel to AC, so given this is given data, given D parallel to AC and DF parallel to DF is parallel to AE. So to prove that BF by FE is equal to BE by EC. See, before proceeding you need to write given data first. That also carries some marks. Without writing the given data, if you try to solve it, you may not get full marks. So please write the data. Please first understand the question before. If you don't understand the question and start solving it, you will not get answer also. So first understand the question, write the given data, and then proceed to solve it. So now in triangle ABE, okay, given that DF is parallel to AE, so this is given data. So therefore, since DF is parallel to AE, I will get BF by FE will be equal to BD by AD. Why? Because of basic proportionality theorem. So we already learned that in this theorem, if a line is parallel to one side, then the other two sides are divided proportionally. So here BF by FE will be equal to BD by AD. I'll mark this as equation 1. Now in triangle ABC, it's given that D is parallel to AC. So that is given data only. So since D is parallel to AC, B by EC will be equal to BD by AD. Why? Because of basic proportionality theorem. So this I'll mark as equation 2. See, now from 1 and 2 what we get? The right hand side of 2 and the right hand side of 1, they are both equal. Therefore the left hand side is also equal. So I'll write from 1 and 2, it's clear that BF by FE is equal to BE by EC. So this is a simple problem. So we'll go to next problem now. Problem number 5. In figure 2.20, D is parallel to OQ and DF parallel to OR. Show that EF is parallel to QR. So I'll write the diagram. Question number 5. So there is a triangle PQR, and there is some point called O here. So they are given D parallel to OQ. Okay. This D, this is D. So D is parallel to OQ. Then DF is parallel to OR. Now this DF is parallel to OR. Now we should show that EF is parallel to QR. Show that EF is parallel to QR. So given data is D parallel to OQ and DF parallel to OR. So we need to prove that EF is parallel to QR. Now in triangle PQO, we know that ED is parallel to QO because this is given data. Since ED is parallel to QO, PE by EQ will be equal to PD by DO. So why means because of basic proportionality theorem. Okay. Now I'll mark this as equation 1. Now again in triangle POR given DF is parallel to OR. Therefore PF by FR is equal to PD by DO. Why? Because of basic proportionality theorem. So this I'll mark equation 2. See, according to basic proportionality theorem, if a line is drawn parallel to one side of a triangle such that it cuts the other two sides, then the other two sides are the other two sides are divided proportionally, right? So here since PF is parallel to OR, we get PF by FR is equal to PD by DO. The same logic applies to the previous section also in case of triangle PQO. Now if you observe equation 1 and 2, from equation 1 and 2, see in equation 1 and 2 the right hand side is same. Right hand side is PD by DO. In the equation 2 also it's PD by DO. Therefore left hand side should also be equal. So I'll equate the left hand side. Left hand side of equation 1 is P by EQ. Left hand side of equation 2 is PF by FR. See now in triangle AQR, P by EQ is equal to PF by FR. So that is just now we derived in equation 3. Okay, in triangle AQR, P by EQ is equal to PF by FR. Therefore EF is parallel to QR. What is the reason? Again here the reason is the converse of basic proportionality theorem. What is the converse of basic proportionality theorem? According to converse of basic proportionality theorem or theorem 2.2, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So in triangle AQR, P by EQ is equal to PF by FR. Therefore EF is parallel to QR according to basic proportionality theorem. That proves this problem. Next question is problem 6. So the question is like this. In figure 2.21, A, B and C are points on OP, OQ and OR respectively. So here there's a big figure, complicated figure. So P, Q, R, A, B and C are points on OP. Okay. Now A is a point, A, B, C are points on OP, OQ and OR. So this is A, this is B, this is C. A, B, C are points on OP, OQ and OR respectively, such that AB is parallel to PQ. So AB is parallel to PQ. This is Q. So given data is AB parallel to PQ and AC parallel to PR. Show that to prove BC parallel to QR. So ABC are points on OP, OQ and OR respectively, such that AB is parallel to PQ and AC is parallel to PR. Show that BC is parallel to QR. This is a easy problem only. The figure looks complicated, but the solution is easy. We'll proceed. So in triangle POQ. So in triangle POQ, AB is parallel to PQ. So this is the given data actually. So given data. So since AB is parallel to PQ, now OA by AP is equal to OB by BQ according to basic proportionality theorem. Okay. Now similarly, now I'll mark this as 1. Now in triangle POR, in triangle POR, given that AC is parallel to PR, it's given data. Since AC is parallel to PR, I get OA by AP is equal to OC by CR according to basic proportionality theorem. This I'll mark as 2. Now from 1 and 2, what we get? From 1 and 2, see in equation 1, the left hand side of equation 1 and the left hand side of equation 2, they are same. If left hand side of two equations are same, the right hand side also will be equal. So from 1 and 2, I'll equate the right hand side, OB by BQ. OB by BQ is equal to OC by CR. So OB by OQ is equal to OC by CR. So now this I'll mark equation 3. Now in triangle OQR, OB by BQ is equal to OC by CR. I just now proved this in equation 3. OB by BQ is equal to OC by CR. Therefore what? Therefore, BC will be parallel to QR according to converse of basic proportionality theorem. So according to converse of basic proportionality theorem, if two sides of a triangle are proportional or divided proportionally, then that side is parallel to the third side. If a line divides two sides of a triangle proportionally, then that line is parallel to the third side. This is what our theorem 2.2 says. Theorem 2.2 is converse of basic proportionality theorem. So since OB by BQ is equal to OC by CR, BC will be parallel to QR. So that proves this problem. We'll go to next. Question 7. So using theorem 2.1, prove that a line drawn through the midpoint of one side of a triangle parallel to the other side bisects the third side. So now consider one triangle ABC. Now if I take the midpoint of AB, so midpoint of AB, let that be D. Midpoint means now AD will be equal to DB. Both will be equal. Okay. So from the midpoint, if I draw a line parallel to the third side, means that is I am drawing a line parallel to BC from starting from D. I will draw such that it will cut AC somewhere here, E. Now I should prove that it bisects the third side. That means we should prove that AE is equal to EC. Now what is the given data? So AD is equal to DB. Sorry, AD is equal to DB. Given data. So given data, AD is equal to DB and D is parallel to BC. These are the given data. What to prove? To prove AE is equal to EC. So we should prove that the line drawn from the midpoint of AB, if a line drawn from the midpoint of AB and which is parallel to BC, that will bisect the AC. That's what we need to prove. That means we need to prove that AE is equal to EC. Now since DE is parallel to BC, then according to basic proportionality theorem, AD by DB will be equal to AE by EC, right? AD by DB will be equal to AE by EC according to basic proportionality theorem. Now AD is equal to DB, right? According to given data, AD is equal to DB according to given data. So I'll mark this as equation 1. Therefore 1 becomes, see, AD by DB is equal to AE by EC. So these two will get cancelled because they are equal, or when I cancel it becomes 1 by 1. So 1 by 1 is equal to AE by EC. So it AD may be 2. If AD is 2, DB also will be 2. So 2 by 2 is 1 by 1. Or it can be any number. AD can be 5, DB can be 5. So if I cancel, it becomes 1 by 1. So now if I cross multiply, 1 into EC is equal to 1 into AE. 1 into any number is that number only. So EC into 1 is EC. So AE into 1 is AE. Therefore, EC is equal to AC. That means E divides AC equally. So it's proven. We proved that EC is equal to AC. So here in the question they have told to prove it using theorem 2.1. Theorem 2.1 is nothing but basic proportionality theorem. Now I'll go to next problem, problem number 8. Problem number 8 is similar to problem number 7 only. Using theorem 2.2, prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. So I'll put the diagram. Let there be a triangle called ABC. So prove that the line joining the midpoints of any two sides of a triangle. I'll consider the sides AB and AC. Let D be the midpoint of AB. So if D is midpoint of AB, then AD is equal to DB. And also let E be the midpoint of AC. Therefore AE is equal to EC. Now if I am joining these 2 points, so using theorem 2.1, prove that the line drawn through the midpoint of one side of a triangle. Using theorem 2.2, prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. So I have taken the midpoint of AB and AC and I have joined, and now I should prove that D is parallel to BC using theorem 2.2. Now given data is AD is equal to DB because D is the midpoint of AB, and AE is equal to EC because E is the midpoint of AC. Now we should prove that D is parallel to prove this we need to prove D is parallel to BC. So now I'll give the proof. See now what is AD by DB? So AD by DB will be equal to 1 by 1 because AD is equal to DB. So if AD is 1 centimeter, DB also will be 1 centimeter. So we will get 1 by 1. Even if it is 10 centimeter by 10 centimeter, 10 will get cancelled and we'll get 1. Okay, I'll mark this as equation. Now even what about AE? What about AE by EC? AE by EC also is equal to 1 by 1 because AE is equal to EC. That's from the given data. So no matter what the length of AE, the length of EC also will be the same, and we'll get 1 by 1 only. So this I'll mark as 2. So how this I got from the data only. AD by DB is equal to 1 by 1, AE by EC is equal to 1 by 1 from given data. Okay, from given data. So now 1 is equal to 2. 1 is equal to 2. Okay, it's clearly right hand side of 1 and right hand side of 2 is equal to 2. Therefore I can write AD by DB is equal to AE by EC. Now, since AD by DB is equal to AE by EC, we get D parallel to BC. The reason is converse of basic proportionality theorem, or theorem 2, or sorry, theorem 2.2. According to theorem 2.2, what the theorem 2.2 says: if a line divides two sides of a triangle proportionally, then that line is parallel to the third line. So according to this theorem, since AD by DB is equal to AE by EC, B became parallel to BC. Problem number 9. ABCD is a trapezium in which AB is parallel to DC and its diagonal intersect each other at point O. Show that AO by BO is equal to CO by DO. So ABCD is a trapezium ABCD and the diagonal intersect each other at O. So given data ABCD is a trapezium. Trapezium means AB will be parallel to CD. So that's also the given data, and I need to prove AO by BO is equal to CO by DO. So now proof. Now I'll draw EF parallel to DC. I'll draw EF parallel to DC and passing through O. Now AB is parallel to DC, we already know. Now I drew EF parallel to DC, therefore all the three lines will be parallel to one another. So now in triangle ABC, in triangle ADC, AE by ED is equal to AO by CO. Okay, this is, I'll mark equation 1. Why AE by ED is equal to AO by CO? Because EO is parallel to DC. So this is according to basic proportionality theorem. See what is the basic proportionality theorem says. If there is a triangle, say LMN, and if I draw a line parallel to one side of the triangle, supposingly if I draw a line parallel to MN such that it intersects LM at P and LN at Q. So if PQ is drawn in such a way that if it is parallel to MN and intersecting the other two sides at distinct points at P and Q, then LM by MP will be is equal to LN by NQ. So applying the same logic here, since EO is parallel to DC, in triangle ADC, EO is parallel to DC. That's why I get AE by ED is equal to AO by CO according to basic proportionality theorem. Now in triangle ADB, we know that EO is parallel to AB. Therefore again here also applying basic proportionality theorem, I get D by EA is equal to DO by BO. So this also same reason according to basic proportionality theorem or theorem 2.1, which we studied in this chapter. So now I'll take reciprocal of this equation. Taking reciprocal of this above equation, numerator will go to denominator, denominator will come to numerator. So d by ea becomes ea by de is equal to, now here bo by do. In both left hand side and right hand side I should make changes. Now I'll mark this as equation 3. Now you compare 1 and 2. Comparing 1 and 2, see, if when we compare, the left hand side of 1 and the left hand side of 2 is same only. AE and EA is same only, ED and D is same. So when left hand side of two equations are equal, we can equate the right hand side also. Therefore right hand side will be equal. Therefore LHS are equal. Therefore RHS are also equal. So I'll equate RHS. RHS of RHS of 1 is AO by CO, and RHS of equation 3 is equal to BO by DO. Now I'll bring this BO to the left hand side, it will come to the denominator. If I bring CO to the right hand side, it will come to the numerator. So AO by BO is equal to CO by DO. So this is what we needed to prove. We proved it. So question number 10. So the diagonals of a quadrilateral ABCD intersect each other at point O such that AO by BO is equal to CO by DO. Show that ABCD is a trapezium. So there's a quadrilateral. So quadrilateral is a polygon formed by 4 sides, A, B, C, D. So here there is a quadrilateral ABCD and the diagonals is intersecting at O. So and such that it is intersecting such that AO by BO is equal to CO by DO. Show that ABCD is a trapezium. So given data, ABCD is a quadrilateral such that AO by BO is equal to CO by DO. I should prove that ABCD is a trapezium. To prove ABCD is a trapezium. See, to prove ABCD is a trapezium, I should prove that I should prove AB is parallel to CD. So what is a trapezium? Trapezium is a quadrilateral in which one pair of opposite sides are parallel to one another. So if I prove AB is parallel to CD, my job is done. If I prove AB is parallel to CD, then it's as good as saying that ABCD is a trapezium. So proof. So I will draw line EO such that it is parallel to DC. Okay, draw EO parallel to DC. Okay, now in triangle ADC. So now ADC is a triangle in which EO is parallel to DC. Therefore AE by ED is equal to AO by CO. I'll mark this as 1. Now you consider the given data here. See, given data is given AO by BO is equal to CO by DO. Here I'll bring this CO to the left hand side and BO to the right hand side. If I bring CO to the left hand side, it will come to the denominator of the left hand side. If I bring BO to the right hand side, it will go to the numerator of the right hand side. Therefore AO by CO is equal to BO by DO. See, now I'll substitute this AO by CO here. Okay, now my AE by ED is equal to AO by CO is equal to BO by DO. BO by DO. AE by ED is equal to BO by DO. Now I'll take reciprocal, taking reciprocal of above. Numerator will go to denominator and denominator will come to numerator. Therefore ED by AE, and in the right hand side DO by BO. Numerator came to denominator and denominator came to numerator. Now you can see this is a ratio of sides. ED by AE is equal to DO by BO. Therefore EO is parallel to AB. Why? See, what is EO is parallel to AC according to converse of basic proportionality theorem. See what the converse of basic proportionality theorem says. If there is a triangle and if a line cuts two sides of a triangle such that let this be L, M, N, and let this be PQ. If PQ cuts LM and LN such way that LP by PM is equal to LQ by QN, then PQ is parallel to MN. This is what the converse of basic proportionality theorem says. Now here if you see this equation, ED by AE is equal to BO by DO. Therefore EO should be parallel to AB. So since now we already knew that EO is parallel to DC. So we only drew that in construction. We drew EO parallel to DC in the initial stage of the proof. Okay. Now we came to know that EO is parallel to AB. EO is also parallel to AB. That means all the three lines AB, EO, and DC are parallel to one another. So if AB is parallel to CD, therefore ABCD is a trapezium. The next topic is 2.4 criteria for similar triangles. So if you see in the textbook, see two triangles are said to be similar only if their corresponding angles are equal and sides are proportional. Suppose there are two triangles, say of side 1 centimeter, 1 centimeter, 1 centimeter. Let this be A, B, C, and let there be another triangle of side 2 centimeter, 2 centimeter, 2 centimeter. So this is a equilateral triangle. So all angles are equal. Each angle will be equal to 60 degree. 60, 60, 60. Okay. See, now angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. So this is one point. And also, if you take the ratio of any two sides, say AB by PQ, which this is equal to 1 by 2. AB is 1 centimeter, PQ is 2 centimeter. Also, if we take ratio of AC by PR, the ratio is 1 by 2. Again, if you take ratio of BC by QR, the ratio is 1 by 2. See, everywhere ratio you are getting constant. So that means we say the sides are proportional. So the criteria for two triangles to be similar is the corresponding angle should be equal and the corresponding side should be proportional. Then we say that the two triangles are similar to one another. So we denote this as triangle ABC is similar to triangle PQR. Now, what is the difference between congruent triangles and similar triangles? Now I'll draw a chart here. See, congruent triangles and similar triangles. See, in congruent triangles, corresponding angles are equal. Also, corresponding sides are equal. But in similar triangles, if corresponding angles will be equal, but corresponding sides will be proportional. This is the main difference between congruent triangles and similar triangles. In the above example, if I take ratio of the sides from bigger triangle to the smaller triangle, that is, if I take PQ by AB, I'll get 2 by 1. Similarly, so if I take PR by AC, I'll get 2 by 1. Again, if I take QR by BC, I'll get ratio is equal to 2 by 1. So here also in all the cases I am getting 2 by 1. So you can take ratio of the sides from smaller triangle to side of the bigger triangle also, or from side from bigger triangle to the smaller triangle also. And if the ratio is constant, then we say the two triangles are similar. Now let me do recap of basic proportionality theorem. Basic proportionality theorem. So basic proportionality theorem is also in your text it's given as theorem 2.1. So here why theorem 2.1 is, this is chapter 2 and theorem number 1, that's why they are mentioned as theorem 2.1. So whenever you want to mention this, it's better to mention as basic proportionality theorem instead of theorem 2.1. So what does basic proportionality theorem says? So see, in basic proportionality theorem says that if a line is drawn parallel to a triangle, suppose there is a triangle like this, and if you are drawing a line parallel to one side of the triangle, so let me draw this line parallel to this base of the triangle. let this be A, B, C, and if I draw a line parallel like this, such that it intersects the two sides of the triangle, then it divides the two sides of the triangle are divided in the same ratio. So that means, let this be PQ. If PQ is parallel to BC such that it intersects AB at P and AC at Q, then AB by BP, this is B, AB by PP will be equal to AC by CQ. So this is what the basic proportionality theorem says, and we have seen the proof also. Now what is the converse of this? Converse of this theorem they have mentioned as theorem 2.2. So it's better to say converse of basic proportionality theorem only. So theorem 2.2 is converse of basic proportionality theorem. So here definition is exactly opposite to basic proportionality theorem. So if you go here, so what the definition says, theorem 2.2, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So if there is a triangle like this, ABC like this, and if I draw a line intersecting two sides of a triangle like this, let this be D. If I draw a line intersecting two sides of the triangle in the same ratio, that means if I draw D such that AD is equal to DB, and this is equal to AE by EC. If I draw D such that AD by DB is equal to AE by EC, then D is parallel to BC. So this is exactly opposite to the exactly opposite of the basic proportionality theorem. So converse of basic proportionality theorem is theorem 2.2. Okay, we'll move to next topic. This is just two line D parallel to BC. So next topic is so the criteria for similar triangles I explained you already. So it says two triangles are similar if corresponding angles are equal and corresponding sides are proportional. So regarding this, there is one activity here. You can read and do it by yourself. Now theorem 2.3. Theorem 2.3. Theorem 2.3. So that means chapter 2, theorem number 3. So in this chapter exclusively deals with similar triangles. Basic proportionality theorem and converse of basic proportionality theorem also dealt with similar triangles only, and now again in this theorem also we will be dealing with similar triangles. Okay, and According to the definition of this theorem, if in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio or proportional, and hence the two triangles are similar. So diagram is like this. There's one triangle and there's another triangle. So first triangle is A, B, C. Second triangle is D, E, F. D, E, F. So suppose if A is equal to D and B is equal to angle B is equal to angle E and angle C is equal to angle F. So then AB by DE, AB by DE is equal to AC by DF is equal to BC by EF. So if in two triangles the corresponding angles are equal, then their corresponding sides are in the same ratio, and hence the two triangles are similar. So we need to prove this. So given data is angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. We need to prove that AB by DE is equal to AC by DF is equal to BC by EF. If it is so, then the two triangles are also similar. So when we call two triangles are similar, when their corresponding sides are equal and their corresponding when their corresponding angles are equal and their corresponding sides are proportional, then we say two triangles are similar. So here also it applies the same. The corresponding angles, if they are in same ratio, that means AD by DE is equal to AC by DF is equal to BC by EF, then it means these two triangles are similar. So given data is so ABC, triangle ABC and DEF are two triangles in which angle A is equal to angle D and angle B is equal to angle E and angle C is equal to angle F. Corresponding angles are equal. So we need to prove that AB by DE is equal to AC by DF is equal to BC by EF. If we prove, what it means is the sides are proportional. So if angles are equal and sides are proportional, then we say those two triangles are similar. So what will I do is, I'll mark a point on DE. I'll mark P on DE such that AB is equal to DP, and I'll mark point Q on DF such that AC is equal to DQ, and join PQ. So I'll write cut DP such that it is equal to AB and DQ is equal to AC, and join PQ. So after joining, what will happen? What's our observation in triangle ABC and DPQ? See, in triangle ABC and DPQ, see, in the textbook some explanation is not given, that's why I am explaining. So in triangle ABC and DPQ, so angle A is equal to angle D, and then AB is equal to DP and AC is equal to dq. Therefore these two triangles are congruent. Therefore triangle ABC is equal to is congruent to triangle DPQ according to side angle side. So what is the first side here? AB and DP. Those are the side. Angle is equal to angle D, and another side is AC is equal to DQ. According to SAS, side angle side congruency rule, rule, these two triangles are congruent. So if two triangles are congruent triangles already have learnt in your previous class. Okay, now if two triangles are congruent, all the corresponding angles will be equal, and also all the corresponding sides will be equal. Therefore angle B will be equal to angle P, and angle C will be equal to angle Q. I am marking here. Angle P is equal to angle B, angle Q is equal to angle C. Now in the figure we can see angle P also is equal to angle E. Now we observe that angle P is equal to angle E, and angle Q is equal to angle F. So what it means? It means PQ is parallel to EF. See, if there is a parallel line and there is an intersection, then this angle is equal to this angle, and this angle is equal to this angle. These are corresponding angles. So if P is equal to E, angle P is equal to angle E, that, and angle Q is equal to angle F, it implies that PQ is parallel to EF. So P is equal to E and angle Q is equal to angle F. Therefore P is parallel to EF. So if P is parallel to EF, this implies dP by PE. dP by PE is equal to dQ by QF, and the reason is basic proportionality theorem. Basic proportionality theorem. See, according to basic proportionality theorem, if there is a triangle, let us say LMN, and if you draw a line parallel to one side, that is, if I draw a line parallel to MN, supposingly, such that it cuts like this, cuts LM and LN at two distinct points. Let this be E and F. So if I draw EF parallel to MN such that it cuts LM at E and LN at F in this way, then LM by ME is equal to LN by NF. This is what basic proportionality theorem says. So in a similar way, now P is parallel to PQ is parallel to EF. Therefore dP by P is equal to PQ by QF. Now I will mark this as equation 1. Now I will take inverse of this. Taking inverse of equation 1. If I take inverse of equation 1, numerator will come to denominator and denominator will go to numerator. So dP by dE becomes P by dP. P by dP is equal to, in the right hand side also same thing applies, QF by dQ. So P by dP is equal to QF by dq. So I'll add 1 to both sides. Add 1 to numerical 1 to both side. Now I'll get P by dP plus 1 is equal to QF by dq plus 1. So this is P by dP plus 1 is 1 by 1. So here LCM will be dP. So it comes in the numerator also, is equal to QF by dq plus 1 is 1 by 1. So here also dq, the numerator also dq will come. So I'll take dp as common factor. If I take dp as common factor, numerator becomes p plus dp. So here in the denominator dq is the common factor. So qf plus dq. So p plus dp is de. So this becomes d by dp is equal to qf by pq. QF by pq. Sorry, QF by dq is df by dq. Now again I'll take inverse. I'll mark this as 2. Taking inverse of 2. So numerator will go to denominator will come to numerator. So this becomes dp by de. df by dq becomes dq dq by df. Now what is my dp? dp is equal to ab. dp is equal to ab and dq is equal to ac. I'll substitute these two here. So in place of dp I'll write ab by d is equal to, in place of dq I'll write ac by df as it is. Now you can see in this equation it's the ratio of the sides. AB and AC are the sides of first triangle, and the denominator D and DF is the ratio, is the D and DF is the sides of the second triangle. So similarly it can be shown that this equation I am writing as it is, AB by DE is equal to AC by DF is also equal to BC by EF. So how can I show this one actually? See, our original figure is ABC like this, A, B, C, and there is another triangle D, E, F. Now what we DF? So we draw PQ like this, and we showed that AB by D is equal to AC by DF. So instead of here, if I draw one line like this, such that it is equal to AC. So in this way, if I go on proving, I can also show that AB by DE is equal to AC by DF is equal to BC by EF. So I'll mark this equation 3. So now if you observe equation 3, it's the ratio of the sides, and the numerator is full of sides of first triangle. In the denominator, it's full of sides of this second triangle. So it's the ratio of the sides, and it is equal that means AE is equal to D, which is equal to AC by DF is equal to BC by EF. That means the ratio of the sides are constant. So this proves our theorem. This proves our theorem. Just now we proved that if in two triangles if corresponding sides are equal, that is A, B, C, D, E, F. If in two triangles if corresponding angles are equal, that means if A is equal to D and if angle B is equal to angle E, and if angle C is equal to angle F, then AB by D is equal to AC by DF is equal to BC by EF. So here three angles were equal. We knew that and we proved. Now what if only two angles is given? Suppose like this. There are two triangles, and if this angle, let this be A, B, C, D, E, F. So what if angle B is equal to angle E and angle C is equal to angle F? Only if these two angles are given, will they be similar? So see, if two angle is given, the third, what will be the third angle? See, now angle A will be equal to 180 degree minus angle B plus angle C. So here also, in the second triangle also same thing applies. Third angle will be 180 degree minus angle E plus angle F. So here angle B is equal to angle E and angle C is equal to angle F. Therefore angle A will be equal to angle D. So if B is equal to C and if angle E is equal to angle F, then A will be equal to angle D. So it's not necessary that if we know if in two triangles, it's not necessary that we know that all the three angles are equal. Even if in two triangles, if two angles are equal, then we can safely conclude that those two triangles are similar to one another. So this is also known as AA criteria. So AA criteria of similarity, the similarity of two triangles. So AA stands for angle. So if in two triangles, two angles or one triangle is equal to corresponding to two angles of the second triangle, then the ratio of the sides, corresponding ratio of the sides are constant and the two triangles are similar to one another. So if three angles of one triangle is equal to three angles of another triangle, then those two triangles are similar. Similarly, even if two angles also, if they are equal, then those two triangles are similar to one another. So you can see in the textbook it has been mentioned. See, in this theorem there is a remark here, and after that you can see, if two triangles of one triangle are respectively equal to two angles of another triangle, then the two triangles are similar. Can you see the mouse pointer? the definition says if two angles of one triangle are respectively equal to two angles of another triangle, then the two triangles are similar. This may be referred to as AA similarity criteria for two triangles. Now there is one activity 5. You should only read and understand. First time you may not understand, but if you read the textbook again and again, you'll be understanding it. Okay, it's left to you. Now after this there is another theorem. Theorem number 2.4. Theorem 2.4. So this theorem, what it says, if in two triangles sides of one triangle are proportional to the sides of the other triangle, then the corresponding angles are equal and hence the two triangles are similar. This criteria is referred to as SSS, similarity criteria for two triangles. So theorem 2.4, it is fourth theorem in chapter 2. That's why they have put it as theorem 2.4. So this is also known as SSS, similarity criteria. Similarity criteria for two triangles. So what this theorem says is, if there are two triangles and if their sides are proportional, so like this, there are two triangles. Let this be ABC and let this be DEF. See, if AB by DE is equal to AC by DF is equal to BC by EF, then the corresponding angles are equal. That means angle A is equal to angle D. Then it means angle A is equal to angle D and angle B is equal to angle C and angle E is equal to angle B is equal to angle E and angle C is equal to angle F. So this the theorem says, if in two triangles ABC and DEF like this, if AB by D is equal to AC by DF is equal to BC by EF, then angle A will be equal to angle D, angle B is equal to angle C and angle C is equal to angle F, and hence these two triangles are similar. So we need to prove this theorem. So given data is, so whenever you are proving some theorem, you need to write whatever data it has been given, you need to mention it. See, there are two triangles here. In triangle ABC and DEF and triangle DEF, given that AB by DE is equal to AC by DF is equal to BC by EF, then we need to prove that angle A is equal to angle D and angle B is equal to angle E, angle B is equal to angle E and angle C is equal to angle F. So if it is proven, then these two are similar triangles. What are similar triangles? Similar triangles are triangles whose corresponding angles are equal and corresponding sides are proportional. So here we already know that the corresponding sides are proportional. We need to prove that the angles are also equal. If angles are also equal, then we can say those two triangles are equal. So proof So to prove this, I will cut D on, I'll cut D at P such that AB will be equal to DP, and also I'll cut Q on DF such that AC will be equal to DQ, and I'll join points P and Q. So I'll write cut DP is equal to AB and DQ is equal to AC, and join PQ. We already know that AB by DE is equal to AC by DF is equal to BC by EF. This is the given data already. Given data. So now we have cut P such that DP is equal to AB. So in place of AB I'll write DP. So DP. So AP I am writing like this, DP is equal to DP by DE. In place of AC I'll write PQ, because my DQ. So DQ is equal to AC. So DQ by DF. Okay, now you can see so what's the reason for this? AB is equal to DP and AC is equal to DQ. Now what I'll do is take reciprocal of the above equation. Taking reciprocal of above equation, I'll get the numerator will go to denominator and denominator will come to numerator. So this becomes D by DP is equal to DQ by DF. Now this is DF by DQ. So if I make changes in the left hand side, I should make changes in the right hand side also. This becomes DF by DQ. Now I'll subtract 1. Subtract numerical 1 from both side of 1. I'll mark this as 1. So D by DP minus 1 is equal to DF by DQ. DQ minus 1. So both the side I should subtract. So here I'll take LCM in the left hand side. It becomes DP, the denominator D. So D by DP minus here 1 is 1 by 1. So if I take LCM, it becomes DP by DP is equal to DF by DQ minus here also 1 means 1 by 1. So LCM is DQ. So DQ by DQ. So I'll write here just to save some space. Now here in the left hand side DP is common. So in the numerator D minus DP, and in the right hand side DQ is in the denominator, and in the numerator DF minus DQ. So D minus DP is P. So P by DP. So here DF minus DQ is QF minus DQ. Now again I'll take reciprocal. Taking reciprocal, I'll get DP by P. DP by P is equal to dq by qf. Therefore pq will be parallel to ef according to basic proportionality theorem. So what does the basic proportionality theorem says? So you already know that if a line in a triangle, if you draw a line parallel to one side of the triangle such that it cuts the other two sides at distinct points, let this be L, M, N, let this be H, I. So if I draw HI, parallel to MN such that it cuts LM at H and LN at I, then LM by MH is equal to LN by NI. So applying the same logic here, PQ becomes parallel to EF. You can also consider converse of basic proportionality theorem also. According to converse of basic proportionality theorem, if a line cuts two sides of a triangle proportionally, then that line is parallel to the third side. So here, if I draw MN such that it cuts LH and LI in the proportion LM by MH is equal to LN by NI, then MN is parallel to HI. So whether you mention its basic proportionality theorem or converse of basic proportionality theorem, it's understood. So here, since dP by P is equal to dq by OF, I'll get PQ is parallel to EF. So I'll mark this equation 2. I'll hide this text and go to new page. Now since PQ is parallel to EF, I'll get angle P is equal to angle Q and angle Q is equal to angle F. What's the reason? These are corresponding angles. So in case of parallel lines, if there is an intersection like this, then this angle is equal to this angle and this angle is equal to this angle. These are corresponding angles. So same way here, since PQ is parallel to EF, angle P is equal to angle Q is equal to angle F. I'll mark this as equation 3. Now again I will consider equation 1. Equation 1 is AB by DE is equal to AC by DF is equal to BC by EF. Sorry, this is not equation 1. This is given data. So this is given data. Now in this given data, so we know that AB is equal to PQ, DP. So I'll substitute that. In place of AB, I'll write DP. DP is equal to DP by DE. So AC is equal to DQ. So I'll write that one, DQ. In place of AC, I'm writing DQ by DF. Now in place of BC, can I write PQ? This is equal to PQ by EF. So how can I say that PQ is equal to BC? See, in the second triangle is like this: D, E, F. So this is PQ, and DP is of some length, okay, and DQ is also of some length. So DP, okay, I'll write the first triangle also. First triangle is ABC, and AB is equal to DP, and AC is equal to DQ. See here, now if PQ is not equal to BC, if PQ is lesser than BC, then that line will be of shorter length. It will be somewhere here. So if my PQ is this PQ, this dashed line, then DP will be of smaller length, and DQ will also be of smaller length. But it is not so. My AB and DP are equal, and which is constant. Similarly, AC and DQ are equal, so it can't change. Now if I think that BC is if I think PQ is bigger than lengthier than BC, then it will be like this. So even this is not possible, because DP will change, and also DQ also will change, but it shouldn't change, because AB is equal to DP, and AC is equal to DQ. Therefore BC should be equal to PQ. In that logic, I will say that BC is equal to PQ. Therefore triangle ABC will be congruent to triangle DPQ, because the corresponding sides are equal. AB is equal to DP, AC is equal to DQ, and BC is equal to PQ. So since the corresponding three sides of triangle ABC is equal to corresponding sides of triangle DQP, those two triangles are congruent. So if two triangles are congruent, then the corresponding angles also will be equal. That means angle B will be equal to angle C, and angle B is equal to angle P, and angle C will be equal to angle Q. See, I'll mark this as equation 4. See, now if you comparing equation 3 and 4, comparing equation 3 and 4, we will realize that angle B is equal to angle E, and angle C is equal to angle F. So here in this congruent triangles, angle A is equal to angle D also. Angle A is equal to angle D. So here now if I compare equation 3 and 4, angle B is equal to angle E, angle C is equal to angle F, and also angle A will be equal to angle D. So I proved that the corresponding angles of the second triangle are equal to corresponding angles of the first triangle. Therefore triangle ABC and DEF are similar. So we already knew that the sides, corresponding sides were proportional, and we just now proved that the angles are also equal. Therefore, these two triangles are similar. Oh, this is triangle DEF. Triangle DF, triangle DEF. So triangle ABC is similar to triangle DEF. So let's see what is there in the next topic. So in the textbook, you can read the proof here in your textbook. If you find my proof easier, you can refer my proof only. In the textbook, some steps are skipped. Okay, they mean that we should understand by ourselves. So some explanation they have not given. You should understand. Theorem number 2.5. Theorem 2.5. So chapter 2, theorem number 5. That's why they have mentioned as theorem 2.5. So it says if one angle of a triangle is equal to one angle of the other triangle. So let me draw the figure. Let the first triangle be ABC. Let the second triangle be DEF. So if one angle of a triangle is equal to the other angle of the triangle, that means if angle A is equal to angle D, and the sides including these triangles are proportional, that means AB by DE is equal to, or proportional, AB by DE is equal to AC by DF. So if there are two triangles such that angle A is equal to angle D, as in this case, and AB by DE is equal to AC by DF, then these two triangles are similar. If they are similar, what will happen? All the other angle will be equal. That means we should prove that angle B is equal to angle E and angle C is equal to angle F. So if these two triangles are similar, corresponding angles are equal. So I'll write the given data. Data is in triangle ABC and DEF, angle A is equal to angle D, and AB by DE is equal to AC by EF. So this is the data. So in such a case, the triangles will be similar. If the triangles are similar, the corresponding angles will be equal. That means we should prove that angle B is equal to angle C and angle E is equal to angle F. I'll make some construction here. So cut DP is equal to AB and DQ is equal to AC, and join PQ. So I will mark a point P on D such that DP is equal to AB, and I will mark a point on Q, on DF, that point is Q, such that AC is equal to DQ, and I will join PQ. Now in triangle ABC and DPQ, angle A is equal to angle D. This is the given data actually. given data. So so they have already told that into this is SAS criteria, right? So two sides are proportional and one angle is equal, that is angle A is equal to angle D. So angle A is equal to angle D is the given data. So and now AB, side AB is equal to DP and AC is equal to length AC is equal to length DQ. Therefore triangle ABC is congruent to triangle DPQ because of side angle side SAS, side angle side congruent rule, SAS congruent rule. So here the two sides AB is equal to DQ and AC is equal to DQ and angle A is equal to angle D. Therefore triangle ABC is congruent to triangle DPQ. So if two triangles are congruent, the corresponding angles will be equal. Therefore angle B is equal to angle P and angle C will be equal to angle Q. I'll mark this as equation 1. Now consider consider the ratio of the sides, that is the given data, given AB by D is equal to AC by DF. So now I'll take inverse of this equation, taking reciprocal, we get, so the above equation becomes, I'll mark this as 2, taking reciprocal of 2, so this becomes D by AB is equal to DF by AC. Now AB is equal to DP. I'll substitute that D by DP is equal to DF by AC is DQ. So reason also I'll mention, because AB is equal to DP and AC is equal to DQ. Now I'll continue here. Now I'll subtract 1. Subtracting 1 both sides. So if I subtract 1 both sides, D by DP minus 1 is equal to DF by DQ minus 1. Now D by DP, so here LCM is DP, so 1 means 1 by 1 I can take, so LCM I'll take DP, so numerator becomes DP by DP is equal to, here DQ PF as it is, here also 1 means 1 by 1, so minus, I'll take LCM, it becomes DQ by DQ. Now here in the left hand side DP is common in the denominator, so D minus the numerator, it is D minus DP. Now here DQ, in the denominator DQ is a common factor, PF minus DQ. Now D minus DP is P, so P by DP is equal to, here DF minus DQ is QF by dq. Now again I'll take reciprocal. Taking reciprocal, I'll hide the textbook for a moment and go to next page. So after taking reciprocal, I'll get dp by d is equal to dq by qf. So what it means, dp by pe is equal to dq by qf. So what's the meaning of this one? It's the reciprocal of sides. So it means that PQ is parallel to EF. So according to converse of basic proportionality theorem. So what the basic proportionality theorem says, converse of basic proportionality theorem says, it says that if there is a triangle like this, and if I draw a line parallel, if I draw a line such that it cuts two sides of this triangle, it cuts in such a way that if LG is equal LG by GL is equal to LH by HM. So if I draw GH such that LG by GL is equal to LH by HM, then GH is parallel to LM. This is what the basic converse of basic proportionality theorem says. So we have already studied that one. So applying the same logic, since dp by p is equal to pq by qf, pq is parallel to ef. Therefore, if PQ is parallel to EF, then angle P will be equal to angle E, and angle Q is equal to angle F. These are corresponding angles. Right. See, if there are two parallel lines and if there is an intersection, then this angle is equal to this and this angle is equal to this angle. These are corresponding angles. So here similarly, since PQ is parallel to EF, we get angle P is equal to angle E and angle Q is equal to angle F. Now I'll mark this as 1, 2, I'll mark this as equation 3. Now if you compare if you compare equation 1 and equation 3, comparing 1 and 3. So if I compare 1 and 3, I will get angle B is equal to angle E and angle C is equal to angle F. See, from 1 angle B is equal to angle P, from 3 angle P is equal to angle E, therefore angle B will be equal to angle E. Similarly, in 1 angle C is equal to angle Q, and in 3 angle Q is equal to angle F, therefore angle C is equal to angle F. So this proves my theorem. So in theorem already it was mentioned that two sides were proportional and one angle was equal. I had to prove that the other angles are equal, so that those two triangles are similar. So I proved that the other angles are also equal, and the theorem is complete. Proof is complete. Let us see what's the next topic in the textbook. See, there are some solved examples here. So you read by yourself and try to understand. Example 4, example 5. So if you understand all the theorems, that is basic proportionality theorem and its converse, and all the uh, sim, theorems for similarities, that is 2.3, 4 and 2.5, those theorems and all, if you understand, you will be able to solve all these problems. So example 6, 7. So explanation are all given in the textbook itself. So example 8. Now I'll go to exercise 2.3. So let us make a revision of what we have learned till now. So in this chapter you learned several theorems. First theorem is basic proportionality theorem, that is theorem 1.1. So theorem 2.1. So chapter 2 and theorem 1, that's why they have mentioned as theorem 2.1, also known as basic proportionality theorem. According to this theorem, if there is a triangle and if you draw a line parallel to one side of the triangle, supposingly I am drawing line parallel DE. I draw a line parallel to BC such that that parallel line will intersect at D. Intersect the side AB at D and side AC at E. If D is parallel to BC, then AB by BD will be equal to AC by CE. So if a line is drawn parallel to one side of a triangle to intersect the other two sides at distinct points, then the other two sides are divided in the same ratio. If D is parallel to BC, then AB by BD will be equal to AC by CE. And in theorem 2.2, theorem 2.2 is nothing but converse of the above theorem. Converse of basic proportionality theorem. So in this theorem says, if there is a triangle and if I draw a line such that it intersects two sides of a triangle, it intersects in such a way that if AD by DB is equal to AE by EC, then DE side DE will be parallel to BC. This is just exactly opposite to basic proportionality theorem. Now theorem 2.3. See, and after theorem 2.2 we will study four theorems which are all related to similarity of triangles. And in that one, first theorem is 2.3. This is also known as AAA criteria of similarity of two triangles. So according to this theorem, if in two triangles the corresponding angles of a triangle is equal to the corresponding angles of the other triangle, then the corresponding sides are in the same ratio, and hence the two triangles are similar. For example, if there are two triangles ABC and DEF, and if angle A is equal to angle D, and if angle B is equal to angle E, and if angle C is equal to angle E, if angle A is equal to angle B, and angle B is equal to angle E, and if angle C is equal to angle E, then AB by DE will be equal to BC by EF will be equal to AC by DF. This is angle F. So if three angles of a triangle, if the corresponding three angles of a triangle is equal to the corresponding three angles of the other triangle, if three angles of a triangle is equal to the corresponding three angles of the other triangle, then the corresponding sides are in a ratio, and hence these two triangles are similar. So it's not necessary that all the three angles should be equal. Even if two angles of a triangle, okay, even if two angles of a triangle are equal to the corresponding angles of the other triangle, then their corresponding sides will be of a definite ratio, and those two triangles will be similar, and this is known as AA criterion. So even if two angles of a triangles are equal, then those two triangles are similar. So next is theorem 2.4. So theorem 2.4 is nothing but SSS criteria of similarity of two triangles. So here it says that if in two triangles the sides of one triangle are proportional to the sides of the other triangle, then those two triangles will be similar. DEF. Suppose in these two triangles, if AB by DE is equal to BC by EF is equal to DC by AC by DF, then the corresponding angles will be equal. Then angle A will be equal to angle D, then B will be equal to angle C, then angle C will be equal to angle F, and hence these two triangles will be similar. And the last theorem that we learned here is theorem 2.5. So this is also known as side criteria of similarity of two triangles. So here in this case, if one angle is equal to another angle of a triangle, if one angle of a triangle is equal to the another angle of a triangle, and if the sides are proportional, and if the sides including these angles are proportional, that is, if angle A is equal to angle D, and AB by D is equal to AC by DF, then these two triangles are similar. If angle A is equal to angle D and AB by D is equal to AC by DF, then these two triangles are similar. So similarity symbol is this one, triangle ABC is similar to triangle DEF. So now based on these theorems, we will be solving some problems. Exercise 2.3, problem number 1. State which pairs of triangles in figure 6.34 are similar. Write the similarity criteria used by you for answering the question, and also write the pairs of similar triangles in the symbolic form. There are two triangles in sub question 1. I'm drawing it. So triangle ABC and triangle PQR. This first sub question. So clearly we can see that let me write the angle also. This is 60 degree, this is 80 degree, this is 40 degree, and here angle P is equal to 60 degree, angle Q is equal to 80 degree, R is equal to 40 degree. Now clearly we can see angle A is equal to angle P, which is equal to 60, angle B is equal to angle Q is equal to 80 degree, and angle C is equal to angle R is equal to 40 degree. Therefore the two triangles are similar to one another. So the given triangles are similar according to what criteria? Angle criteria. According to angle criteria. So three angles of the first triangles are equal to the corresponding three sides of the second triangle. Therefore these two triangles are similar. So writing in the symbol form, and triangle ABC is congruent to triangle PQR. So next sub question. So ABC2 triangle are given. The first triangle ABC sides are 2, 3 and 2.5. The second triangle sides are this is PQR, PQ, and our sides are 6, 5 and 4. Now here angles is not known, only sides are given, so we'll match with the sides. Now here in the first triangle the greatest lengthiest side is AC, which is 3 centimeter. So and here on the second triangle the lengthiest side is PQ, which is 6. Sorry, unit is not given, it may be centimeter or meter, whatever. So here length of PQ is 6, which is the highest. So I will take the ratio of the highest side to the highest side. Now AC by PQ is equal to 3 by 6 is equal to 1 by 2. 3 1s are 3, 3 2s are 6. Now I will take the ratio of the lowest side. Now here AB is the lowest side, and here QR is the lowest side. I will take AB by QR. So 2 by 4. Again here 2 1s are 2, 2 2s are 4. Now only the remaining now is BC in the left and PR in the right side. So remaining side is BC and PR. So first you take the ratio of the highest side to the highest side, then lowest side to the lowest side, then the remaining side. Okay. Now here it is 2.5 by 5. Here also I'll get 1 by 2 as the answer. So the ratio of the sides is turning out to be a constant. So since the ratio is a constant, the two given triangles are similar. So the given triangles are similar according to what is the criteria? According to side. So the three side of the first triangle is proportional to the sides proportional to the corresponding sides of the second triangle. So according to SSS criteria, these two triangles are similar. So writing in symbolic form, ABC, triangle ABC is congruent to triangle PQR. Now question number 3. So here LMP is a triangle. So LMP 2.7, 3 and 2. So next triangle is DF. So DEF. So here sides are 4, 6 and 5. Now which side, comparing which side and which side, there will be a confusion. First, my recommendation is go to the highest side. Here in the first triangle, the highest side is 3, lengthiest side, and here the lengthiest side is DF, which is equal to 6. So I'll go for LP by DF. LP by DF is equal to 3 by 6. So 3 1s are 3, 2 2s are 6. Then I'll go for the lowest side. Lowest side here is MP, which is 2. Here it is D 4. Okay. Now I'll MP by D is equal to 2 by 4. This is equal to 1 by 2. 2 1s are 2, 2 2s are 4. Now the remaining side is LM by EF is equal to 2.7 by 5. So here it is not divisible, and even if it is divisible, you won't get the ratio as the previous one. Here 1 by 2, again if you further divide, you will get 0.5. Here definitely you won't get 0.5, it will be something else. So these two ratios are equal, but this ratio is not equal. This turns out to be 0.5, this also turns to be 0.5. This you can try it out, it won't be 0.5, it will be less than 0.5. So this is different. So the ratio of the sides are not equal. Therefore the given triangles are not similar, because the given ratios, the ratio of the corresponding sides are not equal. Exercise 2.3, first question, sub question 4. So the given triangles are MNL of side 2.5, here 5, and the included angle is 70 degree. And there is another triangle PQR. So 5, here 70 degree and 10 degree, of side PQ is 5 and QR is 10. Now here in this two triangle, we can see that two sides and one angle are given in both the triangles, and the angle is equal to 70 degree in both the case. In both the triangle, one angle is equal to 70 degree. Now let me first check these sides. Now here the highest side is 5 in the first triangle, and in the second triangle the highest side is 10. So I'll check ML by QR. ML by QR is equal to 5 by 10 this is equal to 5 1s are 5, 5 2s are 10. And here in the first triangle the lowest side is 2.5. In the second triangle the lowest side is 5. So I'll go for the lowest side ratio. Now MN by PQ, this is equal to 2.5 by 5. This is also equal to 1 by 2. Now angle M is equal to angle Q. So one angle is equal and the sides of the angle are proportional to the sides of the angle in the second triangle. Therefore these two triangles are similar. So the two triangles are similar according to side angle side criteria, side angle side criteria. So in symbolic form, MNL, triangle MNL is similar to triangle PQR. So according to SAS criteria, if one angle of a triangle is equal to the another angle of a triangle and the two sides of the angle are proportional to the two sides of the other triangle, then those two triangles are similar. Now question number 5. Let me bring this little higher. Okay, now you can see the figure. So here the first triangle is ABC. One angle is 80 degree, side is 2.5, and here it is 3. There is another triangle DEF. So here sides are 6 and 5, and one included angle is given 80 degree. So first I'll go with the sides. In the first triangle, highest side is BC, which is 3 centimeter, and in the second triangle the highest side is EF, that is 6. Okay, now BC by EF is equal to 3 by 6 is equal to 1 by 2. 3 1s are 3, 3 2s are 6, and the lowest side now is 2.5 here in the first case. In the second triangle, lowest side is 5. So AB by DF is equal to 2.5 by 5. This is also 1 by 2. Now what about the angle? One angle is equal, but will SAS criteria apply to this triangle? No, it doesn't apply, because according to SAS criteria, one angle should be equal and the sides corresponding to that angle should be proportional to the sides of the other triangle which has that included angle. So here angle F is the included angle with the given two sides in the second triangle. In triangle DEF, angle F is the included angle included angle between the known sides. Okay, but here in first triangle, angle A, which is equal to 80 degree, this is not the included angle with the known side. So these two can't be similar triangles. Instead of angle A, if angle B were 80 degree, then we could have concluded that these two are similar according to SAS criteria. Now with the given data, we can say that it's not similar. The given triangles are not similar. So actually speaking, here the given data is not sufficient. They should have given what's the angle of B. If angle B were given, we could have concluded, but B is not known. So in fact we can't conclude whether these two triangles are similar. So let us see what's the answer they have given. So exercise 2.3 problem number 5. So they have told it's not similar triangles. Exercise 2.3 problem number 1, sub question 5, it's no. But according to me, the given data is not sufficient to tell that these two are similar or not. Okay, I'll go for the next question. I'll hide the answers. Next, sub question 6. So two triangles are given, DEF, DEF. So it's 70 degree, here it is 80 degree. PQR 80 degree, 30 degree. Now here you can see that angle D is equal to one second. In the first triangle, what is angle F? So angle F is 180 minus. So angle F is equal to 180 degree minus 80 plus 70. The sum of all the angles are equal to 180 degree in a triangle. So angle F will be 180 minus 70 plus 80. So 180 minus 70, 140, 150. So 150, this is equal to 30 degree. So angle F is equal to 30 degree. Now angle E of first triangle is equal to angle Q of second triangle, which is equal to 80 degree. So angle F of the second triangle of the first triangle is equal to angle R of the second triangle, which is equal to 30 degree. So third angle, it's not necessary to consider. Even if two angles of one triangle are equal to corresponding two angles of the second triangle, then we can conclude that those two triangles are similar according to AA criteria. So the two triangles are similar according to AA criteria. AA criteria of similarity of triangles. So I'll write PEF is similar to PQR. Sorry, triangle PEF similar to PQR. That finishes this first problem. Question number 2. So in figure 2.35, ODC is similar to OBA. Given ODC, triangle ODC is similar to OBA, triangle OBA, and BOC is equal to 125 degree, and CDO 70. Angle CDO is equal to 70 degree. Find angle DCO and OBA. So figure is like this. So this is O, A, B, C, D. This angle is 70, angle D. This is 125 degree. find DOC, DCO and angle OBA. So see here, given OBC, triangle OBC is congruent to similar to OBA, right? Therefore angle O is equal to angle here O is actually okay, I'll write like this, DOC. Therefore angle DOC is equal to AOB, and angle B, sorry, this is ODC. ODC is similar to OBA. So now angle ODC is equal to OBA, angle OBA, and DCO is equal to angle BAO, right? Now angle DOC, will first find angle DOC. So angle DOC will be equal to 180 degree minus 125. So this is, since BD must be straight line, so therefore BOD is 180 degrees. So angle DOC will be 180 degree minus 125. This is 55 degree I'll get DOC. Okay, so DOC is equal to AOB. Therefore AOB is equal to 55 degree, because vertically opposite angle, vertically opposite side, angle. And now ODC. Now what is ODC? Angle ODC is equal to sum of the three angles of a triangle is 180 degree. Therefore angle ODC will be equal to 180 degree minus angle COD plus ODC. So this is 180 degree minus COD is just now we found it is 55 degree plus ODC is 70 degree. So this is 180 minus 125, so this is 55 degree. ODC is 55 degree. Therefore OBC is equal to ODC. Therefore OBA is equal to angle OBA is equal to ODC is equal to 55 degree. Now BAO is left, BAO or OBA. Okay, now angle BAO angle BAO is equal to DCO BAO is equal to angle ODC. So ODC is 70 degree. Therefore BAO is equal to 70 degree. So ODC is 70 degree, that is given in the data by given data. So all the three angles are found. BOC is 55, then OBA is 55, and BAO is 70 degree. Oh, only these three are the answers. This and this are the answers. Okay. Exercise 2.2, question number 3. So diagonals A, C and BD of a trapezium ABCD. So ABCD. So AB C D. AB is parallel to DC. So AB is parallel to DC and the diagonals intersect each other at point O. So this is point O. So using similarity criteria of two triangles, show that, okay, so given data ABCD is a trapezium and AB is parallel to CD and diagonal intersect at point O. So we should show that OA by OC is equal to OB by OD. This is the question. So we should use the similarity criteria for two triangles. That criteria we should use, and we should prove this now. Since AB parallel to CD, angle A is equal to angle C, so that this angle is equal to this angle. This is alternate angles. So similarly, angle B is equal to angle D. So this angle is equal to this angle, and this AOB is equal to DOC. This angle is equal to this angle, vertically opposite angles. So AOB is equal to DOC. Therefore three angles are equal. Therefore triangle ABO and DCO are similar triangles. So if two triangles are similar, then their sides are proportional. Similar triangles. So AAA criteria. Okay, according to AAA criteria, these two triangles are similar. Therefore their corresponding sides are proportional. So we already read this in theorem 2.3. If three angles are of a triangle are equal to three angles of another triangle, then those two triangles are similar and their sides will be proportional. So therefore side AB by side DC will be equal to side AO. Sorry, I'll write OA instead. OA by OC is equal to OB by OD. So this is what we needed. So the proof is complete. Question number 4. In figure 2.36, QR by QS is equal to QT by PR, and so this is the given data, and given that angle 1 is equal to angle 2. So let me draw the diagram. Diagram is like this. So this is Q, this is R, this is L, this is P, and this is T. So PR, there is PR here. So this is angle 1 and this is angle 2, to show that PQS is similar to triangle TQR. So now in triangle QPR, see, in triangle QPR, angle 1 is equal to angle 2, right? Therefore angle QPR, therefore triangle QPR is an isosceles triangle. Therefore QP is equal to PR. QP is equal to PR. I'll mark this as 1. So that means QP is equal to QR. These two sides are equal. Now I'll draw these two triangles separately. Triangle QPS is like this. So QPS, and I'll draw QTR also. So I'm drawing those two triangles separately so that we can read it easily. That's why I'm drawing separately. So this is QTR. See, in both the triangles, angle Q is common. Okay, here the measurement of Q is 1, and here also the measurement of Q is 1. Q is common to both the triangles. Now given in the data, given that QR by QS is equal to QT by PR. So now PR is equal to QP. PR is equal to QP. We just now found out. So I'll in place of PR I'll put QP. So QR by QS is equal to QT by QP. Now you see the diagram now. QR by QS is equal to QT by QP. They are the ratio of the sides. Okay, QR is the ratio of the second triangle, QS is the ratio of the first triangle here, QT is the ratio, QR is the side of the second triangle, QS is the side of the second triangle, again is equal to again QT is the side of second triangle, and QP is the side of the first triangle. They are the ratio of the sides, and the ratio of the sides are equal, and also one angle is common, that is PQS is equal to TQR. Therefore according to side angle side criteria, therefore according to side angle side criteria, triangle QPS is similar to QTR. These two triangles are similar. One angle is common, and the sides of the included angle, they are in a definite ratio. That's why these two triangles are similar. Question number 5. So S and T are points on the sides PR and QR of PQR such that angle P is equal to angle RTS. So there is a triangle PQR PQR. So PQR. So PQR is a triangle such that S and T are points on sides PR. So S is a point on side PR. So this is S, and T is a point on side QR. Here T is a point on side QR, and angle P is equal to angle RTS. RTS. Okay, angle P is equal to angle RTS. Angle P is equal to angle RTS. So that angle RPQ is similar to RTS. So given data is PQR is a triangle. Angle P is equal to angle RTS. We need to prove that. To prove that RPQ, triangle RPQ is similar to RTS. So this we need to prove. Now I'll draw these two triangles separately. Okay, PQR. This is PQR, PQ, and this is R. Now I'll draw this RTS triangle separately. Why I am drawing separately is so that it's easy to visualize. Now given that angle P is equal to angle T, this is STR. Angle P is equal to angle T, is it not? Now angle R is common to both the triangles. That is, this angle is equal to this angle here. Now these two data are sufficient to say that these two triangles are similar according to AA criteria. So two angles of triangle PQR and two angles of STR are equal. Therefore, they are similar. So I'll write angle P is equal to angle RTS, and angle R is common to both triangles. Therefore, according to AA criteria of similarity of two triangles, criteria of similarity of two triangles, the given two triangles are similar. That is, triangle RPQ is similar to RTS. Question number 6. So in figure 2.37, ABE. So there's a big triangle. ABC. Sorry, here there's another line AD. Sorry, this is D, this is E. Now B and D are joined, and D and C are joined. This is the figure. So the question is, in triangle, in figure 2.37, triangle AB is congruent to ACD. Given data, ABE, triangle ABE is congruent to ACD. So if two triangles are congruent, then corresponding angles are equal. So AB is congruent to ACD. That means angle A is equal to angle A. This is common angle. Angle A is common to both the triangles, and angle B is equal to angle C. Okay. Now angle E is equal to angle D. So this one is confusing. I'll write like this. Instead of angle B, I'll write ABC. ABC is equal to angle ACD. This is more understandable. And here E, I'll write AEB. Angle AEB is equal to angle ADC. So since these two triangles are congruent, all the corresponding angles are equal. Angle A is common, so ABC, angle ABC is equal to ACD, and angle AEB is equal to ADC, angle ADC. So we should show that to prove what we should to prove, triangle ADE is similar to triangle ABC. We should prove ABC. Now proof. Since triangle ABE is congruent to triangle ACD, the angles are equal. Already I have written in the data. Okay. Now also, if two triangles are congruent, the sides also, corresponding sides also will be equal. That means AB is equal to AC. AB is equal to AC. Then BE will be equal to DC. Sorry, this is just side. So side B is equal to side DC. Then which is the other side? AE is equal to DA or AD. Okay, and this angle symbol is coming. Okay. So are you able to understand? See, there is one I am writing this triangle separately so that it's understandable nicely. This is ABE, triangle AB I have written separately, and triangle AD, ACD. This is ACD. So in these two triangles, this side AB is equal to AC, then AE is equal to AD, and B is equal to DC. So I have written these two triangles separately so that you can understand nicely. Okay. This is 3. I will mark all these 3 equalities as 1. Now I will come to triangle. In triangle ADE and ABC, there are some things which we need to mention here. Triangle ADE and ABC. Now in these two triangles, angle A is common. Okay, angle A is common. So I'll write these two triangles separately. AD, this is angle, this is triangle ADE. So ABC is bigger triangle, and these two triangles are overlapping upon one another. This is ABC. The same figure I have drawn in a different way drawn two triangles separately. So angle A is common between these two triangles, right? Now in these two triangles, already we know that AD and AE are equal from equation 1 we already know AD is equal to AE. Let this be x centimeter, this also be x centimeter. These two are equal, therefore both are x. And let AB and AC also are equal from equation 1, so let this be y. And so since these two are equal, this also will be y. Now I'll just take the ratio. So I'll take AD by AB. What is AD by AB? AD by AB is equal to y by x. Now I'll take what AE by AC. AE by AC also is equal to y by x. So what is the meaning of this? The sides are proportional. So according to SAS, criteria of similarity of two triangles, these two triangles are similar. Angle A is common, and the ratio of the sides also are constant, which is coming to be x by y. So one angle is equal and two sides are proportional. So therefore triangle ADE is similar to ABC according to side angle side criteria. That completes this problem. Question number 7. So in figure 2.38, altitudes AD and C of triangle ABC intersect each other at the point P. So diagram is like this. Question 7. This is point C, this is point A, this is point B. Now from A there is one perpendicular like this to D, and from C there is a perpendicular to AB, which is E, and this point is P. Now prove that. Okay, let me first write the data. So altitude AE, AD and AC of ABC intersect each other point E. AD and AE are altitude which intersect at point P. Okay. Now we should prove that triangle AEP is similar to CDP. Triangle ABD is similar to triangle CBE, and triangle AEP is similar to triangle ADB, and fourth one is triangle PDC is similar to triangle BEC. To prove, so first case, triangle AEP is AEP. So in triangle AEP and CDP, triangle AEP and CDP. So angle APE is equal to CPD. So vertically opposite angle. So these two angles are equal. And now angle AEP is equal to angle PDC. So because they are 90 degree. Okay, since C is the altitude, therefore here the angle will be 90 degree, and similarly AD is the altitude. AD is the altitude if you consider BC as the base. So these two angles are equal. Therefore, according to AA criteria of similarity of two triangles, triangle AEP is similar to triangle CDP. So if two angles of one triangle are equal to corresponding two angles of another triangle, then those two triangles are similar. So here two angles are equal, that's why we can conclude that those two are similar triangles. Next, triangle ABD. So we'll check in triangle ABD and triangle CBE. So in triangle ABD and CBE, angle B is common. Angle B is equal to angle B. B is common angle. Angle B is common angle. And angle ADB, angle ADB is equal to angle CB, which is equal to 90 degree, because C is the altitude if we consider AB as the base, and AD is the altitude if we consider BC as the base. So altitude always forms an angle of 90 degree to the base. So now two angles are equal. Therefore, according to AA criteria, you can write it down. Triangle ABD is similar to triangle CBE. Next, third one, AEP and ADB. AEP and ADB. So in triangle AEP and triangle ADB, angle is common to both triangles. Now angle AEP is equal to ADB, angle ADB, which is equal to 90 degree. So here also same reason, since CE and AD are altitudes, they form at an angle of 90 degree. Therefore again, according to AA criteria, the given triangle AEP is congruent to ADB. Next, fourth sub question, PDC and BEC. So in triangle PDC and BEC and triangle BEC. So in PDC and BEC, angle C is common in both cases. Angle C is common angle, and angle PDC. Angle PDC is equal to BEC, angle BEC. So these two angles are equal. So therefore what? According to AA criteria of similarity of two triangles, triangle PDC is similar to triangle BEC. Question number 8. Is a point on the side AB produced of a parallelogram ABCD and B intersects CD at F. Show that ABE, triangle ABC, is similar to triangle CFB. So 8, there is a parallelogram ABCD, and E is a point on side AD produced. So AD is produced, and there is a point E on it, and B intersects CD. B intersect CD at point F. So given data, ABCD is a parallelogram. B intersect CD at F. So B intersects CD at F. So I need to prove that ABE, triangle ABE is similar to triangle CFB. So proof. Now in a parallelogram, opposite sides are parallel, and also another important thing in this is opposite angles also are equal. Therefore angle A will be equal to angle C. So and since BE is intersecting CD, here we get an vertically opposite angle which are equal. Okay. Now in triangle ABE and BCFB and triangle CFB, angle A is equal to angle C, and angle BFC is equal to DFE. So two angles are equal. So according to AA criteria of similarity of two triangles, triangle ABE is similar to triangle CFB. Question number 9. So now can you see the figure now? So in figure 2.39, ABC and AMP are two right triangles, right angle at B and M respectively. So the figure is like this. There are two triangles, right angle triangles. This part is A, P, this is C, this is B, and this is M. So these two are right angle triangles, right angled at B and M respectively. Prove that. So I'll write the given data. ABC and AMP are right angled triangle. Okay. They are right angled at B and M respectively. Now I should prove that. To prove, I should prove that triangle ABC is similar to triangle AMP. This is first one, and also I need to prove that CA by PA is equal to BC by MP. So proof. So in triangle ABC and AMP, angle A is common. Angle A is common to both the triangles, and angle B is equal to angle M. So they are 90 degrees. This is the given data. Therefore two angles are equal. If two angles of one triangle are equal to corresponding two angles of another triangle, then they are similar. Therefore, according to AA, criteria of similarity of two triangles, triangle ABC is similar to AMP. Now second sub question, I should prove that CA by PA is equal to BC by MP. So here, since these two triangles are similar, that is in triangle ABC and AMP, they are already similar. They are already similar. We proved it. Therefore, we can take the ratio of the sides. Now, AC by AP will be equal to BC by MP. So reason is, since these two triangles are similar. When two triangles are similar, their corresponding sides will be of same ratio, or the corresponding sides are proportional. Question number 10. CD and GH are respectively the bisectors of angle ABC and EGF, such that D and H lie on the sides AB and FE of triangle ABC and EFG respectively, if ABC is congruent is similar to FEG. So there are two triangles, triangle ABC and another triangle which is ABC, and there's another triangle ABC and EFG respectively. So now CD is the angular bisector of angle C, and GH is the angular bisector of G. So D lies on AB, H lies on FE. So given data are CD is bisector of angle C in triangle ABC, and GH is bisector of angle G in triangle EGF. So these lines are bisecting, and D lies on AB and H lies on FE, and also given that these are the given data, and also given that triangle ABC is similar to EGF, FEG, triangle FEG. So when these two triangles are similar, therefore angle A will be equal to angle F, angle B will be equal to angle E, angle C will be equal to angle G. Now we need to prove. What we need to prove? So we need to prove that CD by GH is equal to AC by FG, and next is DCB. Triangle DCB is similar to triangle HGE, and third one is prove that triangle DCA is similar to triangle HGF. So first of question will take. Now in triangle ADC, and FHG, angle A is equal to angle F, two angles are equal, angle D is equal to angle H. Sorry, here these two angles they can't be equal. Their CD is not altitude, and GH is not altitude. I thought it's altitude, so it will be 90 degree I thought, but it's not altitude. CD is bisector. It only bisects angle C, but it can form at any angle on AB. Similarly, GH is not altitude, it's a bisector, so it can form any angle on side FE. But angle ACD is equal to FGH, because angle C and angle G are equal, and CD is bisector. That means ACD is half of angle C. Similarly, here FGH is half of angle G. Therefore, ACD is equal to FGH. Therefore, according to AA criteria of similarity of two triangles, I can conclude that triangle ADC is congruent to triangle HG. Sorry, they are not congruent, they are similar. So if they are similar, then the ratio of the sides are constant. That means CD by GH is equal to AC by FG. So since these two triangles are similar, their ratio of the sides, corresponding ratio of the sides will be constant, or we can say the corresponding sides are proportional. So that proves sub question 1. Sub question 2, I should prove that DCB is similar to HGE. So in triangle DCB in triangle DCB and triangle HGE, so angle B is equal to angle E, and angle BCD, angle BCD is equal to EGH. So the reason is same as the above. Okay, in sub question 1 whatever reason I gave, same reason applies here. Therefore according to AA criteria, triangle DCB is similar to triangle HGE. Now third sub question. So prove that DCA and HGF, triangle DCA is similar to HGF. So in triangle DCA and HGF, so this already I have proved in the first sub question itself. According to first sub question, according to my answer in first sub question, it's already proved that these two triangles are similar. Next question is question number 11. So in figure 2.40, E is a point on side CB produced of an isosceles triangle ABC with AB is equal to AC. If AD is perpendicular to BC and EF perpendicular to AC, prove that ABD is similar to ECF. So question number 11. So the figure is like this. There's a triangle ABC, and what is AD? AD is perpendicular to BC. That means this is 90 degree. Then BC is produced. Is a point on side BC produced of isosceles triangle. So ABC is an isosceles triangle, means AB, length of AB will be equal to length of AC. With AB is equal to AC. AB is equal to AC, it's already given in the data. AB is perpendicular to BC, EF is perpendicular to AC, and BC is produced, and there is a point on BC, that is E, point E. From E there is a perpendicular is drawn to AC, and that perpendicular meets at F. EF is perpendicular to AC. Prove that ABD is similar to EFC. So given data, triangle ABC is an isosceles triangle. AB is equal to BC, and AD is perpendicular to BC, and EF is perpendicular to AC. Then I need to prove that that triangle ABD is similar to triangle ECF. So here in these two triangles ABD and ECF, only two things are matching. See, EF is perpendicular to AC, so this is also 90 degree. So angle ADB is equal to EFC, but there's nothing other else which are equal. So what can I do is, first I will prove that ABD is similar to ADC. Though these two triangles are similar, I'll prove it. Then I'll prove that ADC is similar to triangle EFC. Okay. Now proof. So in triangle ABD and triangle ADC. So in these two triangles, angle ADB is equal to ADC, which are equal to 90 degree. Okay. The reason is AD is perpendicular to BC. So since ABC is an isosceles triangle, angle B also will be equal to angle C. So angle B is equal to angle C. So two angles are equal. Therefore triangle ABD is similar to ADC. AA criteria, according to AA criteria of similarity of two triangles. Now in triangle ADC and ECF. So in these two triangles, one angle is 90 degree and there is another angle which is common to both the triangles. Okay. So now angle EFC is equal to ADC. Okay. And angle C is common. Angle C is common to both triangles. Therefore triangle ADC is similar to EFC. These two triangles are similar because two angles are equal. According to AA criteria, they are similar. Criteria of similarity of two triangles. Now see, this I'll mark as 1, this I'll mark as 2. From 1 I'll get triangle ABD is similar to triangle ADC. And from 2 I'll get ADC is similar to EFC, triangle EFC. Therefore ABD is similar to EFC. Therefore triangle ABD is similar to triangle ECF. This proves the problem. This is 2. From 1 and 2. Question number 12. So side AB and BC are, and median of AB and median AD of a triangle ABC are respectively proportional to sides PQ and QR and median PM of PQR. Show that triangle ABC is similar to PQR. So the figure is like this. there are two triangles, triangle ABC, and AD is the median. So median means it cuts this line BC into two equal parts. Okay, and this triangle PQR, here also there is a median PM. So it cuts QR into two equal parts. So QM and MR will be equal. So here AB and PQ are proportional. Okay. So given data is AB by PQ is equal to BC by QR is equal to AD by PM. So two sides and median or sides are proportional, and also median also is proportional to the sides. Ratio of the median also is proportional to the ratio of the sides. So we need to prove that triangle ABC is similar to triangle PQR. So now I'll take the given data itself. AB by PQ is equal to BC by QR is equal to AD by PM. AD by PM. Now in AD by PM, oh sorry, not this one, BC by QR. So I'll take BC by QR I'll take. So I'll divide both numerator and denominator by 2. BC by 2 divided by QR by 2. If I divide both numerator and denominator by the same constant, the value will not change. Now here what is BC by 2? BC by 2 is BD. You can see the figure. BD is half of BC. So BC by 2 is BD, and QR by 2 is QM. QM is half of QR. So QM. Now I'll write this given data as it is. AB by PQ. So in place of BC by QR, I'll write BD by QM. This is given data. So in place of BC, I'll write BD, and in place of QR, I'll write QM. So the value is not changing, and AD by PM. Now you can see in all these three ratio, their ratio of the sides of triangle, the above are ratio of the sides of triangle ABD and triangle PQM. Therefore, when the ratio is a constant or when the sides are proportional, the triangles will be similar. Therefore, triangle ABD is similar to triangle PQM. So when two triangles are similar, their corresponding angles will be equal. So therefore angle B is equal to angle Q. So angle B will be equal to angle Q. So now in triangle ABC, I'll mark this as 1. In triangle ABC and triangle PQR, so angle B is equal to angle Q. Just now we proved it. And now AB AB by PQ is equal to BC by QR. This is the given data. So in these two triangles, uh, one angle is equal and the ratio of the sides of the two sides of the given angle, they are equal. Therefore, according to side angle side, therefore according to SAS criteria, the two triangles are similar. That is, triangle ABC is similar to triangle PQR. Question number 13. D is a point on the side BC of a triangle ABC such that ADC is equal to PAC. Show that CS square is equal to CB into CD. So there is a triangle ABC. So there is a triangle ABC and D is a point. D is a point on BC, side BC. D is such that angle D is equal to angle A. So given data ADC is equal to BAC. Angle ADC is equal to angle BAC. So we should show that CA square is equal to CB into CD. CB into CD we should show. So proof. This is to proof. See, now I'll draw ABC and ADC separately. Now ABC I'll draw separately. Triangle ABC, and I'll draw ADC also. So ADC is like this. See, now given that ADC is equal to BAC, that means here this angle BAC is equal to, so this is ADC, right? ADC is equal to BAC. It is given data, and angle C is common. Angle C is common to both the triangles. So this is angle C. So this angle is common to both the triangles. So two angles are equal. Two angles are equal in this triangle. Therefore, these two triangles should be similar. So in triangle ABC and ADC, ADC is equal to BAC. This is given data, and angle C is common to both the triangles. Therefore, according to AA criteria of similarity of two triangles, triangle ABC is congruent to ADC. These two triangles are congruent. Therefore, sides are proportional. Therefore, AC by DC will be equal to BC by AC. If I take this AC to the left hand side, so AC into AC is equal to BC into DC, or AC into AC is AC square is equal to BC into DC. AC square and CA square both are same. So, and the BC and CB is same, BC into CD. So, this is what I was supposed to prove. Question number 14. Sides AB and AC and median AD of a triangle ABC are respectively proportional to sides PQ and PR and median AM of another triangle PQR. Show that triangle ABC is similar to triangle PQR. See, the diagram is same as for the question 12. For the question 12, diagram is 2.41. For 14 also it's the same diagram. There are two triangles ABC and AD is the median. So, if AD is the median, BD will be equal to DC. And there is another triangle PQR, PQ and R, and PM is the median. PM is the median. If PM is the median, QM will be equal to MR. So, given that AB by PQ is equal to AC by PR is equal to AD by PM. This is the given data. I'll mark this as 1. So, we should prove that to prove triangle ABC is similar to triangle PQR. So, to proof, so I'll make some construction. I'll extend AD to up till E such that AD is equal to DE. So, I'll make an extension and I'll join EC and BE. Similarly, here also I'll extend PM up till N, and I'll join NR and QN. So, I am drawing in dotted lines. In examination, you can write in real bold lines. So, extend AD to E such that AD is equal to DE, and join DE and BE. Similarly, extend AM to N such that AM is equal to MN. So, AM will become MN, and join NR and QN. Now, in triangle ABD and triangle DEC. So the first figure, the first triangle, in that one we get two triangles ABD and DEC. Now these two triangles are congruent. You can see this is vertically opposite angle. Okay, angle ADB is equal to EDC. These are vertically opposite angle. Then BD is equal to DC, because AD is the median. AD is median. So that's given in the data itself. And also now AD is equal to DE. By construction I got that. So these two triangles are congruent now. One angle is equal, and the side including those angle are equal to the side including of the other angle, other triangle. Side including the angle of the other triangle. So therefore ADB, triangle ADB is congruent to EDC, triangle EDC, by side congruency rule. So you have studied congruent triangles in your previous class. So there is difference between congruent triangles and similar triangles. What is that? If two triangles are congruent, the angles, corresponding angles will be equal, and also corresponding sides will be equal. If two triangles are similar, corresponding angles will be equal, but corresponding sides will be proportional. Here these two triangles are congruent, so all the corresponding sides should be equal. So we already know DB is equal to DC, AD is equal to DE. Therefore AB will be equal to EC. So this I will mark as 2. Now again, if you come to in triangle PQM, in triangle PQ and MNR, in these two triangles also you can apply the same logic as in the previous case and say that these two are congruent. So like PMQ is equal to NMR, vertically opposite angles. Now QM is equal to MR. So this is the given data, because PM is the median. Given data. Next, side PM is equal to side MN. I got it by construction. Therefore these two triangles are congruent. Therefore triangle PQM is congruent to MNR according to side angle side. Two sides are equal and the two corresponding sides are equal, and the angle between those two sides is equal to the angle of the other triangle. So according to SAS congruency rule, these two are congruent. Therefore PQ will be equal to NR. So here AB is equal to EC, here PQ is equal to NR. So I will mark this as equation 3. Now I'll consider equation 1. So I'll write here. Now what the equation 1 says? According equation 1 says AB by PQ is equal to AC by PR is equal to AD by PM. Now AB is equal to EC according to 2 and PQ is equal to NR according to 3. Therefore in place of AB I'll write EC. So EC by NR, PQ is equal to NR is equal to AC and PR I'll write as it is equal to. Now AD by PM, in this one I'll multiply by 2 in the numerator and in the denominator. When I do like this, there's no change. So from 2 and 3, from 2 I substituted AB is equal to EC, from 3 I substituted PQ is equal to NR. Now the above ratio are ratios of sides of triangle AEC, triangle AEC and triangle PNR. See, if you observe the above ratio here, it's the ratio of the sides only. EC is the side of triangle AEC. NR is the side of triangle PNR. Similarly, AC by PR. And now again I'll write that again. So EC by NR is equal to AC by PR. Now AD into 2. AD into 2 is AE. AD into 2 is AE. AE is twice of AD. And PM into 2 is PN. So twice of PM is PN. See, now this is the ratio of the sides of these two triangles, triangle AAC and triangle PNR, and those ratios are equal. Therefore I can conclude that triangle AEC is similar to triangle PNR. So if they are similar, the angles will be equal, corresponding angles will be equal. Therefore angle EAC is equal to NPR, angle NPR. Say let this is x degree. So I'll write this x degree. Now again I'll consider equation 1. One says that AB by PQ is equal to AC by PR is equal to AD by PM. Now again I'll put AB is equal to EC. So EC, PQ I'll put as NR. From equation 2 and 3 I got it. So AC by P. Just hold on a second, I missed out something. See, just like I derived 2 and 3, I can also say that, prove that. Similarly, triangle ADC is congruent to BDE. Triangle ADC will be congruent to BDE, and AC, side AC will be equal to side BE. So you give the reason and prove it, it's left to you. This I'll mark as 4. Similarly, I can prove that triangle PMR, triangle PMR is congruent to triangle QMN. Therefore, PR will be equal to CN. This I'll mark as 5. So for these two, for equation 4 and 5, to derive this one, give the proper reason and prove it. Now I'll come back here to equation 1. Equation 1 is AB by PQ is equal to AC by PR is equal to AD by PM. Now AB by PQ I'll retain as it is AB by PQ. In place of AC I'll put BE from 4. So AC is BE now here, BE, and PR is CN from 5. Okay, and here AD by PM, AD by PM. To the last ratio I'll multiply by 2 and divide by 2. Then there won't be any change. Now you can see this becomes AB by PQ. AB by PQ is equal to B by CN. B by CN is equal to twice of AD. Now twice of AD is AE, and twice of PM is PN. Now this ratio are nothing but ratio of the sides of the triangle ABE and PQN. Okay, therefore the above are ratios of sides of triangle ABE and PQN. Therefore these two triangles are similar. Therefore triangle ABE is similar to triangle PQN. Therefore angle BAE is equal to angle QPN, angle QPN. Say, let us say it is y degree. So my BAE is y and QPN is y. Now you can notice another thing here. Now both angle P and angle A and angle P are equal. Okay. Now the last explanation I'll write here. Now in triangle, now angle A is equal to angle P, angle this is equal to x plus y. Both the angles are equal. Therefore triangle ABC is similar to triangle PQR. We already know that AB from given data AB by PQ is equal to AC by PR. This is the given data. So now you can see two angles are equal and the sides including that angle are proportional. Therefore according to SAS, side angle side criteria for the similarity of two triangles, these two triangles are similar. Therefore triangle ABC is similar to triangle PQR. PQR according to SAS, side angle side criteria of similarity of two triangles. That completes proof. Question number 15. A vertical pole of length 6 meter casts a shadow of 4 meter long. So there is a pole of 6 meter and it will cast a shadow of 4 meter. So pole is 6 meter, shadow is 4 meter. So on the ground, at the same time, a tower casts a shadow of 28 meter long. So there is a tower here, and that tower is casting a shadow of 28 meters. So what is the height of the tower is the question. What is the height? So I'll take this as ABC, and this as PQR. See, this is 90 degree. See, if the height of the pole or tower, whatever it is, if the height is very too much, then the shadow also, the length of the shadow also will be too long. If the height of the tower is short, then the length of the shadow also will be short. So this is actually a similar triangle with similar equal angles. Okay, angle B will be 90, which is equal to angle Q 90, and angle A will be equal to angle P, and angle C will be equal to angle R. These two are similar triangles. So let me, okay, height. So in triangle ABC and PQR, angle A is equal to angle P, angle B is equal to angle Q, which is equal to 90 degree, and angle C will be equal to angle R. So according to AA criteria, these two triangles will be similar. Therefore, triangle ABC is similar to triangle PQR. So sides will be proportional now. So therefore, AB by PQ will be equal to BC by QR. So AB is nothing but length of the vertical pole, that is 6. Its shadow of that vertical pole is 4 meter, which is BC. Then BC, the height of the tower, which we need to find. So H, and QR is the shadow of the tower, which is 28. So H will be 6 into 28 by 4. 4 ones are 4, 4 ones are 4. 4 5 0 4 6 4 7 are 28. So H is equal to 42. So height of the tower is 42 meters. Let us check the answer. So answer exercise 2.3, problem number 15, 42 meters is the right answer. Question number 16. So if AD and PM are medians of a triangles ABC and PQ respectively, where triangle ABC is similar to triangle PQ, prove that AB by PQ is equal to AD by PM. Can you see the, okay, you can see. So there is two triangles ABC, ABC and PQR, PQR, and AD is the median. AD is the median means it divides base into two equal parts. So, and there is PM median. PM is the median of QR. So it divides QR into two equal parts. Now, given that given data is triangle ABC is similar to triangle PQR. So what it means? This sides, this ratio of the sides are equal. That means AB by PQ will be equal to BC by QR will be equal to PR. Sorry, it is equal to AC by PR. So I'll mark this as 1. Now we should prove that AB by PQ is equal to AD by PM. So proof. So first, in triangle ADC and PQR, so given that these two triangles are similar, therefore AB by PQ, AB by PQ is equal to BC by QR is equal to AC by PR. So since they are similar, since the triangles are similar, angles will be equal. Angles will be equal. Therefore, angle B is equal to angle Q, right? Angle B will be equal to angle Q, and all the other corresponding angles also will be equal. I am considering only B and Q. Angle B will be equal to angle Q. Now, I will consider the equation AB by PQ is equal to BC by QR. This is from 1 or data or the given data. Okay, given data. Now in this one, AB by PQ is equal to, now here in the right hand side I will divide by 2, both in the numerator and the denominator. So this becomes BC by 2 is BD and QR by 2 is QM. So now in triangle ABD and PQM, okay, angle B is equal to angle Q, we already know that. See, I'll mark that as 2 and this I'll mark as 3. See, from 2 and 3 we can conclude that ABD is similar to PQM. From 2 and 3 we can conclude that triangle ABD is similar to triangle PQR, because one angle is equal and the ratio of the sides of that angle they are also equal. That is, AB by PQ is equal to BD by QM. So, and the reason is side angle side by side angle side criteria, ABD, triangle ABD and PQM are similar to one another. So if they are similar, their sides will be proportional. Therefore, AB by PQ is equal to BD by QM will be equal to AD by PM. So, and it is proven. We were supposed to prove AB by PQ is equal to AD by PM. The next topic in this chapter is areas of similar triangles. Areas of similar triangles. So, theorem 2.6. So this is chapter 2, sixth theorem. That's why it's theorem 2.6. The ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding sides. So there are two triangles. So these two triangles are similar. A, B, C, P, Q, R, and AM. AM is the altitude, height, and PN. PN is the height of the second triangle. So the ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding sides. So given data is triangle ABC is similar to triangle PQR. So if two triangles are similar, then the corresponding sides will be proportional. Therefore, AB by PQ is equal to BC by QR is equal to AC by PR. This I'll write as equation 1. Now, the theorem says the square of the ratio of their corresponding the ratio of the areas of the two similar triangles is equal to the square of the ratios of their corresponding sides. So according to the theorem, area of ABC by area of PQR is equal to AB square. AB by PQ square is equal to BC by QR square is equal to AC by PR square. So theorem says the ratio of the areas of the similar triangle is equal to the square of the ratio of their corresponding sides. So this is what we need to prove. So let us prove it. Proof. See now, in triangle ABC, what is the area? Area is given by half base into height, right? So half base in triangle ABC, base is BC and height is AM. I'll mark this as 1, sorry, this as 2. Now in triangle PQR, in triangle PQ, area of PQR is equal to half base into height. So half base is here QR into height is PN. I'll mark this as 3. Now 1 divided by 3, equation 2 by 3 gives area of ABC by area of PQR is equal to half BC into AM divided by half QR into PN. So here this half will get cancelled. I am left with BC by QR into AM by PN. So here you can see AM by PN is the ratio of the altitude. I'll mark this as equation 4. Now in triangle ABM, in triangle ABM triangle PQN. See, in these two triangle, angle B is equal to angle QR. Angle B is equal to angle Q. Why? Because already triangle ABC is similar to triangle PQR. Therefore, angle B will be equal to angle Q, right? So here in triangle ABM and triangle PQN, angle B is equal to angle Q. So reason triangle ABC and PQ and triangle PQR are similar. Now angle M is equal to angle N. Both are equal to 90 degree. So two angles are equal in a triangle ABM and triangle PQN. Two angles are equal. Therefore, they are similar triangles. Therefore, triangle ABM is similar to triangle PQN. Therefore, their sides will be proportional. Now, I will write AB by PQ is equal to BM by QN is equal to AM by PN. This I will mark as 5. Now equation 4 I am writing as it is. Equation 4 is area ABC, area of triangle ABC divided by area of triangle PQR is equal to BC by QR into AM by PN. Now AM by PN is equal to AB by PQ. See, from equation 5, AM by PN is equal to AB by PQ. See, these two are equal. I mean, these two ratios are equal. Therefore, I'll put AM by PN is equal to AB by PQ. So this becomes BC by QR into AB by PQ. Now again from equation 1, check equation 1. AB by PQ is equal to BC by QR. So this is equal to BC by QR into AB by PQ is equal to BC by QR. Again, in place of AB by PQ, I will write BC by QR. Okay. From equation 1. Therefore, area of ABC by PQR is equal to BC into BC divided by QC into QR. This becomes BC by QR the whole square. So this one I got from equation 5. From equation 5, I substituted AM by PN is equal to AB by PQ, and here from equation 1 I substituted this one. So finally I got area of ABC by area of PQR is equal to BC by QR the whole square. Similarly it can be shown that area of, I'll write in the next page. Let's record this. So similarly it can be shown that area of ABC by area of PQR is equal to, first I got BC, right? BC by QR the whole square. This is also equal to AB by PQ the whole square, which is also equal to AC by PR the whole square. How can I show this? From equation 1, I can substitute BC in place of BC by QR. I can put AB by PQ, and also in place of BC by QR I can put AC by PR from equation 1. Therefore, the ratio of the areas are equal to the square of the ratios of the sides. That proves the theorem. Let us see what's there. You can read the textbook explanation. There's an example also. You can read it out. All the explanation are self-explanatory. Now exercise 2.4. Exercise 2.4, problem number 1. Let ABC is similar to triangle DF. Triangle ABC is similar to triangle DF and their areas be respectively 64 centimeter square and 121 centimeter square. So ABC is a triangle and there's another triangle DF. A, B, C, D, E, F, 64 centimeter. EF is equal to 15.4 centimeter. EF is equal to 15.4 centimeter. Find BC. What is BC? We need to find. So given that triangle ABC is similar to triangle DEF. Therefore, according to the theorem, previous theorem 2.6, since these two are similar, area of ABC divided by area of DEF, area of DEF will be equal to AB by DE, the whole square is equal to BC by EC, the whole square is equal to AC by DF, the whole square. Now, what is the area of ABC? Area of ABC is given in the data in the question itself. So that is 64 centimeter. So I'll put that 64, and the area of DF is 15.4 is equal to, now BC by EF. So this is BC by EF, the whole square. Now if I want to remove the power of 2, that one, if I want to remove, I should take square root on both the sides. Taking square root on both sides. So 64 by 15.4 square of this, sorry, this is 121. So 64 by 121 is equal to BC by EF is, my EF is 15.4, the whole square. So here also I should put that square root. Now in the right hand side, the square root will get cancelled with this power of 2. Okay, now in this in the right hand side only BC by 15.4 will remain. So in the left hand side, square root of 64 is 8, square root of 121 is 11. Now cross multiply. BC is equal to 8 into 15.4 divided by 8. Sorry, divided by 11. Now 11 ones are 11, 11 ones are 11, then 4s are 44. So 8 into 1.4 into 8, 4 8 are 32, 8 ones are 8, 9 10 11. So 11.2. So BC is equal to 11.2 centimeter. Question number 2. Diagonals of a trapezium ABCD with AB parallel to DC intersect each other at the point O. If AB is equal to 2 centimeter, find the ratio. If AB is equal to 2 CD, find the ratio of the areas of the triangles AOB and COD. So there is a trapezium. A, B, C, D and the diagonals intersect at point O. So AB is parallel to CD. So given data, ABCD is a trapezium and AB is parallel to CD, and AB is given equal to 2 times of CD. So we need to find the ratio of the areas of the triangle AOB. So find area of AOB by area of COB. So we need to find the ratio of the areas of these two triangles. So how do we proceed now? You can see that angle AOB is equal to angle DOC. These are vertically opposite angles, and angle D is here is equal to angle B, because these two are alternate angles. Since AB is parallel to CD, these two are alternate angles which are equal to one another, and also angle C will be equal to angle A. These are alternate angles. So in triangle AOB and DOC, triangle DOC, so AOB, angle AOB is equal to angle DOC, vertically opposite angle. Vertically opposite angle, and angle A is equal to angle C as shown in the figure, and angle B is equal to angle D. These two are alternate angles. Therefore, corresponding three angles of these two triangles are equal. Therefore, these two are similar. Therefore, triangle AOB is similar to triangle DOC. Therefore, their areas, the ratio of the areas, therefore area of AOB by area of COB. Therefore, if two triangles are similar, then the ratio of their squares will be equal to ratio of the square of the sides. Therefore, area of AOB by area of COB will be equal to AB by DC the whole square. Now given that AB is equal to 2 times of CD, so I will substitute that. So 2 times of CD the whole square by CD or DC. Okay, I'll take CD only. So this becomes 2 2s are 4 CD square by CD square. So these two will get cancelled. So it is 4 by 1. So ratio of the areas of the triangle AOB and COD is 4:1. Let us check the answer. So exercise 2.4 problem 2, it is 4:1. So our answer is correct. We'll go to next question. Question number 3. In figure 2.44, ABC and DBC are two triangles on the same base BC. If AD intersect BC at O, show that area of ABC by area of DBC is equal to AO by DO. Question number 3. So the figure is like this. A, B, C, there are two triangles, and D, B, C, and AD and BC intersect at O. So given data, what is the given data? Triangle ABC and triangle DBC has same base BC. I need to prove that. To prove area of ABC by area of DBC, area of triangle ABC by area of triangle DBC is equal to AO by DO. So first what I'll do is, from A I'll draw a perpendicular to BC, that is the altitude. I'll mark this as E. So AE is the altitude or height of the triangle ABC. So altitude means it makes an angle of 90 degree. So similarly here, for in triangle BDC, I'll draw an altitude or the height of triangle BDC. I'll call this as F. So altitude means it should make an angle of 90 degree. Now in triangle ABC, sorry, in triangle AEO and triangle DEO. See, in triangle AEO and DEO, these two are opposite angles. Okay. Angle AOE is equal to DOF. So these two are vertically opposite angles. And angle E is equal to angle F. So two angles are equal. Therefore according to AA criteria, these two triangles are similar. Therefore triangle AEO is similar to triangle DE sorry, this is triangle DFO, triangle DFO. So AE triangle AEO is similar to triangle DFO. Therefore these two are similar, therefore their sides will be proportional. That means AE by DF, AE by DF is equal to EO by FO will be is equal to AC by DO. Is it not? If two triangles are similar, then the corresponding ratios of the sides will be equal. Now I'll see the area of triangle ABC, area of triangle ABC by area of triangle DBC. See, area of triangle ABC, what is it? It is half base into height. So 1 by 2 base of triangle ABC is BC and height is AE, and area of triangle DBC is given by half base. Here also base is same, base is BC and height is FD. Okay, FD or DF. Now here half will get cancelled, BC will get cancelled. I will get this is equal to AE by DF, FD or DF. Now see the previous equalities. Now I am marking this as 1. Now from 1, instead of AE by DF I can write AO by DO. Therefore area of ABC by area of triangle DBC is equal to, so from 1 AE is equal to AE by DF is equal to AO by DO, AO by DO. That completes the proof. Question 4. If the areas of two similar triangles are equal, prove that they are congruent. So there are two triangles which are similar. So let us say it is ABC, and there is another triangle PQR. So PQR, they are similar. So given data is ABC, triangle ABC is similar to triangle PQR. So if they are similar, what it implies? AB by PQ is equal to BC by QR is equal to PR, AC by PR. So this I'll mark as 1. So we need to prove that. To prove that triangle ABC is congruent to triangle PQR. So what is the difference between congruency and similarity? Two triangles are congruent if the corresponding angles are equal and also the corresponding sides are equal. But if two triangles are similar, if their corresponding angles are equal and the corresponding sides are proportional. So in similar triangles, sides will be proportional. In congruent triangles, even sides will be equal, corresponding sides will be equal. So given data is that these two triangles are similar and also the area is equal. That means given data, area of ABC is also equal to area of PQR. So they are similar and the areas are equal. We should prove that these two triangles are congruent. So I've drawn the figure. Now what will I do is I'll make some construction. I'll draw one perpendicular from A to BC. I'll call it as D, and I'll draw a perpendicular here also. I'll call this M. So perpendicular means it makes an angle of 90 degree. So this is 90 degree. So this is also 90 degree. So draw proof. So draw AD perpendicular to BC and PM perpendicular to QR. Now in triangle ABD and triangle PQM, you can see that angle B is equal to angle Q, because triangle ABC is similar to triangle PQR. So if these two triangles are similar, corresponding angles also are equal. Therefore angle B is equal to angle Q. So angle B is equal to angle Q. Then angle ADB is equal to angle PMQ. Now two angles are equal in this triangle. Therefore these two triangles are similar. Therefore triangle ABD is similar to triangle PQM. Therefore their sides will be proportional. That means AB by BD is equal to AB by PQ. AB by PQ is equal to BD by QM is equal to AD by PM. So I'll mark this as 2. Now what is the area of a triangle ABC? Area of triangle ABC by area of triangle PQR. See, area of triangle ABC is given by half base into height. What is base? Base is BC. Height is AD. Now here area of PQR is half base here is QR into PM. PM is the height. So from the data it is given that area of ABC is equal to area of PQR. That means these two are equal. Therefore these two will get cancelled. So in the left hand side I'll get 1 by 1 is equal to the right hand side. This half also will get cancelled with this half, and this half will get cancelled. So BC by QR into AD by PM I will get. See, 1 by 1 is equal to, now BC by QR is also equal to AB by PQ from 1. AB by PQ. And AD by PM also is equal to AB by PQ. So from 1 and 2 I'll get this. BC by QR is equal to AB by PQ from 1, and AD by PM is equal to AB by PQ from 2. So 1 by 1 is equal to AB by AB square by PQ square, or this you can write this also equal to AB by PQ the whole square. Both are same. Now if I take square root on both the sides, 1 by 1 square root, taking square root on both sides. So square root of 1 by 1 is equal to square root of AB by PQ the whole square. Now this square root and this 2 will get cancelled. So now I will get square root of 1 by 1 is 1 by 1 only, is equal to AB by PQ. Now AB by PQ is equal to 1 by 1. So this also implies that BC by QR also is equal to 1 by 1 from equation 1. This also implies that AC by PR is equal to 1 by 1. So if we compare AB by PQ is equal to 1 by 1 with equation 1, even BC by QR also you will get 1 by 1, AC by PR also is equal to 1 by 1. So what is the meaning of this? So if AB by PQ is equal to 1 by 1, then it implies AB is equal to PQ. Also BC by QR is equal to 1 by 1, it implies BC is equal to QR. So AC by PR is equal to 1 by 1, it implies that AC is equal to PR. So all the corresponding three sides of the first triangle is equal to the corresponding sides of the second triangle. Therefore we already knew that three angles were equal. Now we proved that three sides also are equal. So therefore these two triangles must be congruent. Therefore triangle ABC is congruent to triangle PQR. So if three corresponding angles and three corresponding sides of one triangle is equal to corresponding angles and corresponding sides of another triangle, then those two triangles are equal, those two triangles are congruent, right? So it's proved. Question number 5. So D, E and F are respectively the midpoints of sides AB, BC and CA of triangle ABC. Find the ratio of the areas DF, triangle DF and triangle ABC. So there is a triangle ABC. D is the midpoint of AB and E is the midpoint of BC and F is the midpoint of AC. So midpoints are joined and they form a triangle. So D, E, F. DF are respectively the midpoints of the sides AB, BC. Find the ratio of the areas of DF. So given data, D is midpoint of AB. Similarly, E is midpoint of BC and F is midpoint of AC. So to find the ratio of area triangle DEF by area of ABC. So this ratio we should find out. See now what is DF? DF will be equal to half of BC and DE will be equal to half of AC and EF is equal to half of AB. So this also implies that df df by bc is equal to half. Now this also implies that d by ac is equal to half. Now this also implies that if I cross multiply ef by ab is equal to half. See, first of all, how I got this df is equal to 1 by 2 bc. How I got? According to midpoint theorem of triangle. Okay, if there is a triangle, and if this is the midpoint of this side, if this is the midpoint of this side, and if this is the midpoint of this side, and if you join like this, then this side will be half of this side. This is what the midpoint theorem says. Okay, similarly here I got df is equal to 1 by 2 bc, and I cross multiplied, I got df by bc is equal to 1, and similarly dc by ac is equal to 1 by 2, ef by ab is equal to 1 by 2. So reason for all this is midpoint theorem of triangle. Midpoint theorem of triangles. You may have studied this one in your previous classes. Okay. Now since all are equal to 1, I'll equate them. d by bc is equal to, sorry, df by bc is equal to d by ac is equal to ef by ac, ef by ab is equal to 1 by 2. Now see, and the numerator is full of the sides of the triangle DEF, the smaller triangle, and the denominator is all the sides of the bigger triangle ABC. So this is nothing but the ratio of the sides. The ratio of the sides of the triangle DEF and the ratio of the sides of ratio of the sides of triangle DEF and ABC. So, and they are constant. Therefore, I can conclude that these two triangles are similar. Therefore, triangle DEF is similar to triangle ABC, because the ratio of the sides are equal, they are constant. If in two triangles the ratio of the sides are constant, then they are similar according to SAS, side criteria of similarity of triangles. These two triangles are similar. Now if two triangles are similar, then the ratio of their areas is given by area of DEF by area of ABC. If two triangles are similar, then their ratio of the areas will be equal to square of the ratios of the sides. That means it will be equal to DF by BC the whole square is equal to D by AC the whole square is equal to EF by AB the whole square. This we studied in theorem 2.6. So now I'll take any one. I'll consider any one. Now DF by BC is equal to 2 times of DF. BC is equal to 2 times of DF, or DF is equal to half of BC. Okay, DF the whole square by 2 DF the whole square. Now I'll get, in the numerator I'll get DF square, and in the denominator 2 into 2 is 4 DF square. Now df square will get cancelled. Therefore, area of DEF by area of triangle ABC is equal to 1 by 4. That means the areas are in the ratio 1:4. Let us check the answer. Question number 5. So it says 2.4. Question number 5. So answer is 1:4. So I got the right answer. Problem number 6. Prove that the ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding medians. So there are two triangles ABC, and let AD be the median, and there is another triangle PQR, and let PM be the median. So since AD is the median, BD is equal to DC. Here QM is equal to MR. So given that triangle data is ABC is triangle ABC is similar to triangle PQR. So to prove that area of triangle ABC by area of triangle PQR is equal to square of the ratio of this median. So AD by PM the whole square. We should prove this one. So prove that the ratio of the areas of the two similar triangles is equal to the square of the ratio of their corresponding medians. AD and PM is the median. So ratio of the areas will be square of the ratio of the median. That one we need to prove. So proof. See, in triangle ABC is similar to triangle PQR. Therefore, according to theorem 2.6, area of ABC by area of PQR is given by AB by PQ the whole square is equal to BC by QR the whole square is equal to AC by PR the whole square. I'll mark this as 1. And since these two are similar, we also the corresponding sides are also proportional. That means AB by PQ is equal to BC by QR is equal to AC by PR. Okay, and also we know that since these two are similar, angle B will be equal to angle Q. Okay. Now consider these two, AB by PQ by BC by QR. So AB by PQ is equal to BC by QR. Now in the right hand side I will divide by 2, both in the numerator and denominator. So AB by PQ is equal to BC by 2 by QR by 2L2. So effectively there is no change. So AB by PQ is equal to BC by 2 is BD. Half of BC is BD and half of QR is QM. Now if you see this one is the ratio of the sides of the triangle ABD and PQM. Okay, numerator it's the sides of the triangle ABD, and in the denominator it's the side of the triangle PQR. So therefore I'll mark this as 2. The above is the ratio of sides of triangle ABD and triangle PQM, and we know that angle B is equal to angle Q. Therefore these two triangles are similar. ABD, triangle ABD is similar to triangle PQM according to side angle side SAS criteria of similarity. Therefore their sides will be proportional, right? I am writing here. No, we'll consider the area instead of side. Therefore, since these two are similar, then now area of ABD divided by area of PQM will be equal to square of the ratio of the sides, which is equal to AB by PQ the whole square. AB by PQ the whole square, which is also equal to BD by QM, BD by the QM the whole square. Now this I'll mark as 2. I'll write once again. This is equal to AB by PQ the whole square is equal to BD by QM the whole square. This is also equal to AD by PM the whole square. Now if you compare 1 and 2, comparing 1 and 2, area of ABC divided by area of triangle PQR will be equal to AD by PM the whole square. That is, the ratio of the area of triangle ABC by triangle PQR is equal to the square of the ratio of the median. AD is median of first triangle, PM is the median of the second triangle. Therefore the ratio of the areas is equal to the square of the ratio of the medians, and it is proved. Question number 7. So it says, prove the area of an equilateral triangle described on one side of a square is equal to half of the area of the equilateral triangle described on one of its diagonals. So if you take a square means it will be of equal side, right? So let this square be A, B, C and D. So let on AB there be a triangle such that AB is the base. I am drawing a triangle. So this is a equilateral. So this, since ABCD is a square, let us assume all the sides are equal, right? So let us assume all the sides is of 1 unit. So now ABC is a equilateral triangle, and having AB as the base. Sorry, I'll take this as AE. AEB is a equilateral triangle and having AB as the base. Now there is a diagonal here AC. So what is the length of the diagonal? Okay, according to Pythagoras theorem, AC square is equal to AB square plus BC square. So that is equal to 1 square plus 1 square is equal to 1 plus 1 is 2. So AC square is equal to 2. AC will be equal to root 2. So AC will be equal to root 2 units of length, root 2 units. Now if I draw a triangle making AC as the base, it will be like this. So let this be F. So ACF is a triangle. Okay, ACF is an equilateral triangle and AC is the base of that. So according to the question, they are asking that. Okay, let me write the data first. Data is ABCD is a square, AEB triangle, AEB is a triangle and AB is base. Okay, then AEB is an equilateral triangle, actually equilateral triangle, and AB is the base. Again now ACF is a equilateral triangle and AC is the base. Now in the question they are asking to prove that the area of an equilateral triangle described on one of its sides of a square is equal to half the area of the equilateral triangle described on one of its diagonal. So they are asking to prove that area of AEB is equal to half the area of ACF. So we should prove this. Now since both triangle AEB and triangle ACF are equilateral triangle, they are similar. So any two equilateral triangle are similar. Okay, so triangle AEB is similar to triangle ACF. So if two triangles are similar, then their corresponding, according to theorem number 4, if two triangles are equal, then the ratio of the area, so that means ratio of area of AEB, area of triangle AEB by area of triangle ACF. So according to theorem 2.6, if there are two similar triangles, then the ratio of the areas will be equal to square of the ratio of the square of the sides. That means area of AEB by area of ACF is equal to, I can take any one corresponding side, will be equal to AB by AC the whole square. AB is the base of triangle AEB, AC is the base of triangle ACF. Now what is AB? AB is equal to 1 unit. And what is AC? AB is root 2 unit. So this turns out to be 1. 1 into 1 is 1. Root 2 into root 2. Base is root 2 into root 2. Root 2 into root 2 is 2 itself. So or For simplify further, I can take root 2, and this is 2 into 2, so 1 by root 4. Root of 4 is 1 by 2. So area of AEB by area of ACF is equal to 1 by 2, or area of AEB is equal to half the area of ACF. This proves the problem. Next question. Tick the correct answer and simplify. Problem number 8. ABC and BD are two equilateral triangles such that D is the midpoint of BC. Ratio of triangle ABC and BDE. BD is, we should find. So here there is some mistake in the question itself. So ABC is a equilateral triangle and D is the midpoint of BC. Now what is DB? There can't be. So they have not specified the point E. Where does E lies? So I think E is the midpoint of AC. D, E, F, and F is the midpoint of AB. I'll join these two. So question, it's not clear. It's similar to question number 5. So question number 5 already I have drawn the diagram and I have proved something there. So this question is same as question number 5, but in the sentence there is some mistake. Now find the ratio. So let me write the given data. ABC is a equilateral triangle. D is midpoint of BC. Similarly, E is midpoint of AC. F is midpoint of AB. So we should prove that we should find what is the ratio of, find the ratio of areas of the triangle ABC by area of the triangle DEF. So I'll make correction of this question this way. There's a triangle ABC and DEF are the midpoints of BC, AC and AB. We should find the ratio of triangle ABC by triangle DEF. So this is what. So proof. So since D E and F are midpoints of BC, AC and AB respectively, my EF will be equal to half of BC and DF will be equal to half of AC and DE will be equal to half of AB. So this implies if we cross multiply EF by BC will be equal to 1 by 2. Again here if I cross multiply df by AC is equal to 1 by 2. Again this one, d by AB is equal to 1 by 2. See, first of all, EF is equal to half of BC. How I got this? So according the reason for this, the midpoint theorem. According to midpoint theorem of triangles, we have got this one. EF is equal to 1 by 2 BC, DF is equal to 1 by 2 AC, D is equal to 1 by 2 AC. So this midpoint theorem you may have studied in your previous class. I won't go into details about that. I won't go into the proof, but I'll explain you. See, suppose there is an equilateral triangle, and these are the midpoints of the equilateral triangle. So now this side will be, suppose this is PQ and this is LM. So according to midpoint theorem, PQ will be equal to half of LM. So I won't go into proof of this theorem and all. You may have learnt in your previous classes. So now, see, now EF by BC is equal to 1 by 2, which is also equal to DF by AC, which is also equal to D by AB, which is equal to 1 by 2. So now if you observe this one, the numerator are the sides of the triangle DEF, and the denominator are the sides of the triangle ABE. These are simply ratio of the sides of triangle DEF and ABC, and that ratio is equal to 1 by 2. It's a constant. Therefore, if the ratios are if the ratios of the sides are constant, then those two triangles are similar. Or in other words, the ratio of the sides are proportional, we say. So since the sides are proportional, they are similar. Therefore, triangle ABC is similar to triangle DEF according to side criteria of similarity of triangles. This is nothing but theorem, I think it's 2.4. Okay, it's theorem 2.4, I think. Check it out. So now these two triangles are similar. Therefore, according to theorem 2.6, therefore their areas, the ratio of their areas will be equal to ratio of the square of their sides. Therefore, area of ABC by area of triangle DF will be equal to ratio of the square of the sides. I can take any one side. So now ABC is I'll take this side BC. In the denominator I'll take FE. The whole square. Now what is BC? BC is 2 times of FE, right? So I'll put that BC is equal to 2 times of FE according to midpoint theorem. So FE, so 2FE the whole square by FE. So this becomes 4FE square by FE square. So FE square will get cancelled. So now I'll get area of ABC by area of DEF is equal to 4 by 1. This is 4 by 1. So that means the bigger triangle of ABC is 4 times the area of DF. So let's check the answer. So exercise 2.4, exercise 2.4, problem number 8, answer is C. So we have got the right answer, that is 4:1. Question number 9, sides of two similar triangles are in the ratio 4:9. Areas of the triangles are in the ratio, we should find. So if two triangles are similar, okay, if two triangles are similar, then according to theorem number 6, area of triangle 1 by area of triangle 2 is equal to square of the ratio of the sides, right? So let that be S1 here, let it be A1. I'll take A1. Okay, S1 and A1 are corresponding side, I'll take. So like this. Now already they have given that the ratios are two sides of similar triangle are in the ratio of 4:9. So it's right hand side, it is 4:9, 4:9 the whole square. Now how much I'll get? 4 4s are 16, here 9 9s are 81. So area of the triangle by area of triangle 1 area by area of triangle 2 is equal to 16 by 81. They are in the ratio 16:81. Area of triangle 1 by area of triangle 2, they are in the ratio 16 by 81. So answer is D. So let us check the answer. So question number 2.4, 9D. So our answer is right. The next topic in this chapter is Pythagoras theorem. Before studying Pythagoras theorem, there is one more theorem, theorem 2.7. So first in the textbook they have given the proof of the theorem and then the statement. So what it says, if a perpendicular is drawn from the vertex of a right angle triangle to the hypotenuse, then the triangle on both sides of the perpendicular are similar to the whole triangle and to each other. So I'll draw the diagram. So A, B, C is a right angle. Sorry, this is A, this is B, and C. This is a right angle triangle, and the right angle is at angle B. So from the vertex of right angle, that is from point B, I'll draw a perpendicular to hypotenuse. Here AC is the hypotenuse. So AD is the perpendicular. Now there are three triangles here. On both sides of the perpendicular there are one triangle. Okay. On the left of the perpendicular there is triangle ADB. On the right of the perpendicular there is a triangle BDC, and there is another triangle which is our original triangle, that is triangle ABC. Therefore, okay, I'll write the data first. Data ABC is a right angled triangle, right angle at B. angle B is equal to 90 degree. So BD is perpendicular to AC. Now there are three triangles. So on the left of the perpendicular there is triangle ADB. Sorry, ADB, and on the right of the perpendicular there is triangle BDC, and there is another triangle, that is the original triangle, triangle ABC. Now according to this theorem, all the three triangles are similar. So I'll read out the statement once again. If a perpendicular is drawn from the vertex of the right angle of a right angle triangle to the hypotenuse, then the triangles on both sides of the perpendicular are similar to the whole triangle and to each other. Proof. I'll consider triangle ADB and B and ABC, and triangle ABC. See, in the I'll write these two triangles separately. This is ADB and ABC. See, in these two triangles, angle A is common. Angle A is common to both the triangles. Okay, and angle D is equal to angle B, which is equal to 90 degree. So I'll write angle A is common to both the triangles, and angle ADB of the first triangle is is equal to angle ABC of the second triangle, which is equal to 90 degree. Therefore two angles are equal. So if two angles of one triangle is equal to the corresponding two angles of another triangle, then those two triangles are similar to one another. Therefore these two triangles should be similar. Therefore triangle ADB is similar to triangle ABC according to AA similarity rule. This AA rule, similarity rule, you studied in this chapter only, in theorem 2.3. Okay, I'll write that also. Theorem 2.3. You can study again. Now I'll mark this as 1. Now I'll consider triangle BDC, and triangle ABC. So triangle BDC is like this. I'm redrawing so that you can understand easily. Triangle BDC is like this, BDC, and the original triangle is ABC. See, in these two triangles, angle C is common. Angle C is common in both the triangles, and angle D is equal to angle B, which is equal to 90 degree. That is angle BDC. Angle BDC is equal to angle ABC, and angle C is common. So therefore these two triangles are similar to one another according to AA similarity rule. Therefore triangle BDC is similar to triangle ABC according to AA similarity rule. That is theorem 2.3. Okay, this I'll mark as 2. See, from 1 and 2, see, from 1 says that triangle ADB is similar to triangle ABC. but 2 says triangle ABC is similar to triangle BDC. Triangle BDC. Therefore, all the 3 triangles are similar to one another, and that completes the proof. The next topic in this chapter is Theorem 2.8. Theorem 2.8 is nothing but the Pythagoras theorem. You have learned this theorem in your previous classes. So the same theorem we are going to prove using the properties of similarities of triangles. So the statement says, in a right angle triangle, the square of the hypotenuse is equal to the sum of the square of the other 2 sides. So the figure is like this. This is triangle ABC, right angle at angle B. So data is ABC is a right angled triangle, right angled at angle B. So angle B is equal to 90 degree. So according to this theorem, this square of the hypotenuse, so AC is the hypotenuse, so AC, the square of the hypotenuse, is equal to sum of the square of the other 2 sides. See, the other 2 sides are AB, so AB and BC. So AC square is equal to AB square plus BC square. So we'll prove this theorem using the properties of similarities of triangles. Proof. So first I'll draw BD perpendicular to AC. Now according to the previous theorem 2.7, when a perpendicular is drawn, if in a right angle triangle, if a perpendicular is drawn from the vertex of the right angle to the hypotenuse, then what happens? AD. So now if BD is drawn perpendicular to AC, then according to theorem 2.7, ADB, triangle ADB will be similar to triangle BDC is similar to triangle ABC. See, these 3 triangles will be similar to one another according to the theorem 2.7, which we studied in the previous section. Theorem 2.7. Now I'll consider the triangles ABD and ABC. In triangle ABD and triangle ABC, these 2 triangles I am considering. See, in these 2 triangles I'll redraw the diagram once again so that it is easy to understand. ADD is one triangle and ABC is another triangle. Since these 2 triangles are already similar, their corresponding sides will be proportional, right? So what are the corresponding sides here which are proportional? Now first I'll match hypotenuse with the hypotenuse. See, AB is the hypotenuse in this triangle, and in AC this is the hypotenuse. Therefore AB by AC will be equal to, and I'll match the other side also. Now A is common, and here the angle D is 90, angle B is 90. Therefore AD will be proportional to AB. I'll mark this as 2. So AD is proportional to AB. Now if I cross multiply, I'll get AB square is equal to AC into AD. I'll mark this as 1. Similarly, now I'll consider triangle BDC and triangle ABC. See, triangle BDC is like this, BDC, and ABC is like this, ABC. Now C is common, angle C is common, and D is 90, here B is 90. So since these two triangles are already similar, their corresponding sides should be proportional. Now I'll match hypotenuse with the hypotenuse. So here in the first triangle, hypotenuse is 3. I'm marking as 3, and in the second triangle, hypotenuse AAC 3. And what is the side between C and D? So this is 4, and this side corresponds to BC. This is 4. Therefore hypotenuse by hypotenuse, so BC by AC will be equal to CD by BC. Now if I cross multiply, I will get BC into BC is equal to AC into CD, or BC square is equal to AC into CD. I'll mark this as 2. Now I'll add 1 and 2. 1 plus 2 gives me, add the left hand side and the right hand side. Okay, in the left hand side AB square is there, AB square plus BC square, and in the right hand side AC into AD, AC into AD plus AC into CD. Now here AC is common, AC, and in the bracket AD plus CD I'll get, AD plus CD. Now look at the main diagram. AD plus CD is equal to AC. So AC into AC, AC into AC I'll get, this is equal to AC square. AC square is nothing but square of the hypotenuse. And in the left hand side, what is there? Sum of the square of the sides. Therefore in a right angle triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. There are some more information given regarding this theorem. The above theorem was earlier given by an ancient Indian mathematician, Baudhyayan, in the following form. The diagonal of a rectangle produces by itself the same area as produced by its both sides. For this reason, this theorem is sometimes referred to as Baudhyayan theorem. So Baudhyayan theorem and Pythagoras theorem are same only. See, in Pythagoras theorem what we proved, the square of the hypotenuse is equal to the sum of the square of the other two sides, A, B, C. So we proved that AC square is equal to AB square plus BC square. Now what is AC square actually? See, before that I'll make some changes here. I'll draw AE parallel to BC and CE parallel to AB. Okay. Now what is ABCE? ABCE is nothing but a rectangle. Angle B is 90 degree. Okay. All angle are 90 degree here. So now ABCE is a rectangle. Now what is this AB square actually? See here, this AB square. What is this? AC square. So AC square is actually the area of the square, making AC as one of the side. See, this is AC square. AC square is nothing but this area. Similarly, what is this AB square? This AB square is nothing but the area of the square, making AB as the base or one of the side. Okay, if I make AB as one of the side, and if I draw a square, then this is AB square. So AB square is this area. Similarly, what is BC square? BC square is nothing but area of the square, making BC, having BC as one of the base. This is the area. BC square is this area. So what did Bodyan say? The diagonal of a rectangle produces by itself the same area as produced by both sides. That is, AC square is equal to BC square, AB square plus BC square. So both Bodyan theorem and Pythagoras theorem are one and the same only. The next topic in this chapter is Theorem 2.9. So Theorem 2.9, it's the converse of Theorem 2.8. So in Theorem number 2.8, what we studied, that theorem was regarding a right angle triangle. So ABC. So if given in a right, sorry, I'll take this as A, this as B. If there is a right angle triangle, then square of the hypotenuse will be equal to sum of the square of the other two sides, AB square plus BC square. AC square is equal to AB square plus BC square. This is what we learnt in theorem number 2.8. So in theorem number 2.9, will study the opposite of the above theorem, that is converse of the theorem 2.8. Converse of theorem 2.8. So here what it says is, in a triangle, if square of one side is equal to the sum of the square of the other two sides, then the opposite side, then the angle opposite the first side is a right angle triangle. So here it says ABC. So according to this theorem, if AC square is equal to AB square plus BC square, then angle B is equal to 90 degree. This is what this theorem claims. Let me read out once again. In a triangle, if square of one side is equal to the sum of the square of the other two sides, then the angle opposite to the first side is a right angle triangle. So given data, so ABC is a triangle. ABC is a triangle in which AC square is equal to AB square plus BC square. So we need to prove that angle B is equal to 90 degree. So to prove this one, I'll construct another triangle PQR. I'll construct a right angle triangle such that PQR such that PQ is equal to CB. I'll make PQ is equal to CB and QR equal to A. So in this way I'll construct. So and it's right angled at angle Q. So construct a right angled triangle right angled at q, at angle q, construct a right angled triangle PQR. Okay, PQR right angled at q, and PQ is equal to BC and QR is equal to AB. Now according to theorem number 2.8 in triangle PQR, therefore in triangle PQR, in triangle PQR, PR square is equal to PQ square plus QR square, because this is a right angled triangle. So in a right angled triangle, the square on the hypotenuse is equal to the sum of the square of the other two sides, PQ square plus QR square. Now PQ is equal to QR. PQ is equal to BC and QR is equal to AB. I'll substitute that PR square is equal to, since PQ is equal to BC and QR is equal to AB. I'll mark this as 2 and let the given data here let this be 1. See now, left hand side of 1 and left hand side of 2, right hand side of 1 and right hand side of 2 are equal. Therefore I can equate the left hand side. Okay, from 1 and 2, right hand side is equal, therefore left hand side should be equal. Therefore AC square is equal to PR square. So on the both side, power of 2 is there, which can be removed. AC is equal to PR. Now in triangle ABC and triangle PQR, AB is equal to QR. So this one, how means I made construction. Okay, AB is equal to QR and CB is equal to PQ and AC is equal to PR. So these two triangles are congruent. So the three sides of triangle ABC are equal to the corresponding three sides of the triangle PQR. Therefore these two triangles are congruent. Triangle ABC is congruent to triangle PQR. Therefore angles will be equal, corresponding angles should be equal. Therefore angle Q should be equal to angle B, but angle Q is equal to 90 degree. Therefore angle B also should be equal to 90 degree. So this establishes the proof. These two triangles are congruent by side congruency rule. You can go through the textbook explanation, or if you are comfortable with my explanation, you can go for that. Now here there are many worked examples in the textbook. You should read and understand. All the explanation are easy only. It's all self-explanatory. Read by yourself. 12, 13, example 14. I'll be concentrating on worked examples only. Now exercise 2.5. Exercise 2.5. First question. The sides of a triangle are given below. Determine which of them are right angle triangles. In case of right angle triangle, write the length of the hypotenuse. So first sub question, the given sides are 7 centimeter, 24 centimeter and 25 centimeter. So first I'll go for the highest length. I'll check the highest length. Here the highest length is 25. I'll check what is the square of that. Now 25 square is equal to, check it out, 25 into 25, 5 5 are 25, 5 2s are 10, 11 12, 2 2s are 4, 2 1s are 2, so 5 4 5 6 4 5 6, sorry, this is 2 5s are 10, don't carry, 2 2s are 4 plus 1 5, so 5, this is 2, 5 plus 1 625, so 25 square is 625. What is 7 square plus 24 square, check it out, 7 7 are 49 plus 25 square, 24 square, 24 into 24, 4 4s are 16, 4 2s are 8 9, so 2 4s are 8, 2 2s are 4, 5 6, 2 4s are 8, 2 2s are 4, okay, 48, sorry, it's 48, 6 8 8 16 plus 1 17, 4 576 plus 576, so 576 plus 49 is 5, then 12 carry 1 6, so this is 625. So 25 square is equal to 7 square plus 24 square. Therefore the given sides are sides of a right angle triangle according to theorem 2.9. Therefore I'll write the given sides are the sides of a right angled triangle. So next sub questions, question 2, 3 centimeter, 8 centimeter, 6 centimeter. So highest side is 8 centimeter. I'll check 8 square. 8 square is equal to 8 8 are 64. So next I'll check 3 square plus 6 square, 3 3 are 9 plus 6 6 are 36. So this turns out to be 45. Now clearly 8 square is not equal to 3 square plus 6 square. Therefore this is not a right angle triangle. The given sides are not the sides of a right angle triangle. The given sides are not the sides of a right angle triangle. Angled triangle. Now third question. So and also in the question they have asked the length of the hypotenuse. In the first question length of the hypotenuse will be 25, and in the second question it's not at all a right angle triangle. So third sub question, 50 centimeter, then 80 centimeter, then 100 centimeter. So first I will go for the highest side. Highest side is 100 centimeter. So 100 square is equal to, so 100. So now 100 square is 1 followed by 4 zeros. I'll get 1 2 3 4. Now I'll check 50 square plus 80 square. 50 square plus 80 square, 5 5 are 25. 25 followed by 2 zeros. plus 8 8s are 64, 64 followed by 2 zeros. How much is this? So 0 0 5 9 then 6 plus 6 7 8 8 9 00. So clearly 100 square not equal to 50 square plus 80 square. So what's my conclusion? It's not a right angle triangle. So answer is no. So last question. Question number 4. So 13 12 centimeter then 5 centimeter. So I'll check the highest side. Highest side is 13. So I'll check first. I'll check whether what is 13 square. 13 square is equal to, so 13 into 13, 3 3s are 9, 3 1s are 3. So 1 3 are 3, 1 1s are 1. So 169. So I'll get 169. So what is 12 square plus 5 square now? So 12. What is 12 square? 12 into 12. 2 2s are 4. 2 1s are 2. So 1 2s are 2. 1 1s are 1. 4. 144. So 144 plus 5 5s are 25. So addition of these two is 9 4 6 1. So clearly 13 square is equal to 12 square plus 5 square. Therefore the given sides are the sides of a right angle triangle and the hypotenuse is 13 centimeter. So the given sides are the sides of a right angle triangle and hypotenuse is 13 centimeter. Hypotenuse is the highest lengthiest side. Okay, that completes problem number 1. Exercise 2.5, question number 2. So PQR is a triangle, right angled at P, and M is a point on QR such that PM is perpendicular to QR. Show that PM square is equal to QM into MR. So PQR is a right angled triangle and right angled at P, and M is a point on QR. So M is a point on QR such that PM is perpendicular to QR. PM is perpendicular to QR. Show that PM square is equal to, okay, data is PQR is a right angled triangle, right angled at P. So therefore angle P is equal to 90 degree. So and PM is perpendicular to QR. These two are the data given, and we need to prove that PM square is equal to QM into MR. So to prove that, see, according to theorem 2.7, there are 3 similar triangles here. Okay, first I'll write 2 triangles separately here. You can observe. I'll write RMP and PMQ. See, in triangle RMP, M is a right angle triangle, and in PQM, again here M is the right angle triangle. See now, so according to theorem 2.7, triangle RMP is similar to triangle PMQ. This is also similar to triangle RPQ. This is according to Theorem 2.7. So now we will consider only these two triangles. These two triangles diagram I have rewritten again here. Now these two triangles are similar. So what is the corresponding sides here? Angle M, sometimes identifying corresponding sides will be confusing. So first you take hypotenuse by hypotenuse. So then, since these two triangles are similar, their sides will be proportional. Okay. So RP, hypotenuse of this triangle RPM. Then hypotenuse of triangle PQM is PQ. These two will be equal to, I'll mark this and this. These are corresponding sides. This is RP. Next corresponding side will be this and this side. So RM by PM. Next corresponding side is this side. I am marking as 3. So PM by QM. Now I'll consider only these two. So now I'll take these two and I'll cross multiply. So these two are RM by PM is equal to PM by QM. So when I cross multiply, I'll get PM into PM is equal to RM into QM. Therefore PM square is equal to RM into QM. This is the answer. Question number 3. In figure 2.53, ABCD is a triangle, right angled at A and AC is perpendicular to BD. So this is a right angled triangle ABD and AC is perpendicular to this is A, this is B, this is A, and AC is perpendicular to BD. Okay, given data ABD is a right angled triangle and right angle at A. So angle A is equal to 90 degree and side AC is perpendicular to BD. So I should prove these two. To prove AB square is equal to BC into BD. First one, and prove AC square is equal to BC into DC. And third one, AD square is equal to BD into CD. See, now since angle A is 90 degree and AC is perpendicular to BD, then these three triangles will be similar. Which are those three triangles? Triangles BAC is similar to triangle CAD is similar to triangle ABD according to theorem 2.7. These three triangles are similar. So now I'll consider first in triangle. I'll consider triangle BAC and triangle CAD. Now in these two triangles, I'll draw these two triangles once again. So BAC is like this. This is CAB, BAC, and CAD. Triangle CAD is like this. I'm just redrawing so that you can understand properly. This is C and this is D, A, D. Now what are the corresponding sides in these two triangles? See, these two are corresponding side, AB and AD, and BC is corresponding to AC, and AC is corresponding to CD. Therefore AB by AD is equal to BC by AC is equal to AC by CD. Now I will consider if I consider these two and cross multiply, I will get AC square. AC square is equal to BC into CD. So my second this is the second sub question is proved. Now I will consider triangle BAC and BAD. Triangle BAD. I will redraw so that you can understand nicely. So BAC is like this. This is C, here comes here, this is B, and BAD. BAD is the biggest triangle there. BAD. So here angle A is right angle. So now finding corresponding side. First you match the hypotenuse. Once if you match the hypotenuse, you will get all the other sides automatically. Now since these two triangles are similar, now okay, what about the remaining corresponding sides? BA is corresponding to BA, and AB is corresponding to AD. Therefore AB by BD. The first one is hypotenuse by hypotenuse I have written. Next corresponding side is BA by BA. So BA by BA. This is equal to, then this is C, sorry, this is C. So first one is BC by BD is equal to BA by BA is equal to CA by AD. I'm sorry again. The first triangle, this is C, this is C, and this is A. So and if you take the corresponding sides now, AB by BD, AB by BD is equal to BC by BA is equal to AD by is equal to AB by AD. Now if I cross multiply, which one? If I cross multiply these two, I will get AB square is equal to BC into BD. This is my first sub question which I proved. And coming to the third one. Now consider triangle CAD, triangle CAD, triangle CAD and BAC, triangle BAD. Now triangle CAD is like this. C is here, A is here, D is here. So CAD and triangle BAD. This is the biggest triangle, BAD. Now these two triangles are similar, therefore ratio of their sides will be proportional. First I will match hypotenuse with the hypotenuse, then the sides with sides. So now AD by BD is equal to AC by BA is equal to CD by AD. Now I'll cross multiply first and the last one. Okay, if I cross multiply, I will get AD square is equal to BD into CD. This is the last sub question. Question number 4. ABC is an isosceles triangle, right angled at C. Prove that AB is equal to 2AC square. So ABC is a right angled triangle, right angled at C. So ABC, right angled at C. So in an isosceles triangle, two sides are equal. Now hypotenuse is the greatest side, therefore AC will be equal to BC. C is right angled. So given data, ABC is a right angled triangle and angle C is equal to 90 degree. So first you need to write the data, and we need to prove that AB square is equal to AC square, sorry, 2AC square. Now since this is a right angled triangle, the square of the hypotenuse, according to Pythagoras theorem, the square of the hypotenuse, that is AB square, is equal to sum of the square of the other two sides. The square of the hypotenuse is equal to sum of the square of the other two sides. AB square is equal to BC square plus AC square. So this is according to Pythagoras theorem or theorem 2.8. Now AB square is equal to, since AC and BC are equal, this again I will write as AC only. So instead of BC I will write AC square plus AC square as it is. So AC square plus AC square is equal to 2AC square. So this is a pretty simple question. Next question is question number 5. ABC is an isosceles triangle with AC is equal to BC. If AB square is equal to 2AC square, prove that ABC is a right angled triangle. So this is somewhat similar to the previous question. So ABC is a right angle triangle, right angle at so okay, it's not given, so it's not shown that it's right angle. ABC is an isosceles triangle with AC is equal to BC. So AC is equal to BC, so this I'll strike it out. AC is equal to BC. So I'll write the data. ABC is a right angled triangle. So in examination always you need to write the data and then proceed to prove what they have told to. For writing data also you will get marks. ABC is an isosceles triangle. So and given AC is equal to BC, and also given that AB square is equal to 2AC square. Prove that ABC is a right angled triangle. So I should prove. So sorry, in data it's not given it's a right angled triangle. They have given that AC is equal to BC and AB square is equal to 2AC square. I need to prove that ABC is a right angled triangle. So proof, given data is given AB square is equal to 2AC square. So AB square, I can write 2AC square as AC square plus AC square. So AC square plus AC square is 2AC square. Now again I'll write AB square is equal to, also given that AC is equal to BC. So in place of first AC I'll write BC, because AC is also equal to BC. So I'll write BC square here, plus in the second term I'll retain as it is AC square. Now if you closely monitor this equation, the first one is the hypotenuse, and the second two, these two are sides, other sides, okay, other sides of triangle ABC. Now since the square of the hypotenuse is equal to sum of the square of the other two sides, ABC should be a right angle triangle. So you need to mention this, okay, in sentence. Since the square of the hypotenuse is equal to sum of square of the other two sides, the given sides are sides of a right angled triangle. According to theorem number 2.8, that is Pythagoras theorem. Exercise 2.5, question number 6. ABC is an equilateral triangle of side 2A. Find each of its altitudes. So ABC is an equilateral triangle of side 2A centimeter. So AB is 2A, BC is 2A, and AC is also 2A centimeter. Now what are the altitudes? See, from vertex A I will draw altitude. If BC is the base, then AD is the altitude. Altitude always makes an angle of 90 degree. So not only this, there is another altitude. If I consider AC as the base, then BE will be the altitude. So BE makes an angle of 90 degree to the base AC. And also similarly, now if I consider AC as the base, there is CF, the altitude. Okay, this also makes an angle of 90 degree. Now in an equilateral triangle, always altitude divides the base into two equal parts. Therefore, if BC is 2A, BD will be A units and DC will be A units. So what I have given here 2A. Each side is 2A, therefore BD is A and DC is equal to A. Similarly, EC will be A and AE will be A. And similarly, AF will be A and BF will be A. Now consider right angle triangle. Okay, ABD. So here angle D is equal to 90 degree. So since this is a right angle triangle, applying Pythagoras theorem here, square of the hypotenuse is equal to the sum of the square of the other two sides. So AB square is equal to BD square plus AD square. So AB square we know it is 2A the whole square is equal to BD is A square plus AD we don't know. So AD is nothing but the altitude, considering BC as the base. Now 2A square is 4A square is equal to A square plus AD square. Now I will bring this A square to the left hand side. 4A square minus A square is equal to AD square. So 4A square minus A square is 3A square. So A square means it is 1A square, it's understood. So here 4 minus 1, if I take A square as common, I will get 4 minus 1, this is equal to AD square. So 3A square is equal to AD square. So taking square root on both the sides, square root of 3A square is equal to square root of AD square. So here this square root symbol and this 2 will get cancelled. I will get AD is equal to square root of 3A square. Square root of 3A square I can write square root of 3 into square root of A square. So here again this square root symbol and this 2 will get cancelled. I will get root 3 into A is equal to AD, or AD is equal to root 3A. So this is the height. Height is equal to root 3 times the root 3 times half of the base. Now similarly in triangle BCE, angle E is equal to 90 degree. Therefore here also applying the Pythagoras theorem, I will get BC square is equal to EC square plus BE square. So BC square is 2A square. So 2A the whole square is equal to EC square. EC is A. So A square plus B. B is the altitude. Considering AC as the base. So here 4A square is equal to A square plus BE square. So simplifying again here also I will get B is equal to root 3 times of A. This is the second altitude. And what about the third altitude? So for third altitude we will consider triangle AFC. In triangle AFC, angle F is equal to 90 degree. So applying Pythagoras theorem again here AFC. Okay, so AC square is equal to square of the hypotenuse. AC is the hypotenuse. So AC square is equal to AF square plus CF square. So AC is 2A 2a the whole square is equal to a square plus CF we don't know, that's the altitude. So a 4a square is equal to a square plus CF square. So simplifying here also, as in the first case, I'll get CF. CF is equal to root 3 times a. So in any equilateral triangle, the altitude is equal to root 3 times half of the base. Question number 7. Prove that the sum of the squares of the sides of a rhombus is equal to the sum of the square of its diagonals. So draw the diagram of rhombus. So let this be A, B, C, D. So what is a rhombus? Rhombus is a quadrilateral in which diagonals bisect each other and opposite angles are equal. So since diagonals bisect each other, here AO will be equal to OC and DO will be equal to OB. Okay, so data, all right. Data ABCD is a rhombus. So I should prove that. To prove that the sum of the square of the sides of the rhombus, that is I should prove that AB square plus BC square plus CD square plus AD square is equal to sum of the squares of its diagonal. That means this is equal to AC square plus BD square. So proof. Now see here, there are 4 right angled triangles. Another property of rhombus is the diagonals bisect each other and make an angle of 90 degree like this. Here each angle is 90 degree. So there are 4 right angled triangle. So now in triangle ABO, AB is the diagonal, therefore AB square. So AB square is equal to AO square plus BO square, right? Now AO is half of AC, so I'll substitute that. So AC by 2 the whole square is equal to, and BO is half of BD, plus BD by 2 the whole square. So this is equal to AC square by 4 plus BD square by 4. Similarly, I will get BC square. What is BC square? BOC is a right angle triangle. Therefore, BC square is equal to BO square plus CO square, and BO square is equal to half of BD. So BD by 2 the whole square plus, and CO is half of AC. So AC by 2 the whole square. So I'll get BD square by 4 plus AC square by 4. Similarly, I'll get CD square is equal to AC square by 4 plus BD square by 4, and I'll get AD square also is equal to AC square by 4 plus BD square by 4. Now I'll mark this as equation 1, this as equation 2, this I'll mark equation 3, this I'll mark equation 4. Now adding 1 plus 2 plus 1, 2, 3 and 4. So 1 plus 2 plus 3 plus 4 gives, so add all the left hand side, equate, put the equal symbol and add all the right hand side. Now the left hand side I'll get AB square plus BC square plus CD square plus AD square. So in the right hand side I'll get AC square by 4 plus BD square by 4. Now again in the equation 2, again I'll get AC square by 4 plus BD square by 4. Again from equation 3 I'll get AC square by 4 plus BD square by 4, plus again in equation 4 I'll get AC square by 4 plus BD square by 4. Now in the left hand side, AB square plus BC square plus CD square plus AD square is equal to, see here there are 4 AC square by 4, that is AC square by 4 here, the AC square by 4 here, AC square by 4 here, AC square by 4 here. Therefore this is 4 into AC square by 4 plus, now BD square by 4, that one also I'll get 4 times, this and this. So 4 times into BD square by 4. Now here this 4 and this 4 will get cancelled. Therefore this is equal to, right hand side is equal to AC square plus BD square. Now the left hand side, if you see, it's the sum of the squares of the sides of the given rhombus, and right hand side is nothing but the sum of the squares of the diagonal, and this completes the proof. Next question is question number 8. In figure 2.54, O is a point in the interior of a triangle ABC. So I'll draw the figure. It looks like a complex figure. So A, B, C. O is a point in the interior of the triangle ABC, and OD is perpendicular to BC, and OE is perpendicular to AC, and OF. So given data, so always make a practice to write the given data and figure properly. This also fetches some marks in your examination. So ABC is a triangle, it's not okay, is a triangle. So this is O D E F. Given that OD perpendicular to BC, O is perpendicular to AC, and OF is perpendicular to AB. So we should show that OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equal to AF square plus BD square plus CE square. This is the first one I should show, and the second one is AF square plus BD square plus CE square is equal to AE square plus CD square plus BF square. So first thing I'll prove first one. So I'll write the equation as it is: OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equal to AF square plus BD square plus CE square. Now I should show that the left hand side is equal to the right hand side. If I can show it, the job is done. So the given equation is like this: OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equal to AF square plus BD square plus C square. Now see, I'll bring all these terms to the right hand side. I'll bring OD to the right hand side. I'll also bring OE to the right hand side. I'll bring OF also to the right hand side. I'll see what we'll get. OA square plus OB square plus OC square is equal to AF square plus BD square plus CE square. When I bring all these three terms to the right hand side, it becomes positive. Minus sign becomes plus sign. So plus OD square plus OE square plus OF square. Now before proceeding further, I'll make some construction. See, I'll join AO and I'll join BO and I'll join CO. Okay, now I'll come to this equation again. Now in this one, in the right hand side, I'll make some regrouping. AF square and OF square I'll write side by side. AF square plus OF square I have written. Then I'll take BD square. See this: BD square and OD square. BD square plus OD square. So BD square and OD square I am writing side by side, plus now CE square, the remaining is CE square plus OE square. Now you can see here AF square plus FO square. See, now AFO is a right angle triangle, therefore AF square plus OF square will be equal to AO square or OA square, whatever. Plus now if you see the third and fourth term, BD square plus OD square, BD square plus OD square is equal to BO square, because BDO is a right angle triangle. Now if you come to the last two terms, CE square plus OE square is equal to CO square. See, now you can observe that both left hand side and right hand side are equal only. OA square plus OB square plus OC square is equal to AO square plus BO square plus CO square. Both left hand side is equal to right hand side. So now this is done. Now the second one we should prove that AF square plus BD square plus CE square is equal to AE square plus CD square plus BF square. Now in this equation I'll add FO square plus DO square plus EO square on both sides of the above equation. So basically I need to prove left hand side is equal to right hand side. So now I'll add FO square plus DO square plus EO square on both the sides. So my left hand side will become AF square plus I am writing as it is AF square plus BD square plus CE square. Now I am adding this one, FO square plus DO square plus EO square. Now this is equal to, in the right hand side, what the original equation says, thing is there. So AE square plus CD square plus BF square. Now here also I am adding FO square plus DO square plus EO square. So FO square plus DO square plus EO square I am adding. So if I add same thing on the left hand side and the right hand side, there won't be any change in the equation. So now I can see here, I'll regroup, okay. EF square, or I'll write directly. You should closely observe. See, now EF square plus FO square, EF square plus FO square is equal to AO square in the left hand side. Now plus, now you can see BD square plus DO square. This BD square plus DO square. BD square plus DO square is BD plus DO square is BO square. Plus, now the remaining is CE square plus EO square. CE square plus EO square is CO square. Now in the right hand side also you can see now AE square plus EO square. AE square plus EO square is equal to CO square. AE square plus EO square is equal to AO square. Plus again, now you can see CD square. I am marking, you can observe CD square plus DO square. So I am marking star, you can observe CD square plus DO square is equal to CO square. Now the remaining left is BF square and FO square. BF square plus FO square is BO square. Now the left hand side is same as right hand side. Question number 9. A ladder 10 meter long reaches a window 8 meters above the ground. Find the distance of the foot of the ladder from the base of the wall. So there's a ladder which is 10 meter long and window is 8 meter above the ground. 8 meter. So ABC. AB is the ladder and window there somewhere here which is 8 meter above the ground. Okay. Now I should find this distance. What is the distance between the ladder, foot of the ladder and the wall is the question. So it's very simple. So here wall and ground always make an angle of 90 degree. Therefore this is a right angle triangle. So therefore according to Pythagoras theorem, AB square is equal to BC square plus AC square. Therefore, so what is AB? AB is 10 square. 10 square is equal to BC. BC is not known. That's what we need to find out. BC square plus what is AC? AC is 8 square. So this is 100 100 is equal to BC square plus 8 square is 8 8 are 64. 64 I'll bring to the left hand side. So 100 minus 64 is equal to BC square. So what is this? 100 minus 36 is, sorry, 64 is 36. 36 is equal to BC square, or BC is equal to root of 36. So BC is equal to 6. So the ladder is at a distance of 6 meter from the wall. Next question, question number 10. A guy wire attached to a vertical pole of height 18 meter is 27 meter long and has a stake attached to the other end. How far from the base of the pole should the stake be driven so that the wire will be torn? So this problem is same as the previous one. There's a vertical pole of height 18 meters. A guy wire is attached to a vertical pole of height 18 meters is and has a stake attached to the other end. So this is 24. A, B, C. This is 24. So here the height of the pole is 18 meter and wire is attached to the top end of the pole, and the other end of the wire is fixed to the ground. Now here the ground and vertical pole makes an angle of 90 degree, right? So they are asking what is the distance of the what is the distance between from the feet of the pole to the other end of the wire. So we need to find the distance of BC. Other end of the wire is attached to the ground itself. So here this is a right angle triangle, therefore AC square is equal to AB square plus BC square. So 24 square is equal to AB is 18 square plus BC square. BC square we need to find out, we don't know that one. So find what is 24 into 24. 24 into 24. 4 4s are 16. 4 2s are 8 9. 2 4s are 8. 2 2s are 4. 6 8 8 16 17, carry 1, 5 plus 1 6. And what is 18 square? 18 into 18. 8 8 are 64. 8 1s are 8. 9 10 14. 1 8 are 8, 1 1s are 1. 4 8 9 10 11 12. So 3 24. So 674 minus, so I'll is equal to 324 is equal to BC square. Now I'll bring this 324 here. 674 minus 324 is equal to BC square. So what's the addition? So here 4 4 8 7 8 9 6 7 8 9 998. Sorry, there is some correction here. It is 576. This is 576. So 576 576 576. So 576 minus 324 is equal to BC square. So difference between 576 and 324 is 2. 7 minus 2 is 5. 5 minus 2 is 3. So 252. 252 is equal to BC square. 252 is equal to BC square. Therefore BC is equal to 252 square root of 252. Now 252 I'll divide by 2. 2 1s are 2, 2 2s are 4, 2 6 are 12, 2 6 are 12, 2 3s are 6, 3 2s are 6, 3 1s are 3, 3 7s are 21. Therefore BC is equal to square root of 2 into 2 into 3 into 3 into 7. So I'll group these two, and bring outside. So if I bring outside, I can take only 1. So 2 into here I can take only 3 and root 7. So it is 6 root 7. BC is equal to 6 root 7. So the other end of the wire is 6 root 7 meters from the feet of the pole. Question number 11. So an aeroplane leaves an airport and flies due north at speed of 100 km per hour. At the same time, another aeroplane leaves the same airport and flies due west at a speed of 120 km per hour. How far apart will the two planes after 1.5 hours? So now there is one aeroplane going in the north direction, okay, and there is another aeroplane going in the west direction. See, for the first aeroplane, the speed is 1000 kilometers, 1000 kilometers per hour. So what is the meaning of this one? It means in 1 hour it will travel a speed of 1000 kilometer. So in one hour it will travel a speed of 1000 kilometer. So therefore in 1.5 hour, how much it will travel? So if I convert this 1.5 into improper fraction, 2 1s are 2 plus 1 3. So in 3 by 2 hour it will travel into 1000. 2 1s are 2, 2 5s are 10, so 3 5s are 15. So in 1.5 hour it will travel a distance of 1500 kilometer. So after 1.5 hour, so that plane is at a distance of 1500 kilometers from the airport. Now in another aeroplane, speed is 1000, how much is that? 1200 kilometers per hour. So that means in 1 hour it will travel 1200 kilometer. So in 1.5 hour, or 3 by 2, in 1.5 hour, how much it will travel? So here it becomes 3 by 2. Here also same thing. I'll convert 1 by 2 into improper fraction. 2 1s are 2 plus 1 3. So 3 by 2 into 1200. So 2 1s are 2, 2 6 are 12, 600, 3 6 are 18. So in 1.5 hour time it will travel a distance of 1800 kilometer. So this is second aeroplane is at a distance of 1800 kilometer from the airport. Let this be B. Now I'll join these two. Let this be O. So here these two airplane makes an angle of 90 degree from the initial point. Okay, so 90 degree. Therefore this is a right angle triangle. Now what is the distance between these two airplanes? That's the question. How far apart will these two planes be after 1.5 hours? Now clearly AB will be that distance. Okay, now AB square is equal to AO square plus BO square. AO is 1500 square plus BO is 1800 square. So 15 into 15, 5 5 is 25, 5 1 is 5. 5 1 is 5, 6 7 75, 1 5 is 5, 1 1 is 1, 5 12. So 225 00 plus 1800. Now what is 18 into 18? 18 into 18 is 8 8 is 64, 8 1s are 8, 9 10 14. So 1 8s are 8, 1 1s are 1. So 4 8 9 10 12, carry 1, 3 324. So 324, so 324 00 I'll get. So when I square, here 2 zeros were there. When we make square, it becomes 4 zeros. Okay, in both the cases. So this plus this, 324 plus 225, 9, 320. This is 4, 5, 549. So 549 00. This is the AB square. Therefore AB will be square root of this thing, square root of 549 00. So factorize now. 549 00. It is divisible by 5. 5 1s are 5, 5 0, 5 9s are 45, 5 8s are 40, 00 00. 5 8s are 40. So sorry, 3 zeros will come here. Now 5 again, it is divisible by 5. 5 2s are 10, 5 1s are 5, 5 9s are 45, 5 6 are 30. Here 2 zeros will come. 5 4s are 20, 5 3s are 15, 5 9s are 45, 5 2s are 10 0. 5 8s are 40, 5 7s are 35, 5 8s are 40, 5 4s are 20. Now it's not divisible by 5. Divide by 2. 2 4s are 8, 2 3s are 6, 2 9s are 18, 2 2s are 4. Then 2 2s are 4, 2 1s are 2, 2 9s are 18, 2 6 are 12, 2 1s are 2, then 2 9s are 18, 2 8s are 16. Then it's again it's divisible by 2. 2 5s are 10, 2 4s are 8, 2 9s are 18. Then this is not divisible by 2. This is an odd number. So I'll divide by 3. I'll check it. 3 1s are 3, 3 8s are 24, 3 3s are 9. Then 3 again check. 3 6 are 18, 3 1s are 3. Now 61 is a prime number. It's not further divisible. So if I make group of 2 2 2, this is a 2 group, then 2, then again 2 2 2. So I'll write like this only. 5 into 5, there are altogether 4 5s into 2 2s or 4 2s, 2 into 2 into 2 into 2, 3s or 2 times plus into 61. So I can group like this, 5 5, make a group of 2 2 like this 3 into 3. So from this I can take out 1, I can take 1 5, and again from here I can take 1 5, here from here 1 2 I can take, then here 1 2. So this is equal to 5 into 5 into 2 into 2 into 3. So root 16 remains as it is into root 61. So 5 5 is a 25, 25 2 is a 50, 52 is a 100, 100 3 is a 300. 300 root 61 is the answer. So the aeroplane are 300 root 61 kilometer apart from each other after 1.5 hours. Let us see the answer. So question number exercise 2.5, question number 11, 300 root 61, we have got the right answer. Question number 12, two poles of height 6 meter and 11 meter stand on a plain ground. If the distance between the feet of the pole is 12 meters, find the distance between their tops. First read the question, understand the question, and then only you proceed. Without understanding the question, if you proceed, it's of no use. You won't get right answer and you will be wasting time. So there are two poles. One pole is 6 meter height, another pole is 11 meter height. This is 6 meter, this is 11 meter. I'll mark this A, B, this I'll mark C, D, and these two poles are the distance between the feet of the pole is 12 meter. This is 12, BC is 12 centimeter. Sorry, all are in meter. Okay, 12 meters. Find the distance between their tops. I should find the distance between their top. What is AD? That's the question. So here, since the poles will make an angle of 90 degree on the ground, right? So that means these two poles are parallel to one another. So that means they are equidistant. So now if I draw from A, if I draw a perpendicular, I'll mark this E. So since the distance between the feet is 12 meter, therefore AE also will be 12 meter. Since these two poles are parallel, at any point of the pole, if you take the distance, it will be 12 meters only. Now CE also will be 6 meters, because AB will be parallel to EC. Okay, this is 6 meter, the pole length is 11 meter. Now I should find AE. So it's a very simple problem. Now what is DE? DE is equal to CD minus EC. So this is 11 minus 6. So this is 5 meter. So this D is 5 meter. Now AD. Now here AE and DE also, they make an angle of 90 degree. Now AD square is equal to AE square plus DE square. So AE square is 12 square plus DE square is 5 square. So this is 12 into 12 is 144 plus 0.5, 25. So this is 169. So AD square is equal to 169. Therefore AD will be equal to square root of 169. Therefore AD is equal to 13. Square root of 169 is 13. Let us check the answer. So exercise 2.5, question number 12, 13. We got the right answer. You can add another sentence. The distance between top of the poles are 13 meter. Now question number 13. D and D are points on the sides CA and CB respectively of a triangle ABC right angled at C. Right angled at C. Prove that AE square plus BD square is equal to AB square plus DE square. So there is a triangle right angled at C. So let it be A, B, C. According to the question, the right angle is at C, and they are given D are the points on sides CA and CB. So this is D, and E, there is a point E on BC. D and E are the points on sides CA and CB respectively of a triangle right angle at C. Prove that. So I'll join these two. So I should prove that. So data is ABC is a right angled triangle right angle at C. So that means angle C is equal to 90 degree. So we should prove that. Prove that AE square plus BD square is equal to AB square plus DE square. This point is E, so I'll join this BD and AE. Now what is so in triangle AEC, what is AE square? So this is a right angle triangle, therefore AE square is equal to EC square plus AC square. Similarly, in triangle BCD is a right angle triangle. So in triangle BCD, BD square is equal to BC square plus CD square. So square on the hypotenuse is equal to the sum of the square of the other two sides. Now this I'll mark 1, this I'll mark 2. I'll add 1 and 2. 1 plus 2 gives. So add the left hand side to the left hand side and right hand side to the right hand side. Therefore AE square plus BD square is equal to, so in the right hand side EC square plus AC square is there, and again from equation 2 BC square plus CD square. In the right hand side you can see that AC square plus BC square. AC square plus BC square is equal to AB square, and also EC square plus CD square. The remaining is EC square plus CD square, that is equal to ED square. So AE square plus BD square is equal to AB square plus ED square. This is what required. Question number 14. The perpendicular from A on side BC of a triangle ABC intersect BC at D such that BD is equal to 3CD. Prove that 2AB square is equal to 2AC square plus BC. So figure is given. So there is a triangle ACB and AD is perpendicular to it. So AD is perpendicular, so that now ADB is a right angle triangle, and similarly ADC is a right angle triangle. So given data is ABC is a triangle and and AD is perpendicular to BC. We should prove that 2AB square is equal to 2AC square plus BC square. So, and also the given data, another data is given, that is DB is equal to 3CD. So that also I'll write here. DB is equal to 3 times of CD. Now I'll consider to prove AB square is equal to 2AC square plus BC square. I should prove left hand side is equal to right hand side. First I'll take left hand side. Left hand side is given as 2AB square. So 2AB square is, ABD is a right angle triangle, therefore AB square is equal to AD square plus BD square. So this is 2AD square, we don't know, I'll keep it as it is. BD is given as 3CD the whole square. So this becomes 2AD square plus, now 3 3s are 9CD square. Now I'll open the bracket. So 2 into AD square is 2AD square plus 2 9s are 18 CD square. So I'll mark this as 1. Now I'll take the right hand side. So right hand side is given as 2AC square plus BC square. So this is equal to, now ACD is a right angle triangle, therefore to AC square I can write as CD square plus AD square plus, now BC is also CD plus DB, CD plus DB the whole square. So BC square is equal to CD plus BD the whole square. So now I'll open the bracket here. 2 into CD square is 2CD square plus 2 into AD square is 2AD square plus, now here in CD as it is, DB is equal to 3 times of CD. So I'll write like this, the whole square. Now 2CD square plus 2AD square as it is plus CD plus 3CD is 4CD the whole square. Now 2CD square plus 2AD square. So this becomes 4CD into 4CD is 16CD. 16CD square. Now here this I can add 2CD and 16CD. 2CD plus 16CD is 18CD. 18CD the square. 2AD will be as it is, 2AD square. Now you can check 1 and 2 is same. So from 1 and 2, LHS is equal to right hand side. Left hand side is equal to right hand side. Question number 15. In an equilateral triangle ABD, D is a point on side BC such that BD is equal to 1 by 3 BC. Prove that 9AD square is equal to 7 AB square. So there's a triangle AB. See, ABC. So this is an equilateral triangle, therefore all sides are equal, and D is a point on BC. So there's a point on BC, and such that BD is equal to 1 by 3 of BC. So this part, this length is 1/3 of BC. Prove that 9AD square is equal to 7AB square. So given data is ABC is a equilateral triangle. Okay, to prove that, so there's one more data here. D is a point on BC, and BD is equal to 1 by 3, 1/3 of BC. So I should prove that 9AD square is equal to 7AB square. Now in this triangle, since this is an equilateral triangle, all sides will be equal. So I'll take all sides as A unit, A, and I'll take this as A. Now I will draw a perpendicular from A to BC, and I'll call it as point E. I'll call it as AE, and E is a point on BC. So first one is proof. First, draw AE perpendicular to BC. Now in the figure you can see that BD, see BD is equal to, it is given data, it's 1/3 of BC. So now BC I have taken as A, all sides are equal to A I have taken. So 1/3 of BC means 1 by 3 into A, or A by 3. BD is equal to A by 3. Now what is DA? So before that, what is B? B is equal to half of BC. B is equal to half of BC. Therefore this becomes half of A, or A by 2. B becomes A by 2. Then what is D? D is equal to half of B. D is equal to half of BE. So that means D is equal to, it's not half of B, D is equal to B minus BD. So what is B? B is half of, so B already I found it is A by 2. A by 2 minus BD. BD it is given as A by 3. So D becomes, here LCM if I take, it is 6. So 3A by 6 minus 2A by 6. All right, here LCM is 6. So this is 3A minus 2A by 6. So 6, 3A minus 2A, so it is 1A, or A by 6. So my D is equal to A by 6. Now I will write everything here. BD is equal to A by 3. This is BD is equal to A by 3. Then D is equal to A by 6, then and B is equal to A by 2. And what is AE? So what is AE? I have still not calculated. I am calculating here now. So what is AE? Now since AE is perpendicular to BC, ADE is a right angle triangle. Therefore now take triangle ABE. In ABE, in triangle ABE, A is perpendicular to BE. Now here the square of the hypotenuse, that is AB square, is equal to BE square plus AE square, right? So AB square is A square. B square is equal to B square. B square I just now found. B is A by 2, the whole square, plus AE square. Therefore A square, I'll bring this to the left hand side. A square minus A square by 4, 2 2s are 4, is equal to AE square. Now if I simplify this, taking LCM, it becomes 4 is the LCM. So 3 AE becomes 3A square by 4. AE square is equal to 3A square by 4. So I am writing that one here. AE square is equal to 3A square by 4. Now I should prove that 9AD square is equal to 7AB square. So what is 9AD square? 9AD square is equal to 9 as it is, all right. AD square. So AD square is equal to D square plus AE square, right? So AD I am expanding. Sorry, AD is the hypotenuse. So hypotenuse is equal to sum of the square of the other two sides in triangle ADE. So AD square is equal to 9D square plus AE square. So 9 as it is. DE square, D I got, it's A by 6, right? So A by 6 the whole square plus AE square, it is 3A square by 4. So how much I'll get? 9. So this is A square by 36 plus 3A square by 4. So this is equal to 9. So if LCM is 36, so this is A square plus, so 4 9s are 36. So 9, I'll write separately so that you can understand. So here this becomes 36. I am taking LCM, so numerator becomes 9 3s are 27. So it is 27A square. So this becomes 9, 36 common, then it becomes 28. A square plus 27A square is 28A square. Now 9 1s are 9, 9 4s are 36. 9 4s are 36, 4 1s are 4, 4 5s are 20, 4 6 are 20, 4 7s are 28. I'll get 7A square. So 9AD square is 7A square. Now I'll check what is 7B square. 7, I'll mark this as 1. 7AB square. So 7AB square. Oh, this itself is 7a square itself is 7ab square. See, this 7 as it is a square. A square is also equal to ab square. So my left hand side is equal to right hand side. So left hand side is 9ad square, which I got as 7a square. 7a square is also equal to 7ab square, because the length of AB is A. So in place of AB, if I put A, I'll get 7a square. So my left hand side is equal to right hand side. Question number 16. In an equilateral triangle, prove that 3 times the square of one side is equal to 4 times the square of one of its altitudes. So I'll draw equilateral triangle. So in an equilateral triangle, all sides will be equal. So A, B, C, and I'll draw AD perpendicular to BC. Now I'll assume all these sides are equal to 2 centimeter or 2 units. So and here BD will become 1 and 1, because in an equilateral triangle the height or the perpendicular drawn from one vertex divides the opposite side into 2 equal parts. So BD will be 1 and DC will be 1. Now they are telling to prove that, suppose if I make a square on side BC, okay, I'll draw a square making BC as the base. Okay, I'll call this A, B, C, D, E, F. So ABEF is a square. Now since this is a square, all sides will be equal. Since AB is the base, sides also will be equal to same thing, 2, 2, 2, because in a square all the sides are equal. And I'll draw another square making AD as the base. Now here in this triangle, what is AD? See, AD, now here angle D is 90 degree. So ABD is 90 degree. Therefore AB square is equal to BD square plus AD square, right? So in triangle ABD, so AB is 2, so 2 square is equal to BD is 1 square plus AD square. Therefore 4, 2 square is 4 is equal to 1 square is 1 plus AD square. So if I bring this one to the left hand side, sign will change. So 4 minus 1 is equal to AD square. 3 is equal to AD square. Therefore root 3 will be root 3 is equal to AD. So my AD will be root 3. So making AD as the base, I'll draw another square such that all sides are okay. I'll draw a square. Now here all sides will be equal in a square. So AD, EFG, okay, I'll call this PQ. Now AD PQ is a square with AD as the base. So therefore all sides will become root 3. Now in the question, first let me write the data. ABC is a equilateral triangle. And okay, equilateral triangle, and I should prove that triangle, sorry, square, area of square ABEF, area of square ABEF is equal to in an equilateral, prove that 3 times the area of square of one of its side. So prove that 3 times the area of square ABEF is equal to 4 times the area of square of one of its altitudes. That means this is equal to 4 times area of circle, sorry, area of square ADPQ. 3 times the area of square ABEF is equal to 4 times the area of ADPQ, I should prove. So proof. So assumption already I have made. I'll write here. Let AB is equal to BC is equal to AC is equal to 2 units. Length of each side is 2 units. So because of this we got AD is equal to root 3. AD the height of the triangle, root 3 I got, and the side of that square became root 3. Okay, so I assumed AB is equal to BC is equal to AC is equal to 2 units. Therefore sides of square ABCD are 2 units each. Okay, that is AB is equal to BE is equal to EF is equal to AF is equal to 2 units. So because I took AB is equal to BC is equal to AC is equal to 2 units, AD became root 3. Therefore sides of square ADPQ are root 3 units. That is AD is equal to DP is equal to PQ is equal to AQ is equal to root 3 units. Okay, now I'll check what is 4 times into area of triangle, area of square ABEF. 4 times of area of square of ABEF is equal to 4 into what is area of square ABEF? Area of square is given by side into side, base into height. So that is base is 2, height is 2. Okay, that is 4, 2 2s are 4, 4 2s are 8, so 8. So 8 square units is the area. Next, now I'll mark this as 1. I'll check what is 3. Sorry, I should check 3 into area of square ABEF. So this is 3 into 2 into 2. Now 2 2s are 4, 4 3s are 12. I'll get 12 as the answer. Now I'll check what is 4 into area of square ADPQ. So this is equal to 4 into square. Now area of this square is given by side into side again, that is root 3 into root 3. So 4 root 3 into root 3 is 3. 4 3s are 12. So 1 is equal to 2. So it means 3 times into area of square ABEF is equal to 4 times this area of square ADPQ. ABF is the square formed on one of the sides of the triangle, and ADPQ is the square formed on altitude of triangle ABC. Therefore 3 times the area of square formed on one of the sides of equilateral triangle is equal to 4 times the area, 4 times the area formed on 4 times the area of the square, 4 times the area of the square formed on one of its altitude, on one of its altitudes. Here in this proof, I assumed length of the equilateral triangle to be 2 units, 2 units, 2 units, and I proved it. You can assume any length. It's not necessary to assume only 2. Okay, you can assume it is 4 or it is 5, it is 10. You can assume any length and you can prove, or else generally you can assume that length is 2a. Even if you take the triangle like this, and if you put ABC, if you put each side as 2a, 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 then and put if AD is perpendicular, then this becomes A and A. If you go in this way, then also you will be able to prove. Instead of 2a, I have taken I have taken just 2. I have taken a numerical value. You can take any numerical value. Also, you can take any number or any unknown number, just like 2a. Question number 17. Tick the correct answer and justify. In triangle ABC, angle AB is equal to 6 root 3, AC is equal to AC is equal to 12 centimeter, and BC is equal to 6 centimeter. The angle B is. So I'll roughly draw the triangle. So A, B, C, given AC is equal to 12 centimeter, AB is equal to 6 root 3 centimeter, and BC is equal to 6 centimeter. So using sides, we can't find the angle of A, B or C. We cannot find it, but using sides we can check whether it's a right angle triangle or not. So to check, I'll choose the highest side. Highest side is 12 centimeter. Okay, so I'll square the highest side. So AC square is equal to 12 square. So 12 into 12, I'll get 144. 144. Now I'll check the I'll find the sum of the square of the other two sides. I'll check AB square plus BC square. This is equal to 6 root 3 the whole square plus 6 the whole square. So this is 6 root 3 into 6 root 3 plus this is 6 square. 6 square is 6 into 6. 6 into 6 is 36. So here 6 root 3 into 6 is root 3. 6 into 6 I'll get 36. into root 3 plus 36. So 36 root 3 into root 3 is just 3. That square root symbol will vanish. Plus 36. So 36 into 3. 3 6 are 18. 3 3s are 9 plus 1 10 plus 36. So this is 6 6 12 13 14. 14 carry 1. 1 plus 3 is 4. So 1. So this is AB square plus BC square. So first one I will mark as 1 and this as 2. Now we can see 1 is equal to 2. So 1 is equal to 2. So what it means? The square of one side is equal to the sum of the square of the other two sides. Therefore the given triangle must be a right angled triangle. So square of AC square is equal to AC square is equal to AB square plus BC square. The square of one side is equal to sum of the square of the other two sides. Therefore ABC should be a right angled triangle. According to which theorem? According to theorem 2.9. If the square of one side is equal to sum of the square of the other two sides, then the given triangle is a right angled triangle. Therefore triangle ABC is a right angled triangle. And where is the right angle? Right angle will be opposite to the highest side. So here angle B is opposite to highest side, that is AC is the highest side. So it's opposite to angle B is opposite to the highest side. The highest side will be the hypotenuse, because we got hypotenuse square is equal to sum of the other two sum of the square of the other two sides. Therefore angle B is equal to 90 degree, and actual figure will be like this. A B C, this is 6, this is 6 root 3, this is 12. So before solving I did not know the angles. I just drew a rough diagram. Now after knowing angle B, I drew the exact drawing like this. And now that completes this problem and this exercise. Next there are some optional exercise. This is beyond your scope, but still they are given. This is just for your understanding. You can try by yourself, but I don't think so it will come for the exam. Then next is summary. So in this chapter you have studied the following points. Two figures have the same shape but not necessarily the size or similar figures. All the congruent figures are similar, but converse is not true. Two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. If a line is drawn parallel to one side of a triangle to intersect the other two sides at distinct points, then the other two sides are divided in the same ratio. So point 4, this is which theorem? This is theorem 2.1. This is the first theorem which we learnt in this chapter. If there is a triangle like this ABC, and if we draw a line parallel to one side, supposingly we draw a line parallel to BC, such that it cuts AB at D and it cuts AC at F, then the other two sides are divided in the same ratio. That means if BC is parallel to DF, then AB by BD is equal to AC by CF. This is what we learnt in theorem 2.1 of this chapter. Next is, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So fifth point, so if there is a triangle like this, and if you draw a line dividing two sides proportionally like this, if you draw, suppose I draw DE such that AD is equal to DB is equal to AE by EC, then DE is parallel to BC. So this we learnt in theorem 2.1, sorry, theorem 2.2. okay, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So if DE divides such that AD by DB is equal to AE by EC, then D will be parallel to BC. Next point, point number 6. If in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio, and hence the two triangles are similar. So if there are two triangles, suppose ABC and DEF, suppose if angle A is equal to angle D, angle B is equal to angle C, and angle C is equal to angle F. Okay, if A is equal to angle D and B is equal to angle E, and angle C is equal to angle F, then the sides will be proportional. AB by DE is equal to AC by DF is equal to BC by EF. So this is also theorem number 2.3, theorem 2.3, which we studied in this chapter. So if in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio, and hence the two triangles are similar. This is also known as AA criteria. AA criteria of similarity of two triangles. Point number 7. If in two triangles, two angles of one triangle are respectively equal to two angles of the other triangle, then the two triangles are similar to each other. So it's not necessary that all the three angles of one triangle should be equal to all the corresponding three angles of the other triangles to be similar. Even if two angles of one triangle are equal to corresponding two angles of the other triangle, then they are similar. If this angle A, B, C, D, E, F, if angle A is equal to angle D and angle B is equal to angle E, even if these two angles are known, then also these two triangles are similar. So if A is equal to angle D and angle B is equal to angle C, then the sides will be proportional, and hence the two triangles are similar. Then AB by DE is equal to AC by DF is equal to BC by EF, and these two triangles will be, and hence these two triangles will be similar. So for this also it's the same theorem, theorem 2.3. Theorem 2.3, this is AA criteria. AA criteria of similarity of two triangles. Next is point number 8. If in two triangles corresponding sides are in the same ratio and their corresponding angles are equal, and hence the triangles are similar. So if there are two triangles ABC and DEF, ABC and DEF, and if it is known that if AB by DE is equal to AC by DF is equal to BC by F. If in two triangles these two this condition, if this condition is satisfied, then the corresponding angles also will be equal, and hence these two triangles will be similar. Then angle A is equal to angle D, so and angle B is equal to angle E, and angle C is equal to angle F. This is nothing but theorem 2.4 which we studied. Theorem 2.4, also known as side criteria of the similarity of two triangles, SSA rule. Okay, if in two triangles the corresponding sides are proportional, then those two triangles will be similar, and hence the sides will be, and hence all the corresponding angles will be equal. Next, point number 9. If one angle of a triangle is equal to one angle of other triangle and the sides including these angles are in the same ratio, then the triangles are similar. SAS criteria, they are given in the point itself. So not necessary that if all the three sides are known to conclude that they are similar. Even if two sides are known with an included angle, and such that two sides are proportional and one angle including that side is equal, then then the two triangles are similar. Suppose in these two triangles ABC and DEF, only if AB by DE is equal to BC by EF. Okay, only if two sides are proportional and the included angle of these two sides are equal. Suppose angle B is equal to angle C, angle B is equal to angle B is equal to angle E, then these two triangles are similar. Then triangle ABC is similar to triangle DEF. So this we learnt in theorem 2.5. Theorem 2.5, also known as side angle side rule of criteria for similarity of two triangles. So that means one angle will be equal to another angle of the triangle, and the sides corresponding to those angle, and the sides of those angle is proportional to the corresponding sides of the other triangle. Then those two triangles will be similar to one another. Next point is point number 10. The ratio of areas of two similar triangles is equal to the square of the ratio of their corresponding sides. So point number 10. So if two triangles are similar, ABC, DEF, so if triangle ABC is similar to triangle DEF, then area of ABC, area of triangle ABC by area of triangle DEF is equal to the ratio of the square of the sides. That means AB by DE the whole square is equal to AC by DF the whole square is equal to BC by EF the whole square. These two triangles are similar, and therefore corresponding sides will be proportional. So and then the ratio of the area will be equal to ratio of the square of the corresponding sides. So this we learnt in which theorem? In theorem 2.6. Theorem 2.6. Next point is point number 11. So if a perpendicular is drawn from the vertex of a right angle triangle to the hypotenuse, then the triangles on both sides of the perpendicular are similar to the whole triangle and also to each other. Suppose if there is a right angle triangle like this, A, B, C, and if angle B is right angle, and if I draw one perpendicular from the vertex of the right angle and let that intersect the hypotenuse D, then according to this point the three triangles formed, triangle ADB, triangle ADB is similar to triangle BDC is similar to triangle ABC. This proof we studied in theorem 2.7. Theorem 2.7. Next point number 12. In a right angle triangle, the square of the hypotenuse is equal to sum of the square of the other two sides. This is nothing but Pythagoras theorem. So A, B, C. In any right angle triangle, square of the hypotenuse, here AC is hypotenuse, AC square is equal to AB square plus BC square. And point number 13. Point number 13 is opposite of converse of the point 12, that is converse of Pythagoras theorem. So what it says is, if in any triangle suppose ABC, so let me read out what's there in that point. If in a triangle the square of one side is equal to the sum of the square of the other two sides, then the angle opposite to the first side is a right angle. If in any triangle, if square of one side, that is supposingly if here in this triangle AC square is equal to AB square plus BC square, then angle B will be equal to 90 degree. So if the square of one side of any triangle is equal to the sum of the square of the other two sides, then the angle opposite to the first side is a right angle. Point number 12 in your this is theorem number 2.8 or Pythagoras theorem. Or theorem 2.8. And point number 13 is nothing but your theorem 2.9 or converse of Pythagoras theorem. Or theorem 2.9. Theorem 2.9 in this text. Now you know the difference between congruent figures and similar figures. See, in any polygon, congruent figures or congruent polygon, similar polygon. So two polygons are said to be congruent if corresponding angles are equal, and also corresponding sides also equal. But two polygons are said to be similar if corresponding angles are equal but corresponding sides are proportional. So the point number 3 in summary says that two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. Two polygons are said to be congruent if their corresponding sides are proportional and corresponding angles are equal. Now consider two triangles ABC and PQR. So let they be equilateral triangle. Therefore each angle will be equal to 60 degree. 60 degree. So since they are equilateral triangle, each side will be, all the sides will be equal. So let there be 1 unit, 1 unit, 1 unit, 1 unit, 1 unit. So now these two triangles are congruent. Now if you check the ratio, it's a special case. Now if you check the ratio, AB by PQ is equal to BC by QR is equal to AC by PR. If you will get ratio 1 by 1, which is equal to 1. So in congruent triangles the sides are equal. That's why if you take the ratio you will get 1. But if two triangles are similar, the ratios will be different. Only in congruent triangles or in congruent polygon, the ratio of the sides will be 1. If the polygon is not congruent, but if it is similar, then the ratio will be greater than 1 or less than 1. For example, you see here LMN. Suppose this is also equilateral triangle, but let us say the sides are 2 centimeter, 2 centimeter, 2 centimeter, or 2 unit, whatever you say, but they are equal. Now if you take the ratio, for example, now PQ by L, let this be N, okay, PQ by Ln is equal to QR by Nm is equal to PR by Lm. This will be equal to 1 by 2. See, if two polygons are similar, the ratio of the corresponding sides will be less than 1 or greater than 1. But if two polygons are congruent, then the ratio of the sides will be equal to 1. You can see point number 2 in summary. All the congruent figures are similar, but the converse is not true. Congruent polygons also are similar, but similar polygons may not be congruent.